This is a paper I'm preparing for publication.
Okay.
The change of climate has caused a lot of scarcity of water. The World Health Organization predicts that at least one person dies every 26 seconds due to waterborne diseases. 90% of the 2.3 million people that die due to waterborne diseases come from developing countries, where most of us come from. 80% of these deaths are innocent infants. Because of these challenges, a lot of research has been on water purification system, which has yielded effective water purification systems such as reverse osmosis, ultrafiltration. However, these filters are too costly for the developing world. It is because, and then ceramic water filters, which will have addressed the issue of cost, are brittle and insensitive in removing viruses. It's because of these challenges that we have fabricated diatomaceous earth-based ceramic filter, which comprises both a nano property and the bulk property of ceramics. We have been able to improve the ceramic water filter using diatomaceous earth waste and diatomaceous itself, and also the organic binders from local weeds. Just before we go, we go to the main discussions, it's good to really understand why we are looking at this topic. And it is mainly because our work was to improve the properties, mechanical properties of ceramic water filters. And we have published a paper in that, but in this paper we are trying to really look at the relationship on mechanical property and porosity. How do they relate to each other, and at which point are they really good to balance and be able to give us a better membrane. And there are so many discussions that have been going around between mechanical properties, relationship with porosity. And in this work, we are mainly looking at modulus of rupture and porosity relationship. And the discussions around this topic have involved both theoretical and experimental researchers. The literature is divided into two schools of thought. There are those who argue that the minimum solid area affects the MOR of the ceramic material, also referred to as minimum solid area model. There are those researchers who argue that MOR depends on the pore shape and the stress concentration that these pores cause in the ceramic material. Equation 1 shows how MOR, symbolized as a delta, in a relationship with the porosity, where delta naught is the MOR of a full dense material, which is really hard to get, and P is the porosity of the material. Equation 1 is only valid for isentropic materials. Equation 1 is only valid for isentropic materials in which pores, solid phase, and the applied stress do not change with change in porosity. In equation 2 and 3, alpha is the aspect ratio in the complete elliptical integral that stands for a function of a complete elliptical integral. Equation 2 represents the B values of the randomly distributed pores on the isentropic material, and equation 3 represents uniformly distributed pores on an isentropic material. However, this model fails to fulfill the boundary conditions at delta is equal to 0 and delta is equal to 1, and is only valid for ceramic materials with open porosity of around 45%. In order to address these challenges, the stress concentration effect model was developed. And this model actually explained the relationship between mechanical property and porosity also. In this model, the relationship between MOR and porosity depends on the pore shape, pore distribution, and the resulting stress concentration as given in equation 4, where nu is the numerical value of that represents the pore shape and the orientation of the axis with respect to Poisson's ratio, and is given by equation 5. The fraction z over x stands for the aspect ratio and is defined to mean the mean pore. Theta is the angle between the axis of the rotation and stress direction. Thus, cos squared theta represents the orientation factor, and for isentropic material, this factor is 0.33. In deriving equation 4, Boccaccio adopted a two-phase porous composite ceramic material with several pores. The two phases comprise of the spheroidal pore phase and the continuous matrix phase. The model also assumes that the pores are spheroids and the pore size was invariant in equation 4, and satisfy the equation, the boundary conditions at delta is equal to 0 and delta is equal to 1. Thus, the role of MOR on the influence of porosity cannot be determined without considering pore geometry in a stress concentration model. To address the pore shape and the orientation effect, the self-consistent scheme theory was put forward. In self-consistent theory, the pores were considered to be randomly placed in an isentropic material. The pore shape was considered sphere-like, depending on the value of alpha. Pores with alpha is equal to 1 were considered as oblates, and pores with the alpha close to 0 were classified as spheres. In studying the aspect ratio and porosity relationship, Fan found out that the two were dependent, and the sintering process was an important factor. Due to their dependence on sintering parameters, Martin and colleagues suggested that the aspect ratio porosity relationship can be considered at each data. He found out that alpha increases with an increase in porosity up to P is equal to 5%, beyond which alpha decreases drastically. However, all these things are happening in clay materials, which don't have original pores. As we know, a diatom by its nature has nanopores and even micropores. So it is already an uniform material. So, and the normal clay doesn't normally have its own pores, apart from the pores, interparticle pores that come with it. And maybe when we introduce the external pores by a burnout material. So it is because of this reason we're trying to see which really works for this material in a diatomaceous material. We want to really look which model works for it. And if it works for it, how do we balance it to make a stronger material? So to do that, we used diatomaceous material, diatomaceous earth, different types. That was diatomaceous. We called it diatomaceous earth 1, diatomaceous earth 2, and diatomaceous west. Diatomaceous earth 1 is a diatomaceous material that is not very old. It's just a few million years old. So it still has the pores. Diatomaceous earth, that one was called diatomaceous earth A. So diatomaceous earth B was far much older fossil, which is normally used in thickening of the painting. So we also looked at it. And then we looked at the west, where the company doesn't also use at all. So we then ground these diatomaceous to nanoparticles, and then mixed it with a locally fabricated binder. And this binder, we made it from Cochlearis solitaris, locally known as Miranda. So we got the list.
5 minutes more.
So when we made the membranes, we then looked at their pores and its characteristics. So let me just go to the results so that I'm not caught up with time. So we found out that in the figure 3.1 that our diatomaceous earth A, that's a pure diatomaceous model, diatomaceous earth A was able to, our data was able to fit that model better. And this can be attributed to the fact that porosity in the this can be attributed to the fact that porosity in the 3 diatomaceous earth was less than 40% and 5%. Such material favor a minimum stress concentration area model, just as predicted in literature. The failure of stress concentration model can be attributed to the pore size of diatomaceous base membranes, which have pores in nanoscale, as shown in figure D. The solid phase surrounding the pores is bigger than the pore in size. The pore size. Thus, there is no stress in homogeneity in the load-bearing area. And table 3.1 shows the values of the constants B and null used in fitting MCA and the MCA models, MSA models. The statistical values of R squared and the Pierce correlation are obtained after fitting. The models are shown. The values of B range between 3.5, 2.9, and 4.2 for diatomaceous A, diatomaceous B, and diatomaceous earth waste. These values were similar to those in literature. Diatomaceous B showed the lowest value of B, which can be attributed to the broken diatomaceous pores and different species of diatoms because of the old age of the fossil. Such variation also resulted in different structure of pores from the rest of the membrane. A similar value was found by Coble and Kingery, who found out that the values of B as 2.5. The constant B in diatomaceous earth waste was the highest of value of B, and this could be attributed to the elemental composition of this material, which we reported earlier in our earlier work. Diatomaceous A had the lowest value of B, which can be attributed to its continuous nanopores. The values of B obtained by the 3 samples were within the accepted limits 2 to 9 according to literature, and the difference is associated with the pore structure and variation. The low values of diatomaceous A and diatomaceous B are attributed to the high porosity in this material, and high values of B in diatomaceous earth waste was caused by high densification. The values of nil varied from 2.8 for diatomaceous A and 2.4 for diatomaceous B, and 3.5 for diatomaceous waste, and were less than those found by Nyongesa and Aduda, who found the values of null as 3.5. And Kingery was found his own as 2.5. Low values of null are attributed to extrusion and unaxial pressing used in preparation of this material. The values of R squared and Pearson correlation confirms that MCA model gives B the best fits as characterized by the higher values of R squared and R. Pearson's correlation were negative, further affirming that the inverse relationship between strength and porosity. The values of R and R for MSA were all less than 0.9, indicating that the fits were not good and highly uncorrelated. Figure 3.2 shows the plot of relative strength against volume fraction of the membrane from the mixture of diatomaceous A and charcoal, and 10%, charcoal at 10%, and their respective micrograph are also shown as obtained from the membranes fired at 900 degrees Celsius. It also the MCA model fitted better than the SCE model in the membrane fabricated with 5% charcoal. The values of, however, reduced from 3.5 to 2.5. This change is attributed to increased porosity in the material and reduced densification. The membrane with 10% charcoal, however, fitted more in SCE model due to its high porosity. Large pores, that's around 10 micrometers, were also uniform. The large pores in the membrane acts as sources of failure, and the presence of nanopores from diatomaceous causes inhomogeneity in the pore size and shape in this membrane. The micrograph in figure 3.2b shows pores both in a nanoscale and a microscale. That's why the failure was high. Figure 3.2 also shows that's figure 3.3, yes, shows the pie chart of a number of occurrence against aspect ratio of membrane of porosity 0.12, 0.18, 0.22, and 0.28 for pure diatomaceous A. Pure diatomaceous B and pure and diatomaceous earth waste. It is observed that the sintered diatomaceous earth had all forms of pore shapes as predicted by literature. However, these shapes vary in number. That is, some shapes occurred frequently than others. There was no difference in aspect ratio when the axes were interchanged, implying that orientation of pores will not affect the porosity, just as it was also found by literature. Again, aspect ratio
can we go to your conclusion? Your time is up.
Please. Yes, I'm concluding. Again, okay. Aspect ratio of around unity that and 0.5 was one to be most preferred by non-diatomaceous pores. Similar results were also found by porcelain. The sphere-like and oblate-like porosities were caused by the cylindrical diatoms that characterize the micrographs of the preceding sections. Most of the nano spherical pores, however, causes reduced porosity and at the same time increased porosity. At the same time increases the porosity occurrence. The aspect ratio of 0.1 to 0.3 and 0.6 to 0.5 was also a common occurrence. Thus, we can conclude and say that porosity MOR relationship of pure diatomaceous earth membrane fitted the MCA model against the SCE. The SCE model fitted well in the mechanical strength porosity relationship of highly porous, that is porosity more than 0.3. Diatomaceous earth membranes and MCA fits well in less porous material, that's 0.3. Diatomaceous, that is 0.3 diatomaceous membranes. The diatomaceous earth membranes is mainly made of spherical shaped nanopores, and therefore with such we will be able to get a strong membrane that will not be brittle as the current membranes. Thank you.
Thank you very much for your presentation, Miss Mary Simiyu. The floor is now open for questions. Please, I will be taking questions from like 2 to 3 people because of the time. Please, if you have questions, kindly raise your hands, and then so we can take your questions. I can't see any hands raised yet. Any questions? Okay. While questions are coming, if you also can't raise your hand, you can type a question. You can read from the panel here directly. Mary, I have a few questions. Can you hear me?
Yes, I'm listening.
Okay.
Yes,
What exactly is the concern about this? Is it the scarcity of water or the purification of water? Climate change has made probably the amount of rainfall we have in certain regions of the world to have changed from what we used to know. So our expectations are not met anymore somehow. But the water that is also available from our rivers and our wells might not be pure enough for us to drink. So what exactly is the concern? Is it the purity of the water?
The concern is both. But me, I'm not addressing the challenge of climate change. No, I'm addressing that the little water we have, more of it is contaminated,
It's contaminated.
and we don't have mechanisms, mostly in developing countries, of purifying this water, even as we have so many purification systems around. So that, like in my country, Kenya, we always have like a yearly outbreak of cholera. Meanwhile, we have very nice water purifications in our malls and all over. So
Okay.
in our research, we found out the challenge is always either the cost or usage. So we are trying to fabricate a membrane that can fit into such setup.
Okay. Thank you very much. I have another question.
And
Another question. The other question is concerning the pores you have in your diatomaceous or diatomites, whatever you call it.
Be a bit loud.
Oh, you can hear me?
I can hear you now.
Okay, please. I was referring to the types of pores you have in your diatomaceous material or diatomites.
Okay.
I can see you talked about different structures of pores. My question.
Hello.
Can you hear me?
Yes.
What is the effect of baking? Baking, make it maybe ceramic. What is the effect of that on the type of pores you have in your material? Does it shrink them? Does it enlarge them? Does it make them to be closed such that you cannot use them as filters anymore? What is your observation on that?
Okay. We actually don't bake. We sinter. That's the right word.
Okay.
So, sintering.
Okay.
Sintering makes the material strong. Like me, I was sintering from 700 degrees to 1150. Now, when you continue sintering the material, what sintering is actually heating a material near its melting point, but not at its melting point, just near its melting point.
Okay.
So if we sinter to very high temperatures, like I couldn't go up to like 11, beyond 11, 1200 and up, because my material is 80% or more silicon. So if I sinter to that level, the whole silicon will melt and then it will close up my pores. At the same time, I cannot sinter my material to very low temperatures. Like if you see my optimum temperature in my earlier work was 900, 950. So if I sinter less than 900 and 950, I get a material, if a client is holding it, it will break. So the heat, because I was sintering using heat, not pressure. So the thermal heat I get is actually helps in bonding the material, making those bonding, the ionic bondings, to be strong enough to hold the material so that even when it falls, it will not break. And in our earlier works, we reported of pressure of around 100 and plus megapascal that can break our material, meaning that even if you are washing and the child drops the material, it will not break.
It will not break. Thank you very much. There is a question from Professor Matthew Afoladi, and the question is, how is the relationship between porosity and strength against breakage of your membrane?
How is the relationship between
porosity and strength against breakage? Against cracking, yes, of the membrane. What relationship can you establish between porosity and strength as a function of breaking the membrane?
Okay, now when I was measuring modulus of rupture, I was actually breaking the material.
Okay.
So that what I do is I was using 3-point test to break the material. So that is at the point I say this is my MOR, and that can also be equal to rupture. That's what he's asking. The breakage point is called the point of rupture. So the more you have pores, if you have more pores, if the material is too porous, then it will break easily. And if your material is less porous, it will not break easily. That is the best way I can answer.
Thank you very much for your presentation. We appreciate you.
Second question.
You want to move to the next presenter? The next presenter is Dr. Ebenezer.
Second question.
Oh, another question.
Yeah, Prof.
Yes.
Afolabi has another question.
Okay, sir. We just have
It's
to be
there.
fast.
I typed the second question already.
Okay, I actually didn't see it. Can you please say it directly, Prof?
How can your membrane stop heavy metal?
Heavy metal, yes, it does. Okay, in our membrane, in our work, we also tested with the sodium fluoride. So sodium fluoride is an ion. So metals are also ions and all that. So naturally, diatomaceous art itself from the, let me show you this material here. Hope I have.
We're talking
So
about
diatomaceous. Okay. So it has increased surface area naturally that can remove metallic ion through absorption. That is one. Two, when the material is in the water, it has different charges from the charge of the ion. So it also gets attracted through electrostatic forces. So this thing is able to absorb. Now, when we heat the material also at higher temperatures, the aluminium silicon bond breaks. So when the aluminium silicon bond breaks, it leaves the silicon ion hanging. When this ion is hanging, it is able to attract the charged particles which are in the oval. Those are the contaminants. In our other work, which we are also planning to publish, we further improved the mechanical property of this material by soaking in molasses and then overnight, and then heating this material in the absence of oxygen. That is, we carbon activated the material, so thereby increasing the absorption properties.
Thank you very much. Thank you very much. We have to stop here because of time. Maybe for further discussions, Prof can get in touch with you in private, so collaboration can go on. So the next presentation comes from Dr. Ebenezer Onia, and the title of the presentation is Internal Radiation Level in Natural Quartz Samples Collected from Southwestern Nigeria, Implication on Thermoluminescence Studies. Is Dr. Onia in?
No, it's not. No, it's not.
Okay.
So what we can do is Dr. Awolabi is there, so we can give the floor to Dr. Awolabi if he can hear us.
Dr. Awolabi?
Hello, I'm here.
Okay.
You're welcome, sir.
Yeah.
Dr. Onia is not around, I guess.
Okay.
So probably you come before him, and when he joins, then he's going to make his presentation. So you have the floor now, please.
Okay.
Thank you very much. And then I should mention that your presentation is on development of empirical relationship between crystal acid distortion and superconducting temperature of doped magnesium. What is boron? Superconductor?
Yeah.
Yeah.
We call it MgB2.
MgB2. Thank you very much. All right, you have the floor. You have the floor, please.
I'm trying to share my slide.
Okay.
I'm trying to share my screen.
Okay. All right, we can see it now. So you can just make it full.
Okay. Yeah, good morning. Before I comment this presentation, this work was done by me and Professor S. Olatunji from Computer Science Department, College of Computer Science and Information Technology, Imam Abdurrahman bin Faisal University, Dammam, Saudi Arabia.
Okay.
I sent Professor the link so that he can also join the presentation, so that if you have a question that I may not be able to answer, so that he can bail me out. The topic I'm presenting is development of empirical relationship between crystal lattice, distortion, and superconducting transition temperature of both MgB2 superconductor. Actually, what prompted us to do this work is that we published a work on this material in 2014 in Journal of Superconductivity and Novel Magnetisms. And the paper received a lot of citations. And in that work, what we did was that we related crystalline distortion with superconducting transient temperature using the chemometrics techniques. But this technique is not empirical. I mean, it's not empirical. It is difficult to implement directly. Then we thought, okay, let's try to develop empirical relationship that researchers can quickly implement in their laboratories. To start with, we just need to start from where the superconductivity began, from K. Onnings in 1911, when he was able to liquefy helium. When he got helium liquefied, then he started to study the behavior of material at a very low temperature. But he found that most materials, although he investigated mercury then, most materials at a particular temperature, their resistance drops to 0, meaning that at a particular temperature, materials has no resistance. It means that it can transmit current forever. When you put current there, it remains there forever. Such materials are known as superconductors, and they are a variant of superconductors. This diagram shows normal metal and superconductor. At a particular point now, the resistance of this material drops to 0, and that point is the critical point, superconducting transition temperature of the material. And this material, superconductors, has a lot of interesting properties like Meissner effect. That is, it can repel magnetic field. You can see in this equation, electric field, magnetic field is 0. In as much materials still remain a superconductor, that is, below critical temperature, below the critical field and the critical current. The picture I'm showing here is one of the graphs I got during my MSc program when I was fabricating another class of superconductor. Yeah, the MgB2 that we are considering here, it has a lot of interesting properties. This is the crystal diagram of MgB2. I got this structure from this link. It has a lot of interesting properties, among which is that MgB2, its constituents are very cheap. Magnesium, boron, they are very cheap. They are very light. Also, the gray boundaries of this superconductor is transparent, which means that it allows supercurrent to flow. It allows flow of larger supercurrent. Also, large coherence length is also there as advantage. Also, it has a weak absence of weak links and small anisotropy. These are the uniqueness of this superconductor that makes people to be researching on it. And the goal of the research on this superconductor is number one, that this superconductor has a transition temperature of almost 39 Kelvin. And 39 Kelvin is very far from the room temperature, which means that for us to achieve that, we need to use either liquid. We use a liquid nitrogen. Then we can use liquid helium to take it back to that range of temperature. Now, what we observe is that this material, when we introduce a foreign material into this MgB2, then we dope it. When we dope it, we observe a kind of distortion in lattice parameter. That is, the structure is natural at room temperature, is hexagonal, but can be distorted either along A axis or along C axis, depending on the dopant that we are introducing to this structure. Then we thought of, okay, let us use the distortion, which is contained in lattice parameter, to build a model that can give us the superconducting transition temperature of this material. Because for us to determine superconducting transition temperature of this material, it is costly. We need liquid helium. You may need to liquefy it from room temperature to 39 degrees. It's very good. It's not easy to determine superconducting transition temperature of this material. But we can determine crystal destruction through lattice parameter obtained from XRD. And XRD takes like 30 minutes to 1 hour to do XRD. And I'll say, okay, can we use the result of this XRD to model the superconducting transition temperature? Although we did it in our former work, but the model we use is not empirical. It cannot be easily implemented. Okay, let us develop equation that can be easily implemented. And that is the essence of doing this work. And what we use stepwise regression algorithm to do that. In this stepwise regression algorithm, this is the equation. Y is the superconducting transition temperature. This X is distortions as contained in the lattice parameters along A and C axis. This is beta. This is the weight that stepwise regression will determine. And this another constant that it will determine. And what stepwise regression does is that it generates equation that links descriptors, crystalline distortion with the transition temperature. And by doing that, it weighs the contribution of each of the distortions. That distortion along A axis is the one contributing much, or distortion along the C axis is the one contributing much. I can also have interactions. We can interact distortions along A and the C axis. That's the basis for the algorithm. Then, after we developed the algorithm within MATLAB computing environment, the algorithm was developed and we implemented it. We obtained the following equations. We obtained this equation 2. You can see A is distortion along A axis that can be obtained from lattice parameter along A. This is square. A, that lattice parameter, we have C also as lattice parameter. This is equation 2. We got 4 equations. Equation 2, equation 3, equation 4, and 5. And that equation we use different interactions. Let distortion along C interact with distortions along A. Let A even interact with A. In the last equation, equation 5, you can see that distortions along C is not even contributing. Then we evaluate these equations, that which one is better. We evaluate the equations on the basis of 2 parameters. We use mean absolute percentage error. I also use root mean square error. Since this is the error, the equation that shows lower error is what is the best equation. And we can see from this now, the equation that shows least error is this equation 2. For mean absolute percentage error, we have 2.216%, and root mean square error, it shows 0.987. Others are higher than that. To put it in a pictorial view, you can see this graph, figure 1, presents root mean square error for different model. For the equations, you can see the red shows the lowest. It shows the lowest, which means that the best equation. The same thing can be transferred to mean absolute percentage error. We just need to use different error metrics to evaluate our model, because it might be possible. I've done work like that, in which we have one error like root mean square error is lower, but when you get to mean absolute error, it is higher. The problem that we need to use different metrics, and all these metrics should dictate. They should be able to observe similar inference from the matrix. Now, the model we built using this to obtain these equations, it was built using 61 experimental results. That is, we went to the literature, different MgP2 superconductor doped with different materials. After being doped, we got the experimental superconducting transition temperature, and we got the lattice parameter from the XRD result. These 61 samples we used to build our model. And from these 61 samples, we got the aforementioned equations. Then, these are the results. This is the crystal lattice A and C. We have superconducting temperature, which is experimental. This one is a result of our earlier work in 2015. We compare it with this present work. And we can see from the last column here that the result of this work, it is better than the earlier work, which means that this work has a lot of uniqueness and the novelties that will be explained later. Then, these are novelties of this work. We got the easily implementable equation. And these equations, they are better than the existing models. Also, when we got our equation from 61 doped samples of superconductor, MG2 superconductors, then we further validated our model. Then we went to literature again. We got another 100 samples, different from the earlier 61 samples. Then we implemented these equations on the 100 new samples, and we got error less than 3%. This is a summary of the whole work. I put in the chart like a graphic abstract. Lattice distortion of doped MG superconductor along A and C axis. When it goes into empirical relations, you can get this as the evaluation of the equations. And this one we compare it with the existing models. In summary, this work, it develops empirical equation. These equations very easy, it can be easily implemented, also performs better than the existing model. Now, what we are doing now is that we want a situation by which we can determine the same superconducting transition temperature using room resistivity measurements. That is, after I have fabricated my sample, then I will determine its resistivity at room temperature, because resistivity at critical temperature is 0. That is a point at which resistivity of the sound becomes 0. That point we call it superconducting transition temperature. What we are doing now, we have submitted a paper on that, is that we are trying to relate room temperature resistivity with superconducting transition temperature, which means that we don't even need to do any experimental work at all. After you fabricate your sample, measure its resistivity value, that value just input into the model, it gives you the superconducting transition temperature. When the papers kept true, then you can now think of how do we incorporate this into like a microchips. That microchips can be incorporated into a multimeter, so that a multimeter can do the following functions. Number one, it can measure the resistivity of the sample you just prepared. I can also tell you superconducting transition temperature of that sample. Now, what is the cost implication? It saves stress and the time. Also, it allows researchers to not waste time on samples that give good results, because experimentation is like try and error. You dope with this sample, you dope with this sample, you dope with this sample. And after doing a lot of stress, see that result you get is not presentable. By this now, when this one's kept true, experimentalist does not even need to do a lot of work. By preparing your sample, just find the room temperature resistivity. It gives you the superconducting transition temperature of that sample. Thank you for listening.
Thank you very much,
Thank you.
Dr. Olabi. for this very beautiful presentation. It's a very exciting and thought-provoking work, which I'm sure many of us will have developed interest in one way or the other. So we will allow, the floor is open for questioning now. If you have a question, you can raise your hand or you can post your question directly in the chat so we can read it to the presenter. Then we get an answer from him, please. The floor is open.
I have my hand raised.
Okay.
We have Dr. Dambe. Yeah.
Okay.
Yeah, okay. Okay, thank you, Dr. Olabi. That was very interesting. I learned a lot. I have two questions, but the first question is more a curiosity question. So you said that the MGB2 is very is cheap to be made. So that means we can really think about the possibility in the very close future to have circuitry with superconducting material. Is that?
To have what?
Is it possible in the close future that we will have a circuitry, electronic circuitry with this kind of material?
Electric circuits made of this kind of material.
You see, the issue of superconductivity, superconductors, they had been on it over 100 years ago. What is the goal is that we want a material that can behave in this manner at a room temperature.
Yes, I've seen that you have a critical temperatures of 36 degrees.
39 degrees actually. There are some at 36, 39, maximum 40.
In Africa, is the normal temperature.
No. This is
Kelvin.
Kelvin.
It's Kelvin.
Ah,
Yeah.
okay. I thought it was 6 Celsius.
No, it's Kelvin.
It's Kelvin.
Very low.
Ah, okay.
Very low.
Okay. I thought it was a Celsius.
No.
Okay. My second preoccupation is about the perspective that you exposed. You said that you would like to be you would like to have the ability to determine the TC just by measuring the resistance. My point will be more in the mathematical points. I think only one variable. It will be only one variable.
Actually, we published a work in 2016 where we proposed that. We published it in Ndewi, where we proposed that room resistivity should be enough to determine critical temperature of material, because material becomes a superconductor when resistivity becomes 0. Resistivity to start with, it decreases gradually until it gets to 0. Now, initial resistivity have a contribution.
Of course.
Now, what we are just published, what we just submitted for publication now is that if that should work, it might not give just absolute results. The accuracy might be like to 5%. But as a researcher now, maybe you prepare 10 samples, and that 10 samples you can get the pattern without being stressed. You can just get the pattern that the material I'm using to dope my material cannot work well. They can just discard it and proceed further.
Okay, because I would like to propose something which I think maybe give something help is, instead of in at room temperature, we can try also to mimic the temperature effects just by applying a high voltage. Because when you apply high voltage, you are creating Joule effect inside the material.
But in that case, you are increasing the temperature. The goal of it is to decrease.
Yes, of course. No, but not very high voltage. You can apply just voltage of maybe not more than 24 volts.
Yeah, you are correct. But what we are doing with this sample is that we are reducing the temperature from 300 Kelvin room temperature to 39 Kelvin.
Yeah.
When we apply voltage, voltage will only increase the temperature beyond room temperature.
Yeah. No, my point is that just by increasing a little the temperature, you have at least 2 or 3 or 4 points of the resistivity.
Okay.
And then 3 or 4 points of resistivity,
I get the point. I get the point. I get the point. Yeah,
yeah,
I get the point. You can get like 3 or 4 data points and extrapolate.
Exactly. Instead of only having 1 point at room temperature.
I get your point. Good.
Yeah.
Thank you. I get it. I get it.
Okay, thank you.
So I think we also have a question in the chat from Professor Falabi. Do you want me to read it?
Yeah.
So what parameters have you enhanced during your theoretical doping?
We have enhanced distortions along both directions. That is, when we distort a material along A axis, what effect will it be on the critical temperature? When we distort along C axis, what effect will it be on the critical temperature? You can see that this equation we presented here now, equation 5, it shows this along A alone without putting C into considerations. Meaning that if you want to improve the property of this material now, you can just look for a material that can distort MgB2 appropriately along either of the axes. Thank you.
Dr. Olabi, before you go, because it's almost time, I have a question too, please.
Okay.
And then my question is, when you talked about distortion of the lattice parameters, so what exactly is the crystal structure of MgB2?
Hexagonal.
Okay.
Is hexagonal. Yeah. So does it mean that in the event of addition of doping atoms,
the state will not change. The state will not change. Do not rapture. Just elongation or contraction. That's what we mean by distortion.
Okay.
Either A is contracted or
expanded.
Yeah. Likewise, C.
Now the other thing I want to ask also quickly is why didn't you give maybe the experimental thing is short? I know you have explained a lot of things, but because, for example, liquid nitrogen is not that scarce to get if you want to lower the temperature.
You see, in my MSc program, I worked on superconductor, not this time. I worked on ion-based superconductor.
Okay.
And that has critical temperature of 4 Kelvin.
Okay.
Liquid nitrogen to take it from room temperature to 78 Kelvin.
Yes.
We now use helium to take it from 78 to 4 Kelvin.
All right.
My brother, cryostat in Nigeria is very difficult to get. It's difficult.
Okay. Thank you very much for your presentation.
Second question.
Online.
Okay, another question for you. There is somebody that is interfering. Can you please mute your microphone, please?
Okay.
I send a text. Second text.
Dodi.
Yeah, I'm trying to.
Yeah, okay.
Okay, I think it's the person is moving, so there's no way you can stop the. Yeah, it's fine now. So Professor Afolabi had 2 questions actually.
Yeah, there is 2 questions. Yeah.
Do you want me to go for the second one? So the second one is, can your non-caustic sample replace the copper for electrical conduction?
In fact, we are working towards that. If we can achieve that, the whole life becomes easy. The computer you are having in front of you will not generate it again, because power loss will be 0 in this material we are saying. If we can excel in that, your power transmission wires will not lose energy, because during transmission we transmit at a very high voltage, low current to prevent power loss. In this case now, we don't need that.
Yes.
We don't need that. But we have not achieved that. The maximum we have achieved now is 225 Kelvin at a very high pressure. 225 Kelvin at a very high pressure, and we are coming to 300 Kelvin. However, we have some prospects. This prospect is that a magnetic resonance imaging that they use in the hospital. You see, the principles of this machine is that it needs a very huge magnetic field. To generate a magnetic field, you need current. To increase the field, you increase the current. When current is increased, it will increase. Now, to generate huge magnetic field, a lot of power will be lost. But now we are using superconductor for that work. At least superconductor of transition temperature of like 90 Kelvin can be used. Ordinary liquid nitrogen can cool that material from room temperature to 90 Kelvin, like YBC0. We are published on that, the YBC0. At that point now, in the hospital, you put liquid nitrogen around that material, then you can generate huge amount of magnetic field, then MRI can function properly. I believe one day we achieve room temperature superconductors. Thank you.
Okay.
Thank you. So maybe, is it break time or we still have another
Not break time.
second one?
Come on.
So yeah, we still have one more presentation.
Yeah, Dr. Beltaco.
So
And
if,
I don't know if Mr. Oniya is back because he's back.
I think he's back, yeah.
Yeah, he's back. Because yesterday he was with us, so that was our surprise that he's not here. Okay, yeah, he's back. So after Dr. Beltaco, Dr. Oniya can make his presentation.
so while Dr. Beltaco is sharing the screen, I can see a hand raised. Oh, Prof. Falabi.
No, I don't have questions.
Oh, okay.
I think Professor Olabi should stop his screen sharing first. Beltaco, it's up to you.
Okay. So I will start sharing my screen now.
You have 1 minute of presentation and 30 seconds of question.
Oh my God. So I'll just say good morning and then I will pass. Oh my God. They want me to share Microsoft document.
Okay, something's coming.
Okay. You are seeing my screen?
Yeah. Yeah, I think it's fine. If Dr. Latif can introduce the presenter, then we go.
Okay, so
Okay. Thank you very much, Dr. Beltaco. So you'll be talking about the thermoelectricity at nanoscale. Dr. Beltaco, please, you have the floor.
Okay, thank you. Good morning, everyone. And
good morning.
I will talk about thermoelectricity at nanoscale, as the title just said, is about molecular junctions. So basically, the idea is since most of the electronics actually are getting to less than 10 nanometer scale for most of the semiconducting electronics, so people are looking in different directions. And mostly one of the highly active direction is molecular electronics, where people are trying to see whether we can replace, for instance, the silicon in transistors and all the other types of electronic devices with molecules. So single molecular junctions are one of the candidates for these stories. So actually, you have a picture here where there is a single molecular junction. And in this type of junction, you have a gold electrode on the left and on the right. And then you connect this molecule in the middle that is porphyrin with these two electrodes. And you want to see how charge or energy or heat will flow through this junction. So these are different things you can look, for instance, the differential voltage or the quantization of the conductance and these things. And even quantum interference actually are one of the very active phenomena where people are trying to clearly see quantum interference in molecular junctions, in molecules, basically from theory side and even experimental side. So what I'm presenting here is, let's say, both of them, like theory and experiment, where we have some collaboration with experimental groups. So we do actually DFT plus NEGF, non-equilibrium green functions, formalism for the transport, and sometimes Boltzmann transport. So we just develop the codes and do the simulation. Okay, so the theory side is, for instance, the Landauer formalism. When you have this kind of junction, you want to see how the current will flow from left to right. So the current flow is, for instance, a difference of, let's say, a difference of bias, you know. So if you want to have a flow of current, you need either to apply bias or apply a pulse or a difference of temperature or something. You want to move the carriers in a junction or in a kind of device. So here, this is why you can see the difference of Fermi distribution. So depending on how the carriers are distributed on the left and the right. And then you have tau E, that will be the transmission function that will characterize how the carriers will flow through your device. So you know what is called the conductance is just the inverse of is I over E over V. And we have the quantum conductance that is 2 times E squared, E the electron charge divided by H bar. So basically in molecular junctions, the conduction or the carrier flow is mostly depending on the molecular electronics, the electronic structure of the molecule, and then how this molecule is connected to the electrode, like the gold in our case. So this is why people try to look at different types of connecting groups. They call it anchoring groups to the electrodes. And now, regarding the thermoelectricity, basically you need, you have this quantity that's called the thermal conductance that is made of 2 components, basically the electrons contribution and then the phonon contributions. So for the phonons, for those that don't know what is a phonon is just the vibration of the lattice. Like if you have your electron moving in your crystal, then for instance, the vibration of your lattice, the lattice of your crystal actually will contribute to the heat flow. So this contributes to the thermal conductance. And then you can compute the electrical current or the phononic current or the heat current in your system with these equations. So you still have this transmission times the difference of the Fermi distribution on the left and the right. And then for the phonon or the heat current, you have the difference of the, let's say, Bose-Einstein distribution, GRGL, the difference of your heat or your heat bath on the left and the right. Then you can compute in linear regime, let's say for small temperature difference, the difference of voltage induced by the temperature difference. So basically, I guess you understood from the beginning that I didn't say it, but that the thermoelectricity effect is due to the temperature difference. Like when you apply temperature difference between two electrodes, then you will get this a kind of current flowing, and this current flow is thermoelectric current. So you can compute the Seebeck of your material as well with this formula here. And then if this formula actually, yes, this formula is the general, then there are approximations when you are in the linear regime. So the linear regime is where you have a very small bias applied to your device. Then for if your Seebeck is positive, it means that your system, your junction is hole dominated, like the transport of the hole is more dominant. And then if it's negative, then you have electron dominated transport. And in thermoelectricity, one of the parameter, the most important parameter is the the ZT. The ZT is just the product of the conductance and the Seebeck squared times the temperature divided by the thermal conductance. And the main problem for thermoelectricity is that you have this object that is the thermal conductance, the thermal conductivity at the below, so the K or the kappa, I don't know which one we call it, but anyway, but it have contribution from phonon and electron. So it's kind of turned out that when you have a high conductivity, for a high electron conductivity, you have a high thermal conductivity as well, because you have electronic contributions. So in that case, it's kind of canceling from top. So the main problem is to find a material where you have a very a low thermal conductivity with a high electrical conductivity. And this is very difficult to obtain from so far from theory. So for instance, if you have a material with a ZT greater than 1, then at least you can consider this material as something that will contribute to like a thermoelectric material or a thermoelectric molecule. But then if the ZT is greater than 3, you can consider that this kind of junction will compete. This kind of junction will compete with the traditional thermoelectric materials, basically semiconducting materials that people use often. So for instance, you have to take note that the heating, since the junction is very small, the process of heating is actually happening in the electrode, not in the molecule itself. You can have in the molecule a local heating that is just the heat in the electrode that is transferred to some small part of the molecule. Then some people observe experimentally this, let's say, local heating, sorry. So things we can note are thermal power. This is the S in the ZT expression, is not sensitive to the electrode molecule coupling. I said that the transport in molecules are very sensitive to the coupling to the electrode or the contact. Then thermoelectricity is less sensitive to that. It has been proven in several papers. And it is possible to probe experimentally the thermal power, the thermal power, yes, also done. And it is not yet possible to probe neither. No, I'm sorry, but this sentence is not correct, because for now, since 2018, there is a paper that said they were able to measure the thermal conductance in single molecular junctions from a group already. So yes. So, but then on the theory side, there is a limitation. The limitation is that DFT, basically we use DFT for the electronic structure and then NEGF for the transport. DFT actually, as far as we know, actually minimize the molecules gap. The gap is not correctly computed in any DFT code. So the main point is, how do we correct that? And there are several methods. One of them is DFT plus sigma. And the DFT plus sigma is made of a method where you just compute the ionization potential. So basically, this is the formula you correct for instance, you take the orbitals of all your molecule, and then you shift them, you correct them by the IP and the HOMO, LUMO, and the delta OC. The delta OC is the fact that when you have the gas phase molecule, before you put it in the junction, when you put it in the junction, then there is a kind of screening effect that makes affect the electronic structure of your molecule because you compress it in the junction. So this screening effect, or this kind of screening effect, is computed properly here. Like you consider point charge in space, and then you just assume, for instance, that your electrodes are a plane, and then your charge distribution on your molecule are point charge in space. So you just compute what is happening to this point charge, what is the correction to this point charge induced by the field induced by the plane. Okay, sorry, speaking too much. Okay, so this is basically the main point. So I just set here an example of one of our collaboration where we did a computation of a molecule, and I showed here the orbitals, the high molecular orbitals, and lower unoccupied orbitals, molecular orbitals, sorry. So you just see, so these are three molecules. This is the porphyrin, and then this is a metalloporphyrin where you have the copper in the center, and then you have zinc in the center. So I did this calculation with Tubomol. So I want to show you an example of result where we got, for instance, if you do simple DFT calculation on the porphyrin connected to a gold 20, for instance. So you get the conductance 4.9 10 to the minus 2. Then the same molecule, if you correct, you do the correction, because since the DFT actually underestimate the gap of any molecules, any DFT code actually underestimate the gap. So once you correct it with DFT plus sigma also is not accurate 100%, but at least 90%. So you can, or 95, because basically we get close to what experimental people say. What is interesting is that you see from the calculation, the red is DFT and the blue is DFT corrected. So DFT sigma. And you can see that what we get from DFT plus sigma, for instance, is almost close to what people got in the experiment, you see. And it is really close to what people got in the experiment. And the same thing for the ZBEC. The ZBEC, they got something like 7.1, 10 to the minus 6. And then we also got 4.3, 10 to the minus 6. And the first time I did these calculations, I was like, oh my God, it is very interesting, because people measure something, and then at some point you sit down, you do the theory calculation, and you get it. So I think and the same thing happened when you use the metallo center. Why didn't I put the, okay, when you put the metallo center for zinc, that one, we got something also close to the experiment. Not really, because the experiment is 1.7 and we got 2.0. It's not bad, but the ZBEC is a bit far, but for experimental people, they think is okay. But okay, I think that's all. That's all. So basically, the main thing is to say the studies on classical, or let's say using semiconductors, using different materials is interesting at some point, but now people are moving to, okay, molecular electronics, spintronics, thinking of how they can actually directly measure quantum effect like interferences and these heat phenomena in molecules. So I just wanted to show that up, and then maybe have a discussion with you guys. That's all for me today. Thank you so much.
Thank you very much, Dr. Beltaco, for a very thought-provoking presentation. Nice work, DFT. I'm not very conversant, but I can see a lot of work has been done before we get this result. Thank you very much.
Yeah.
And also for the good time management.
You're
so
welcome.
Now the floor is open for questioning. So if you have your questions, you can raise your hand, you can ask directly, or you can type your questions. Please. Questions? We're talking semiconductors here. I want to guess that people in superconductor might have some interest some way. So if you have questions, please be free to ask your questions.
I can see Prof. Falabi hands.
Okay.
Okay.
Yeah.
My question, can I ask?
Please, go ahead, Prof.
Yeah. You have different metals. Then there's a junction between them. And then you apply different temperature to them. Is that not what you did? Then you measure the conductivity there. Is that what you did? Okay. Now, can you suggest the two materials that are best in producing high seeback effect or high current, and how we can apply such to our everyday use in a particular case? That's my question.
I'm not sure. I'm not sure I understood properly. You said, please repeat the question.
Okay, you have tested different materials. One on the right, one on the left. Then you estimate their current conductivity, how they can produce electricity. And I said, now we have photoelectricity. Then this is thermoelectricity. Of course, we are in Africa where we have heat and enough solar intensity. We can apply that one outside. Now, which material can be very promising from your work? Which two material can you suggest? And can you quote the quantity of the electricity they can produce at certain temperature?
Okay, basically this is more something at the nanoscale. So I think from the experimental side, the zinc actually, when you introduce zinc at the buffering, you actually make the highest Zbec, the highest thermal power. But then, for instance,
are you saying zinc junction?
No, I mean for this molecule, the zinc as metallo group inside this molecule.
Oh no, you talk about zinc. That's mono something. The same similar junction. Is that
yeah.
I thought you said you have done something like zinc, aluminum, zinc, copper, different junctions. And
yes, this zinc. Yeah, this zinc is inside the molecule. As can you have a look at this?
I see. That's the junction.
It's just
so. What is the yellow material then? What's the yellow material?
The yellow material is gold contacts. The yellow material is gold. Then in the
no, that's
in the
not
middle of this.
People will see gold when you put them outside. You should have tried a low-cost material. Okay, thank you.
You're welcome.
Thank you. Man, you should try low-cost materials next time.
Okay.
Do you understand what I said? Okay.
Okay, thank you,
I understood. Thank you
for your comments. Thank you, Dr. Beltaco, for the nice work. So we will stop here for this presentation and take the last one before the break. Actually, we are having a slight change in the schedule, and that is because we took a first presentation that was actually not supposed to be included in today's list of presentations. So we are going to take Dr. Ebenezer Onia now, and immediately afterward, we are going for a break, a coffee break, and then after we continue. So Dr. Onia, please, you have the floor. Is Dr. Onia in?
Yeah.
Okay, thank you.
Dr. Onia, are you sharing your screen now? Okay.
May I remind us that the title of the presentation of Dr. Ebenezer Onia is Internal Radiation Levels in Natural Quartz Samples Collected from Southwestern Nigeria, Implications on Thermoluminescence Studies. Thank you, Prof. Go ahead.
Thank you very much. Can you all hear me? Can you hear me?
Yes, yes, we can hear you, but I think you might have to increase the volume, please.
Oh, okay. Maybe I speak louder then.
Yeah, thank you very much.
Is my screen on?
Yeah, the screen is on. We can see your screen.
Okay, thank you very much.
No problems.
So I'm presenting a work that we have done on internal radiation level in natural quartz samples collected from southwestern Nigeria and implication on the thermoluminescence. The presentation outlines introduction followed by focus of the study, materials, method, result, and discussion, and lastly, conclusion. Quartz as a natural dosimeter is the major mineral used in luminescent respiratory dosimetry. This material exhibits thermoluminescence and OSL, that is optically stimulated luminescence signals corresponding to amount of pure radiation it received. In the sense that because this material are insulators, so when they receive ionizing radiation from the environment, the radiation will cause excitation of electron to the conduction bands, and because of defects and metastable within the material, some of these excited electron are trapped in some traps within the material. And because of this, if they will be necessary to supply external energy to get the trap electron back where they can recombine and give out a UV, which is measurable. So when the energy supply is in form of heat, we call it a thermoluminescence, and if it's in form of light, it's an OSL. So such luminescence signals have been used in retrospective dosimetry dating geological and archaeological material over the last year for TL, like the wind lines, the material was heated. So because the material will be absorbing radiation, and over a period of time, if this material is taken to the laboratory and the TL is carried out, the signals, luminescent signals, will correspond to the amount of radiation the sample has received. So if this one is evaluated and the dose rate in the surrounding, the background is known. So the dose measured in the laboratory will be divided by the dose rate, and that one will give us time. So it's used for dating and for accident dosimetry. So the TL glow curve of this material is characterized by a number of glow peaks when heated from room temperature to 500 degrees centigrade at a constant heating rate after irradiation. Each of these peaks is associated with the electron trap responsible for it. So these are the trap responsive. We have shallow traps, we have thermally stable traps. Like 110 glow peak is very unstable in the laboratory because within 2 hours, all the charges that's accumulated can easily go away. So, but nevertheless, this particular peak is very important because it's used for sensitive to monitor sensitivity and in hollow quartz because the radiation it receives and the heat, or the history of all these heat and the radiation can be assessed through 110 TL peak. In general, mechanism of luminescence of course are full of complexity, particularly the issue of sensitivity that is very complex in nature because there are no reproducibility. If you take a sample, two samples from different locations, by the time you give them the same dose, you will not get the same signal. So this has been a real problem and cause luminescence. So recent work are centered on this mechanism in order to have better understanding of the mechanism towards improving its application in respective dosimetry and dating. So factors like different geological origins as well as complex sedimentary history, effect of different laboratory procedures. Each sample is subjected to have been reported to influence their luminescence sensitivity. So a lot of work going on that have been done on this. However, much attention has not been paid to possible impact of internal radiation level of a quartz sample on its luminescence sensitivity because some quartz is widely employed, used for dating, but focus are not on the internal radiation, that is self-dosing, resulting from the sample itself. So in this course, and this study, the focus of the study is to evaluate internal radiation level in some quartz using gamma ray spectrometry and subsequently to study the TL signal sensitivity in each of the sample and possibly correlate them with the internal radiation level and a possibility of a presence of FESPA leading potassium 40 leading to FESPA infection. So materials, 12 natural quartz samples were collected from different locations in Nigeria, like southwestern Nigeria, as indicated this map. We have the point where the samples were collected. The samples were crushed and pulverized and cleaned in acetone. So the pulverized samples were packaged into labeled airtight plastic dispensing sachets for analysis. So methods. So the gamma spectrometry measurement on the samples were carried out with Gamma detector at a jamming, and its luminescence TL measurement on the samples were measured with a RISO TS OSL reader in Greece. So the description of the TL measurement protocols. For a given sample, a dose of 10 gray was given to the sample, implying that this dose is given on the sample because the sample will have absorbed natural TL, natural dose from the surrounding. So in the second step, a heat read up to 500 degrees centigrade was carried out on the sample. And the signal got here will be due to the dose given to the sample and the natural dose that has been received from the surrounding. And in step 2 now, so the same step 3 rather, sorry. Step 3 to 2 were repeated for the same sample. That is, we give the same dose and read the TL on the same sample, that is on the same aliquot rather. So in step 4, steps 1 to 3 were repeated for different samples. Result and discussion. The concentration of radionuclide activity in all the samples were very low as compared with world average. The highest dose rate in one of the samples, that is the S4, that is a factor of 15, lesser than a case of self-dose reported in the literature. As well, no artificial radionuclides were detected in any of the samples. Can you all hear me? Hello?
Yes.
Yes, we are with you, don't mind.
Okay, thank you. So no artificial radionuclides were detected in any of the samples. And among the 12 samples, there are only 3 samples with measurable activities. The remaining samples were undetectable because of they were below detection limit of the equipment used. And these samples are S4, S2, and S10, and with a dose rate of 7.19, 0.3, and 0.09 nanogram per hour respectively. Because in luminescence, we deal with the dose rate because that is what is used to retrieve the time, that is the age in dating. So these dot rates are far less as compared with the 1.05 milligram per hour observed in another material in the literature. And this material was discovered to have a self dose, that is, it gives self dose to itself. So implying that these samples of ours cannot have a self dose, that is self-dosing. So the luminescent resource now. So the graph here shows the glow curves for Fox samples selected, and the three of them, that is S4, S2, and S10, were the sample where activity were detected, and incidentally, these samples have a higher TL response. And a sample H was selected representing the group that had undetectable radioactivity. So 8 represents the first TL, and YB represent the second TL after giving another dose on the same early coach, and the TL was carried out. As you can see here, the thermally stable trap here from around 200 and above that are used for dating and retrospective dosimetry are filled. And this is a result of the natural luminescence that the sample has received. And by when the sample has been read and given the same dose, you see they are very low. And one of the properties of 110 TLP is here that there is enhancement in the sensitivity, that is has been sensitized this to the dose and the heating, and these phenomenon is as a result of pre-dose effect and thermal activation process. So here's another graph plus showing all the samples now, the 12 samples. There's a 110 TLP, the first glow, that is the first measurement, that is A, and B, 110 TLP, the second measurement. C is the high temperature, thermally stable star for the first goal, C, and the D for the second measurement. It is since here the 3 samples, that is S2 and S4 and S10, that possess a major radioactivity that could measure. They are the samples with a leading luminescent signal here. And the other samples were not up to them. And coming to higher temperature peak as well. These 3 samples are leading. So, but as I initially said, that some cores possess different sensitivity. They are not reproducibility. We can see the reason why this sample, though they resolve the same dose, although different TL, natural TL, we can expect them to have the same signals. But coming to the second TL now, for 110 TL big, it has been enhanced, and the 3 sample as well possess highest signals, leaving the other samples with no measurable activity behind. But nevertheless, but X1 is competing with S10. But when it came to return of the IRTLP for the second image, it's arbitrary. So we cannot correlate the correlation between the radioactivity and the sensitivity. So although the result of the 3 core sample with detectable activity concentration have demonstrated a promising link between the level of internal radioactivity in the sample and its luminescent sensitivity. The high percentage of 75% of the number of samples with undetectable radioactivity concentration in these samples that in this measurement pose a limit to further probe into a possibility of established potential correlation between the two phenomena in this study. So we got stuck because of other samples that could not be measured. But nevertheless, another approach was employed or deployed, the additive dose procedure for estimating the equivalent dose for each of the sample. That is, just by following the dating procedure, these samples, we try to measure the amount of dose they've received from the environment, because that will give the same um, effect on the cell dose to see how they are being sensitized according to the natural dose they've received. Since the effect of the third factor is much related to self-dosing, so emanating from activity concentration within the sample. So here is the result for high temperature TL peak. We see here there is a direct link with the signals with above dose calculated for this sample. And the three samples that had a detectable radioactivity among the H2, X4, and X10, though we have H2A and S11. But there is a cluster of samples here which seem not to be dependent on the remnant ED, that is absorbed dose here. And there's a sample here, 7 here. In its own case, they not follow a particular pattern. And when the sensation factor for 110 peak has been used for monitoring sensitivity, we discover that all the sample now show a sort of dependence on the remnant ED they have received from history. And about S7 as well is standing still, as we know that there are many factors responsible for sensitivity of sample, as I already highlighted, like the factor they are being exposed to, and the geological formation, and all the rest. So the TL integral yield is straightforward increasing tendency with ED for 5 samples. Surprisingly, the 3 samples that yield that measurable activity due to the decay of specific radionuclide are inclusive among this. So out of the rest 7 that are independent of the accrued dose, a group of 6 indicate similar sensitivity with the exemption of S7. But for the challenging factor, 110 TL peak versus the remnant dose. So they follow the same pattern except S7. So this indicates a promising link between ED and the sensitivity if it's being deployed. Here, oh, sorry for this. This is not part of the plot. So in order to test for the first part inclusion, IRS measured on other course of each sample following administration of a 10 gray on natural TL of fish, as shown in this figure. It is observed that S12, and S11 and S5 from follow being mostly infected by the FESPA infection. From this, it is clear that FESPA inclusion contributed to the sensitivity and TS signal of these 3 samples, but other samples, they are not being affected because their own curve is just flat. For normal IRS measurement, it follow a decay curve like this. So in conclusion, it can be concluded that the 3 factors itemized above that I've explained, that is activity concentration in each of the samples, though this one we could not reach a logical conclusion because of the number of samples that were detectable were only 3 out of 12, and the level of FESA infection affected 3 of them. And lastly, the equivalent dose accumulated in them affected the TL sensitivity, as shown by the sensitization factor of 110 TL peak that is known to be used for correcting sensitivity and luminescent protocols. So it is recommended that further work are recommended to establish promising link between the level of internal radioactivity in the sample and its luminescent sensitivity by extending this work to other samples and see if possible those samples will have detectable radioactivity which can be well correlated. And nevertheless, these works show that it's possible there's a link between these two phenomena that have not been that well investigated in the literature. Right, the end. Thank you.
Thank you very much, Dr. Ebenezer Onia, for your nice presentation. Everything was 16 minutes, just 1 minute more. Thanks for keeping to time. Now the floor is open for questions, please. If you have questions, you can raise your hand so we call you to ask your question, or you can post your question in the chat. Yeah, so the floor is open, please. We have 2 to 3 questions, and then we can go for a break, coffee break, and thereafter we continue. Thank you. So please, questions. Questions? Okay, while waiting for others to ask their questions, Dr. Nia.
Yes.
I have 1 or 2 questions for you.
Thank you very much.
We know ourselves very well, so thank you. My question is, about the self-irradiation thing being investigated in quartz.
Yeah.
Well, I suspect that probably you might need to take one more step.
Yeah.
I feel that because ordinarily the gamma spec shows there is no gamma emission with below the background level, and that probably might not be sufficient to conclude there is no irradiation, because there could be radiation, for example, from beta.
Yeah.
And for example, yttrium is a very known pure beta emitter, beta minus emitter. It decays by electron emission. Strontium is also a very good beta emitter. And the problem with yttrium is because it has a very short half-life of about 64 hours. So the emission rate is quite high. So I wouldn't know if you might have the facility to check for beta emission level, if possible. We did a work similar to this. We had something close to that, and to be able to conclude, we have to refer to the elemental composition, for example. If you check the elemental composition, if you do a very accurate elemental composition of your sample, maybe using a very sharp technique like an accelerator, PIGZ, PIGA, RPS, will give you in detail all the elements, and then you can identify from the concentration of those elements which ones can be beta emitter or even alpha emitters.
Well, thank you very much. Your question is well understood, but the problem we had, well, for the beta, that one could be considered, because that was why it's part of the recommendation that this work need to, because this work now shows there is a sort of a correlation between the two phenomena, but we cannot reach a logical conclusion on that. But nevertheless, we can still go ahead to investigate using other methods. But you made mention of elemental composition analysis. Though we're African, we are all here, we know the problem we face. On all these samples, I tell you, I've carried out NAA and Zaria and your university.
Accelerator?
Yes, I used the accelerator.
Okay.
And I use your X-ray.
Okay, XRF.
SRF, yeah. But
XRF might not be accurate for this kind of samples, because
yes, I know what I'm saying.
Okay.
What I'm saying, yeah. Let me learn. Because the three results, they seem not to agree. So that is why I would not want to.
I think I can give an answer to that, sir.
Yes, they will not agree, because
okay.
I was in a conference in Netherlands and I showed to a professor. He told me, well, there should be a sort of correlation between them. So that is one of the reasons why I decided to drop those research. But nevertheless, for the beta analysis, I think it's worth of being reconsidered. Yes,
Thank you,
you
sir.
said you have an answer? Yeah?
Yeah, okay, it's fine. With the explanation you're giving. I have another question.
Okay.
The 110 degrees C peak in quartz, which is short-lived.
Yeah.
I think this is another area that we can quickly bring out a very quick result, because that's the fact that it is short-lived. We know from theory how luminescence decay. We have an expression for that. Why can't we sort of simulate or maybe evaluate the lifetime based on the theory that we know, compare with what we see in the lab, and then probably now come up with some sort of I wouldn't say algorithm, or maybe correcting that, because we did something similar to that in a paper published in 2018. And then from theory, I think we were expecting something like 4 days. And then in the lab, we observed something like 15 days. And then some of the very top people, you know the person, you know.
Come and see now, sir. Let me follow this thing up. I went up without slippers.
Dr. Onia.
Yeah, it's not.
Yeah, I spoke with Chen. You know Chen very well, very top person in this business. And Chen was excited. He said, "So you got this value, you know?" So because the theory have been evaluated, maybe considering so many things, and then it has been almost impossible to practice them in our situation. And the fact that this peak is short-lived, it is a good opportunity to quickly test that theory. And then if it doesn't work, or if to what extent we can now make some suggestion, and that goes out to be, I think we can discuss this better after this conference.
Okay, thank you very much. It's a good idea. We'll discuss that after this.
Okay.
But nevertheless, the 110 TL peak, though, is so unstable, but as I said, it has been very useful because it's used for pre-dose dating. It is being used for pre-dose dating, in which we'll calibrate the dose that the sample that's received from the radiation history, because depending on the radiation and its dose history, in radiation history, the sensitivity of quartz change. So that one cannot be used to now calibrate the amount of dose that's a T else a sample has received. So 110 TLB is a very useful tool, though it has a very short-lived in the laboratory, but it's very, very useful. And apart from that, I have many work in which I try to separate the effect of a pure thermal activation on the samples. On 110 TLP, I did some simulation and I did some experimental work on that. So, but it's, as you suggested, the floor is still open because many things have not been, known about this particular aliquot and phosphorus.
Okay, then there's a question from Professor Fulavi here, who is asking, how can quartz materials be improved on for dosimetric application?
For what?
For dosimetric application, how can we improve on? I guess he's referring to sensitivity.
No, yeah, that's what I'm saying. The way there are a lot of established protocols that takes, what I'm trying to say here is that quartz exhibit sensitivity changing due to radiation and heating, but nevertheless, it is being used for dating.
Okay.
Because the procedures for sensitivity changing correction are inclusive in all these procedures. And that is one of the reasons why many studies are devoted to 110 TLP, because that is the singular, not the singular that manufacturer, but is the one used most for correct, for sensitivity changing correction.
All right.
So, but nevertheless, more studies are needed for more robust understanding of mechanism of this sample, for how it works, in order to improve on this application.
Thank you very much. If there are no other questions, we will have to stop here.
Dr. Latif,
yes.
Please.
You have a question?
Yeah, I'm sorry. Just Professor Olatunji is among us now.
Okay.
Last time I promised that I sent him a link to join us. He could not meet up.
Ah, okay,
Maybe
okay.
he should introduce himself and greet the house.
Please, Prof, you have 2 minutes to introduce yourself, please, sir.
Maybe we need to unmute him, I think.
Doji?
Yeah, but which?
Sunday Olatunji.
Professor Sunday Olatunji.
Sunday Olatunji. Okay.
Yeah. Yeah.
Yeah, you can just unmute.
Yeah,
Hello.
he's unmuted now.
Good afternoon, my respected colleagues.
Ah, good day, Prof. It's still not afternoon yet with us, yeah?
Oh, sorry.
You are welcome, sir.
Thank you very much, everybody, for the wonderful gathering. I so much appreciate that.
We are very happy to have you with us.
It's a pleasure for me also. Thank you very much.
You're welcome, sir.
I hope to have been around earlier, but it clashed with one of my project presentation. I just finished and I said, okay, let me join right away.
You're always welcome, Prof.
Nice being with you.
Thank you very much.
So use the opportunity to say hello to all my learned colleagues, Professor Afolabi, Dr. Nia, and all other people over there, Dr. Taurid. Thank you very much for this opportunity.
You're welcome.
Just introduce yourself, Professor, for 1 minute, so that
I know him very well. You are welcome.
Okay, it's okay.
Nice hearing your voice, Professor Olatunji.
Thank you very much, Dr. Ebenezer. It's a pleasure to chat to you and talking to you. As you can see, my name is
thank you very much.
Olatunji by name, and Sunday from. I personally work with Imam Abdurrahman Bon Faisal University, Dammam specifically, so in the Department of Artificial Intelligence. So with computer science department, but we established artificial intelligence department last year, so where we moved to that department. So it's a player, and I work in the area of artificial intelligence and machine learning with applications to several fields: oil and gas, medical, physical material properties, and the likes.
All right.
So thank you very much. It's a pleasure for
welcome,
me.
sir.
Thank you.
Thank you very much, sir.
Thank you very much. You're all welcome. Thank you.
Yeah,
thank you, Professor. We hope that you'll stay with us until the end of the conference today. Anyway, if it's possible, we would like to have you with us in the network, and we can add your email with your authorization if you like.
Yeah. It's a great pleasure, actually. It's always a pleasure for me to collaborate with my team down there in Africa, and also that's my home. And always longing also to return home by the grace of God sooner or later. So you are welcome. I'll be a big player to be on the team.
Sure. Okay, thank you.
You're welcome, sir.
Thank you very much.
So this is the end of this session. We are going for a coffee break, and then we'll return after 15 minutes, please.
After 10 minutes, not 15.
Okay.
Yeah, the coffee break is 10 minutes.
Yeah. Coffee here. I mean, within 10 minutes, I should finish it.
So we return by 11 GMT, 11 a.m. GMT. Thank you.
Yeah. Virtual coffee break.
Ok. Non, mais tu es là, non?
Yes.
Comme ça, je te passe la main.
Ok, bon, je suis un peu là, ouais. Si je
Non.
dois me lever,
Non, c'est Dame qui sera le... Écoute, c'est Dame qui sera le chairman pour la session prochaine. Après le retour, là.
Oh, non. Aujourd'hui, c'est ni moi, ni Dodi, on fera chairman. Trouvez quelqu'un.
Normalement, c'est Beltaco, là.
Trouvez quelqu'un. Dodi et moi, on a fait fatiguer. Maintenant, vous aussi faites aujourd'hui. Ou bien Dodi?
Non,
aujourd'hui. Ouais, Belte est là.
Les gars, je ne suis pas là. J'ai une réunion.
Et qui n'a pas de réunion? Trouvez quelqu'un.
Calmez-vous. Ça va aller.
Il y a Ludovic qui est là aussi.
Ah, Ludovic est là.
Ouais.
Okay, let's speak English because.
Mais hier, vous avez écrit sur la plateforme que c'était professeur Sugotier et Latif, non?
Latif n'était pas là hier, professeur Sugotier a fait.
Hein?
Professeur Sugotier a fait, mais Latif n'était pas là hier.
Ah. Parce que la session 4, ça leur appartient.
Oui, en fait, non, c'est ce qui était prévu, mais le problème, c'est que, bon, je n'avais pas vu que Prof. Sokoti était prévu pour aujourd'hui.
Bon, c'est pas grave. S'il n'y a personne, moi, je finis ma réunion vers 13h, 14h. Donc, je peux voir si je...
Non, Ludovic est là.
Ok.
Il a suivi aussi tout, non. Ah, maintenant, il a disparu. Ouais, il est là.
Ah, on a les excuses de Rick Ziki. Je ne sais pas si tout le monde avait suivi ça hier. Il a perdu un membre de sa famille. Donc, si possible, si une personne peut essayer de lui écrire un mot après pour lui présenter nos condoléances.
Dambé, tu peux le faire, non, comme c'est toi qui annonce.
Je ne peux pas. Quelqu'un n'a qu'à le faire.
Non, il est là. J'ai envoyé trop de emails. J'ai mal au doigt.
Tout ce que j'ai envoyé, voilà. Tu connais quoi? Continue.
Même WhatsApp là. Yeah. WhatsApp était full.
Continue.
Ah, ok. Welcome, Ludovic.
Il est là.
Morning. Excuse me, the internet is very bad where I am.
Now, if your internet is bad, then it will be difficult for you to make.
Yes,
to be
very
host.
bad.
Yeah. Les gars, rentrez un peu dans la politique. Au moins comme ça, vous allez développer les choses en Afrique.
Toi aussi, là-dedans.
Une fois que tu rentres en politique, on te prend et puis c'est bon.
Non, moi j'ai été réquisitionné ici en Afrique du Sud, donc je ne peux plus jouer la politique au Togo.
Mais qui t'a dit que tu peux faire politique en Afrique du Sud?
Non, ici l'Afrique du Sud c'est sérieux, même les étrangers, non, vous n'avez droit à rien.
Tu prends ta nationalité, non? Quoi le problème?
Non, je suis togolais.
Ah, donc reviens faire la politique ici. Choisis. On appelle ça une fuite en arrière.
Oh, tu sais, bon, il y a les gens qui sont nés pour être en avant, et il y a d'autres qui peuvent être en background et puis diriger les choses. Bon,
nous tous, on a choisi d'être en background.
Non.
Quoi est ton problème?
Tout le monde ne peut pas être en background, s'il te plaît.
Bon, ok, ensemble, nous décidons que ce soit toi qui sois en avant.
Oh, guys.
Bon, on a un problème. Il y a Mama Sangare qui a un gros souci aussi.
Ah bon?
Donc, il se peut qu'elle ne puisse pas. Elle est en déplacement, en fait. Et normalement, elle a trouvé le temps pour présenter, mais elle est en train de terminer son travail de recherche là-bas. Et elle a des imprévus qui ne sont pas dus de sa volonté, qui sont dus plutôt aux exigences du labo où elle est. Donc, du coup, ça va être très compliqué qu'elle soit avec nous. Donc, bon, ça fait une absence de plus.
Aïe.
On prend les autres.
So, Mr. Kolani, I've just add you to the panelists. So now you can see can you see the sharing green button somewhere? Because we, yeah.
I'm saying that is Mr. Pedano, it's not the Kolani. Okay.
Oh, yeah, I also add Mr. Kolani as well.
Okay.
Yeah.
Thank you.
So can you see the green button?
Yeah, yes, I see it.
Yeah. So who else? Let me see if I can see Mr. Bimbola, Dr. Bimbola. Okay.
Merci beaucoup, monsieur. C'est bon, c'est bon.
Bon, les 10 minutes sont passées. So if you have Dr. Sama, you can start maybe sharing your screen.
Okay.
And I will maybe ask Dr. Beltaco maybe to chair or to be the chairman, if it's possible.
Okay, do you see
there is yes.
Okay.
Hello.
Yes. Please, can I start?
Let's see if...
Hello?
Yes, Doctor. You can on vegetation cover in high radiation areas. Heat and water vaporization exchange for passive cooling purpose. So Dr. Sama is coming from University of Kara. You have the floor.
Okay. Thank you very much. Good morning, everybody. My topic change. I have a little modification. Sorry for that. Then the new title is Modeling a Vegetation Cover in Higher Irradiation Area, Heat and Water Vapor Exchange for Passive Cooling Purpose. My presentation will follow this plan. We have an introduction, the
modeling, the result and discussion, and I will finish with a conclusion. It is well known in literature that 30 to 50% of the heat gain inside the building is brought about element of the roof. And in warm climate regions, those heat gains can be very significant and induce unbearable indoor environments. Then it will be useful to reduce thermal heat gain through brought back about by the roof. That will improve greatly the thermal quality in a building. Usually, we have a conventional approach to reduce heat gain in building. It includes the improvement of the albedo of the wall and the roof of the building, the introduction of false ceiling, the ventilated attic space, the use of thermal insulation materials, the architectural modification, and the introduction of bioclimatic thermal screen. And my presentation concerns these last points. The main objective of my work is to promote the vegetation, the green roof, and modeling the heat and water vapor transfer in this complex roof. Specifically, I want to analyze the interaction of transfer in green roof and estimate also heat gain inside the building. What is why the green roof? We have some benefit that I recall here. We have ecological and health benefits. We have impacts on thermal comfort. We have landscape impacts, but we have also disadvantage, which is mainly the wage that must be taken into account during the design and size of our roof. Here are some examples of a green roof. The idea is not new. We have it this example we have it go from traditional green roof to modern one. It means that this idea is used through centuries. Here is the overview of my physical model. This model is divided into 4 parts. The first one is the atmosphere above the vegetation. The second one is the vegetation cover itself. The third is the growing medium. And the fourth is the roof, which is the concrete flagstone here for my case. And the last one is the indoor environment. To study our model, we have defined some characteristics. The first one is the Nelson number, which describes the heat transfer. It is calculated by this equation. It's 1. We have also the Sherwood number, which describes the water vapor transfer, and it is calculated with this equation. We have also modelized the evapotranspiration, who is the sum of the evaporation at the growing medium level added to the transpiration of the leaves. And the last parameter is something I call solar heat gain factor, which defines just the amount of the heat transfer to the inside of the building. For our model, we have written transfer equations completed with boundary condition and initial condition. And those equations has been adimensionalized. And after this adimensionalization of the transfer equation, the discretization by an implicit method with finite difference lead to a tri-diagonal system. As you can see, sorry. Okay, we have our tri-diagonal system. All the equations are put on this form. This system is solved using the Thomas algorithm associated with the iterative Gauss-Seidel method. We have found some results. Here we have on these figures, we have studied the effect of leaf area index on Nelson and Sherwood numbers profiles. And as you see, sorry. At vegetation atmosphere interface, the Nelson number increase with leaf area index as a function of solar flux density. I have a small problem with my animation. Okay, we have a similar evolution with a Sherwood number, and it's mean that heat and water vapor transfer at the vegetation atmosphere interface intensify with increase of leaf area index. Okay. We have studied also the effect of leaf area index on sensible head flux. And we have on these two figures, we have represented the evolution of this parameter for different value of leaf area index and local densities of sensible head flux involved in a complex way with value generally positive in the upper parts of the cover, sometimes becoming negative in the lower parts of the cover. The positive value has been obtained at a lower value of the line, and it means that heat exchange. Hello, are you hearing me?
Yes, yes, we are.
Okay, heat exchange is from the cover, the vegetation cover to the atmosphere. But for the negative value at large area index, it means that the diffusion of the accumulated heat is from the canopy twice the whole ground. I want to say the growing medium. We have studied also we have represented here the evolution, the temporal evolution of evapotranspiration for different value of leaf area index. And this value is as a function, as a function of the density population and the vertical distribution of leaf matter within the canopy. As sound density increase, the leaf area density increase, and evapotranspiration tend to increase. Now, as I said it above, we have studied also the energy transfer into the room with the solar heat gain factor that we represent here for different values of the leaf area index. We observe that a maximum solar heat gain factor without vegetation. It reached 45%, but for a leaf area index equal to 3, we have 15%. Then it means that planted roof significantly reduce heat gain in the building, and solar heat gain factor remain practically constant and less than 4% during a long period of a sunny day, as you can see it on the figure. Okay, if I can summarize this work, we have modelized a green roof, and the results are presented in terms of Nelson and Sherwood numbers, sensible heads, and evapotranspiration fluxes, and the solar heat gain factors in correlation with leaf area index. A large leaf area index reduces the solar flux penetration, stabilizes the fluctuating value, and improve the indoor environment quality. As a perspective, I think that study must continue to identify suitable plant species for West African climatic conditions for the practical building. Thank you for your attention.
Okay, thank you, Dr. Sama, for your nice presentation. And we are now ready for questions. And I think this question is very interesting since it's an environmental question. And we are in West Africa. We have a serious heat problem. So the floor is open for questions now.
Okay.
If you have a question, just raise your hand.
We have Dr. Dambe.
So thank you, Dr. Sama, for this very good presentation. I will have a question for, I would say, a non-scientific person. Okay. For example, what will be your advice, actually, for this kind of, if someone who is not scientific said, okay, I've seen your presentation, you talk about vegetal roofs. So what will be your advice to him, actually?
Okay. I can give an answer now? Yes.
Yeah.
Okay. A vegetal roof is just, it's not something very complex. It's just a small garden on the roof. I think that everybody can do something simple. If you grow some flowers, pot flowers, you put it on your roof. You can have your green roof like that, very simply. Thank you. I don't know if I have very well. Okay.
Yes.
Thank you.
Okay. Then I also had a question regarding this technique of growing flower and plants on your roof. The question is, how do you manage for the growing area not to destroy your roof?
Okay. Thank you. It's a very good question. Each time I present this work, it is always the same question. As I
Okay, I
present is
didn't know.
very simple, but in practical, we have many layers. We have after the growing medium, we have, for example, waterproof layer. We have anti-barrier. We have also the drainage layer. Then there is no problem. The technique is known. There is no problem for the roof itself. It is protected.
Okay, I see. Then I think it's very interesting if we can protect our roof against destruction. So yeah, thank you so much. So actually, is there any other question? Raise your hand if you want to ask a question, or we can just any other question.
Yeah, maybe. Sorry. So I wanted to
Yeah, you can.
know. Yeah, I wanted to know, Dr. Sama. So, what is the impact of the dramatic decrease or increase of temperature that we have? Like, let's say I've been in Senegal, and the place we were, like, during the day you can have temperature up to 40 or 45 degrees, and then in the night
Everywhere in
you
Senegal.
okay, yeah, and then in the
Very
night
dangerous.
it's super cold. So what can be the impact of this change in temperature on the system first, and how can you, is there any way that you can I don't know, try to optimize your system such that people don't feel that change?
Oh, okay. Thank you for the questions. I think that the answer is will be in my perspective, because for the plant species selections, it is very useful to found a residence plant species for the for the localization. Then I think that for everywhere we have plants, if those plants can survive, we can study to see if those plants can be used for growing on the roof. But I think that the species that are used are not imports. It must be the local species. Then I think that the problem can be solved naturally.
Okay, thank you very much.
Okay. So we thank Dr. Sama for his presentation and answering the questions. We'll go to thank you, Dr. Sama. We'll go
Thank
to the
you.
next presenter now. Syrian Madon Kenyi from Cameroon. Syrian, have you seen? I don't know whether it's a lady or. I think.
Yeah, but
anyone
okay,
have
so
seen Syrian?
No, she's not there.
maybe if she's in
Okay.
the attendee with a different name, you can just raise your hand so we can include you in the.
Raise your hand if you are Syrian. Donald, Syrian Madon Kenge. But we can start with Dela Donald Auku. Are you there? Okay.
I'm not sure she will come
Just
because
start sharing your screen before we continue.
I'm not sure
So,
Syrian will be here
Donald,
because I sent her a message and she didn't answer. So.
Okay, so let's say Donald will start sharing his screen. He will be presenting on modeling of fluid flow and heat transfer in bioreactive household waste storage facilities from Laboratoire sur l'énergie solaire, Lomé University. So you have the floor, just put it in presentation mode, and then you have the floor.
Yeah. Monsieur Oko, yeah.
Can you put it in presentation mode, Aoku? Hello, can you hear us? He's not.
Your mic is muted. Can you unmute?
Yeah, can you unmute your mic? Your microphone is not on.
So
we cannot hear you. No, not your video. Stop the video, your mic.
With a sharp.
The mic is just close to the video as well.
Now,
so just try
to Zoom. Go to Zoom.
Sinon, si tu peux appuyer sur
your presentation.
Sinon, si tu peux faire un Alt A, et si tu sais faire ça, Alt A, appuie sur Alt et A à la fois. Non.
No, click on the Zoom icon down there, and then you go to your Zoom. In French, il y a l'icône de Zoom en bleu à côté de toutes les icônes qui sont en bas de ton écran.
Oui,
clique sur l'icône de Zoom. Oui.
Apparemment, ça ne vient pas.
Non, non, ça vient, aussi... mais en fait, nous, ça vient, nous, on ne peut pas le voir parce qu'il ne partage que l'écran de PPT.
Ok, il faut fermer l'écran de PPT, comme ça, on va voir.
Réduis l'écran de PPT.
Réduis, ça, on va voir.
Ok, réduis ça encore. Non, réduis, pas agrandir, réduis.
Bon, ce que tu vas faire, hein, il faut stopper le sharing.
Le sharing.
Non, c'est bon. Clique, non, c'est bon. Maintenant, clique sur le chose Zoom.
Parce que comme Dambé dit, s'il ne partage pas l'écran, ça risque de ne pas venir.
Tu as cliqué sur le Zoom?
Oui, apparemment.
Ça passe pas.
Il n'y a pas quelqu'un là où tu as pour t'aider non plus. Donc, et arrête le sharing.
Attends.
Le partage, tu l'arrêtes.
Non, attends. On va essayer un truc. Dodi.
Ouais.
Clique sur, va dans Participants, dans les participants là. Tu fais Ask to Unmute. Non, il va lui faire un signe.
Oui, bon, je pense que j'avais déjà fait ça. Hein.
Fais ça, je crois que quand on fait ça, il fait un signe pour montrer où est-ce qu'il faut unmute.
Ah là, c'est bon.
Voilà, c'est bon. Tu peux parler, on t'écoute. Tu peux parler. Aoku?
Can you hear us?
You are unmuted. You can talk now.
Maybe we go to the next presenter and then we'll follow up with him. So,
Betako?
Yes?
Are you at the department?
Yeah, but I'm at the department, yes.
Awuku is there also?
No. I don't know. Maybe he's in another office, but
another room. If you want, I can make the chairman for the next presenter, and if you can find him and help him.
Yeah. Okay. I'll try to do that.
Okay. So I'll do the chairman for the next presenter. Please, next presenter, is it possible that you do your presentation now? It's Kolani, no, what am I saying? It's Dr. Olaremu Abimbola. Olaremu Abimbola, yes, he is with us. Please, is it possible that you make your presentation time that Dr. Oku Mr. Oku try to correct?
Hello.
To be connected. Yeah.
It's not Mr. Kolani. I said it's a Pedanu.
Huh?
It's Mr. Pedanu. After.
No, after Oku is Dr. Abimbola.
And after Dr. Adebola is Mr. Pedanu.
It's Pedanu. Yes. But for the moment, it's Abimbola who should make his. Dr. Abimbola.
He is sharing his screen.
Okay, great. Yeah. Thank you for your cooperation. We are sorry for
any mic.
We are sorry for this. You know, it's the problem with online conferences. I think you should activate your mic. It looks like you don't have a mic. Oh, quite.
Dr. Abimbola, can you please check in the settings if your mic is connected?
Yeah, it looks like your mic is not connected.
So just go to the settings.
We have another problem again. Dr. Pedanu, prepare yourself. I think if this one takes time, you will be the next one. Right?
Hello.
Yeah, prepare yourself in case Dr. Olaremu can't activate his microphone. You will be the next to present. Is okay?
Oh, okay.
Okay, great. Thank you. Dr. Bimbola, can you share all your screen so that we to activate the mic? Try to share all the screen, not only the PPT, and then we can try to see if we can help you to activate the microphone.
So, Dr. Abibola, so when you want to share your desktop first.
Yeah, okay.
Yeah, please share your desktop.
Dr. Bimbola, are you with us? You can, if you have some problem, you can write in the chat also. We are following. If maybe we can help by the chat also, because actually we have no word from you, so it's difficult to know if what we are saying is useful or not. Dr. Bimbola, are you with us? That's right. Maybe you are not hearing us. I don't know.
He shared the presentation again.
Can you minimize your the PPT, please? Just minimize it, the PPT. Great. Yeah, it looks like you have a bug. No. Is it the video is lagging or? Okay. No, the video is not lagging. You did not minimize the PPT. Can you minimize it? Did you minimize it? Is it minimized on your screen? Just write on the chat, please. It looks like you are sharing only the PPT, I think. You should stop the sharing and share all your screen, not only the PPT. When you hit the share screen icon, you have the choice between Aoko, tu es connecté avec deux trucs, c'est pas bon. Ah non, c'est Pédanou qui est revenu avec son chose. Okay. No, this is the whiteboard you have shared. No, this is just a whiteboard. This is not a screen. The whiteboard is something you use for if you want to make a lecture.
So the desktop is the first left, the first icon when you want to.
When you hit the share screen, the first one, choose the first one.
Exactly.
Great. So now open your Zoom.
Now if you go to Zoom.
Yeah, select Zoom. No, it's down. Select it down on the bar. Yeah.
Did you click on Zoom?
It's the blue icon on the bar down on the bar detach. How you say it? I don't know. No, not the PPT. The blue icon next to the PPT icon.
Maybe if you can maybe find someone.
Minimize this screen. Minimize the PPT.
C'est la présentation que vous avez.
Okay. Put the mouse down. Go down with the mouse. I will show you. Go down. Okay. Okay, left, small, slowly, yes, no, yes, this one. No. No, right, yes, this one. Yeah, select the first one. Select the first, yeah, great. Okay, select the second one now, please. No, go down to, no. Go down where you were, when you was. Yeah, okay. Click, select the second one. Yeah. It's not coming.
Okay, let me maybe try something.
Yeah.
Maybe I will share my screen and show him. So, can you see my screen?
But he is not writing anywhere in the chat also, so I don't know. I think there is a problem.
Can you see my screen?
There is the video resolution which is lagging. So, Dr. Bimbola, please look at the video. He's showing you how to do it.
So when you come here, you select this.
Please do it by selecting down on the dans la barre des tâches.
Okay, let me close this first. When you come to Zoom, so this is the.
Tu vois, ta vidéo lag beaucoup.
Ah bon?
Ouais.
Bon,
en fait, la fenêtre vient, mais ça met du temps pour faire la génération de l'image.
Okay. Can you maybe do it?
Okay, let me try.
Alternatively, if.
Okay, let me try to show you how to do it. Okay, I will share my screen. Okay, are you seeing my screen? Is everybody seeing my screen, Doji?
Yes, we can see.
Okay, so Dr. Bimbola, this is how to do it. So you have your screen, okay? You have this icon here, okay? It's almost the same thing with you, okay? You have this one, which is the first one that you were selecting, and that is not the good one. You have to select the second one, okay? So I select the second one. The problem is that when I'm sharing my screen, when I select the second one, it shows me something like this, okay? And that's normal. So this is the window that I need to go, I want to have. So here is the microphone, okay? So here you can activate it here. And if you don't have this icon of the mic, that means you don't have a microphone. Or she should told you that your microphone does not exist.
Yeah,
okay.
But now we can't see your. Yes, also.
You cannot see this?
Because you are already sharing now.
Okay, that's the problem. Or maybe the another way is to go here. I don't know if it's possible. Okay, when you go here, normally it should tell you that you have a speaker and a microphone or not. I don't know. It's a little difficult to show it here. So let's go with another one, and we'll see how to do it after. So I think Awuku is back. Awuku, can you try it again if you want?
Allô?
Yeah. OK.
Tu peux essayer?
Oui, tu peux essayer. Vas-y.
D'accord.
Il y a quelqu'un d'autre qui est dans la salle avec toi, qui a le même, qui est sur Zoom. Il n'a qu'à désactiver son micro. Ça crée du larcène, quoi. Ça crée du larcène, c'est à cause de ça. Et puis, toi-même, tu as aussi un deuxième appareil qui est connecté dont le micro est ouvert. Ça, c'est pas bon.
D'accord.
Ouais, il faut désactiver le micro de ton deuxième appareil qui est connecté. Ou tu éteins ça carrément.
Attends, je vais voir.
Ah, voici, tu peux couper sur le deuxième appareil. Okay, good. Now we should have less Larsen. So go on, Auku. You can share your screen now.
Il ne t'a pas encore donné.
Yeah, l'autre. Si, normalement, tu dois avoir tu dois avoir l'onglet.
Il faut l'autorisation.
Si tu l'as.
Oh.
Non, avec voilà, c'est pas.
Tu as l'autorisation avec le truc que tu utilises. Hein. Tu vois l'ordinateur que tu utilises actuellement pour nous parler là.
Oui.
Tu as l'autorisation dessus. Parce que tu es connecté à deux choses en fait. C'est pour ça que si tu ne fais pas attention, tu vas aller faire autre chose. Tu vas aller utiliser l'autre. C'est pas bon.
Can you try again, Mr. Can you try?
Okay. Partage.
Bon, ok.
Partage.
Oui,
ouais,
partage.
Voilà. Oui, partage.
Votre navigateur, il faut le... Oui.
Il dit quoi?
Il dit votre navigateur bloque l'accès au partage. Condition.
Ferme le navigateur. Ferme le navigateur.
Est-ce qu'il n'utilise pas le navigateur pour se connecter à Zoom par hasard?
Oui, c'est le navigateur que j'utilise sur ce PC.
Donc, quand tu vas activer le share, quand tu vas activer le partage, normalement, le navigateur va te faire une icône pour te demander d'autoriser. Donc, appuie sur partage et regarde en haut du navigateur. Il y a un petit pop-up qui devrait arriver et te demander d'autoriser le partage. C'est juste un truc de sécurité pour éviter que quelqu'un ait accès à ton navigateur, en fait.
Vous pouvez répéter?
Je dis, quand tu vas cliquer sur le partage, normalement, en haut du navigateur, il va te dire d'autoriser le partage.
Oui, ça ne s'affiche pas. En fait, c'est ce qu'on a fait au premier abord. Après, il dit que c'est bloqué. Puis que quand on l'a fait, il a dit autoriser le partage. Déjà, quand on essaie de faire ça, on ne voit pas la main. Et maintenant, il dit que c'est bloqué. Donc, on va essayer de refaire ça.
Ah, ou bien la première fois, vous aviez cliqué par accident sur non.
En fait, il ne nous a pas donné la possibilité de cliquer sur autoriser pour la première fois.
Vous utilisez quoi comme navigateur?
Firefox.
Firefox.
Oui.
Attendez.
Can we maybe see with the Kolani?
Hello?
Oui. Donc, juste, allez dans les options de Firefox, OK? Tu vas dans les options de Firefox et tu vas dans vie privée et sécurité.
Allez dans l'option de Firefox.
Oui.
Please, can we maybe move to Mr. Apedano?
Yeah, yes. But the problem is that they will still have the problem after.
No, I will contact him inbox.
Okay, great. So, Dodi will contact you to help you after. So, Mr. Apedano.
Yes.
Yeah, can you make the?
Okay, I am fine.
Okay, great.
Can you hear me?
Yeah, I can hear you.
Do you see my screen?
Of course, very good.
Okay.
So we will have now finally one presentation. So the presentation of Mr. Ganyo Kofi Apedano, who is working on the numerical modeling of mixed convection in the Azuto improved cook stove. So he's from Laboratoire de Energie Solaire, okay? Solar Energy Laboratory at University of Lomé in Togo. So you are welcome, Mr. Apedanu. You have 15 minutes for your presentation.
Okay, thank you. As you said it, my name is Apedanu Kofi Gagnon. I'm a PhD student at the University of Lomé, and I work in physics, energetic, and application. I will presented on numerical modeling of mixed conversion in the Asuto improved cook stove, and this is the plan of my presentation. I will begin with an introduction. I present the geometrical model, the mathematical model also, and we present the results and discussion, and end it by conclusion. According to WHO report in 2020, more than 3 billion people still depend on polluting energy sources for cooking, the use of wood and charcoal. And this is unchanged for 10 years ago. You have consequences on the ground cover. These make pressure on the ground cover. And in other hands, we noted 3.8 million of premature death each year caused by indoor air pollution due to cooking. This pollution is essential due to solid fuel, the use of solid fuel as wood, charcoal, with traditional cook stove or fireplace, and open fires. I give you here some data on this statistic. You have 18% of these premature death due to cerebrovascular accident, 27% of due to heart diseases, 20% due to chronic obstructive pulmonary diseases, 80% due to lung cancer, and 27% due to pneumonia. Okay. Before people will have access to renewable energy as photovoltaic, which is promoted now, a transitional solution for this situation is the use of improved cook stove with optimized performances and minimized emissions. To do this cook stove, to make this cook stove, we have two approaches. You have an experimental approach, which is too expensive, and you have also numerical approach, and validate with some experimental data. And now, so the purpose of my presentation is to study the mixed conversion, the hair draw in the geometry of one of the most popular cook stove in the sub-region, which we call the Jiko or the Asuto. Some person call it Toyola cook stove. I will present here my results as a term of streamline isotherms, profile of the speed U and V in the geometry and the temperature, and also the humidity profile. That is the geometry of Asuto stove. We have here the inlet, and the Asuto stove is subdivided in two regions. You have the first region we call air draw zone, and the second region is the combustion zone. This is in this region we have a charcoal which will burn to produce energy, and the two regions are separated by a grate. Okay, to have a good combustion, which will lead to a good efficiency of the combustion, and to minimize the emission due to the combustion of charcoal, we need some quantity of air draw through the first zone. And my aims here is to simulate the air draw in this region after in the combustion region zone, to know the quantity of air draw we can have when we modify the geometry of this cook stove. And to modelize this, we use Navier-Stokes equation. Here are the continuity equation for incompressive flow. You have here the flow motion equation in x direction. You have here also the flow motion equation in y direction. There are the heat exchange, the heat transfer equation, and we also modelize the water vapor equation here. We added to this equation initial condition, some initial condition, and the boundary condition also. We use the vorticity formulation as a function of current. We dimensionalize this equation and discretized by finite differences method. The ADI method, alternating direction implicit method, was used, and we solved the equation by the iterative method of Gauss-Seidel. We programmed this with Fortran language. Okay, and then we have our result, and we validate our result with the result of Eden. Here we have the present work, our work. This is the stream function, which we compare with the stream function of Eden. You have also the isotherm, which we compare here with the isotherm of Eden. We add in our work, we added to the equation the water vapor, and this is the humidity also, which is the ISO value of the water vapor. Okay. We've simulated now the air draw in our cook stove. Here is the inlet, the air enter into the cook stove through this hole, and you have here the stream function, which show the line of the air in the cook stove. You can note here some recirculation in the air draw region. Okay, here it is a speed, the profile of of speed u as a function of x in different heights of the head row region. You have also the profile of the speed v as a function of x. Here is the profile of temperature, and here the profile of humidity. And in this figure, you have the profile of speed as a function of y or z. Okay. We have here the profile of speed also as a function profile of speed v as a function of z. You have here the profile of temperature as a function of z, profile of humidity as a function of z, and also we put the profile of speed u and v as a function of x in the combustion chamber. Here is the profile of temperature as in the combustion chamber as a function of x, and also the profile of water vapor or humidity in the combustion chamber as a profile of x. Okay. I can summarize now. In conclusion, we noticed that our results are in good agreement with the Eden results. This shows us that our code is usable for the optimization of the head row in the cook stove. We noticed also some recirculation in the draw zone. We must therefore optimize the geometrical parameters of our fireplace in order to avoid them, because if you have recirculation in a combustion chamber is good, but have recirculation in the head row region will not it's not good. Okay, in the continuity of this work, we will couple the combustion chamber with the combustion chamber, which will be modeled as a reactive porous medium to the air draft zone in order to directly obtain the efficiency of the fireplace. Okay, thank you for your good listening. Hello.
Okay, thank you.
Okay.
Thank you, Mr. Pedano. So the floor is now open for questions. If there is any question for Mr. Apedano. Is there any question? You can post your question in the chat or just raise your hand. Then we'll see. Or maybe your work is well understood.
Okay.
I have
okay, yes, go.
Mr. Sama.
Dr. Sama, yeah.
Okay.
Thank you. I want to thank the presenter. I think that the topic is very interesting. And I have a small question for him, just to understand. If we take his model, I know that we have the upper part who represent the combustion chamber, and
yes.
the lower one who
yes.
is the admission. For this stove, I don't know. Usually, I think that between them there is a separation, which is made in, I think, something which is
a grid.
a small conductivity. Do you take into account this separation, or just it is a whole?
Okay, in the to separate the combustion chamber to the air draw region, they use a ceramic grate.
The ceramic grate.
Yes, they use ceramic grate.
Okay, yes.
Okay, they use ceramic grate. Now, in this work, we don't take account to the ceramic grate.
Okay.
There is a hole, but in the continuity, we take account to this.
Okay. Thank you very much. Because when I see the streamline,
yes,
I noticed that there is a hole. If not, it is not possible. Then, as you say that there it is a hole, then thank you, and I think it's a very good work.
Okay.
Thank you very much.
Hello, I have a question.
Okay, thank you, Dr. Sama. Professor Falabi.
I have a question.
Yes.
The presenter talked about improved cook stove.
Yes.
Right? When you're looking at the stove, what fuel can be used? And can I see the picture of the stove? Then is it what fuel is it using, and how is it environmentally sustainable?
I don't hear you. I don't hear you. Well,
so
what fuel are you using? What fuel? Is it diesel?
But
is it diesel? Then you said you have it's an improvement. What is the
input of the?
The input of
is it charcoal? Is it gas? Is it electricity?
Okay.
Yeah. What is the?
It is charcoal. It is charcoal. It's charcoal stove. Why?
Can you come again, Prof?
Is the improvement based on the consumption of fuel or the emission of pollutants?
Yes.
The improvement, what is it based on? Is it because it can use bypass fuel source?
Yeah, his question is your calculation was to improve the consumption of charcoal or to improve the emission of gas.
We aims to improve the consumption of charcoal and also to minimize the emission of pollutant. We aim to do the two. Optimize the consumption of charcoal and also optimize the emission.
Okay.
Yes.
Okay, thank you.
Hello. So hello.
Yeah.
In
You
that
can
case,
ask
we want histogram. Okay. Time history of your improvements on pollution, and then the quantity of fuel that is consumed for specific work. You understand? Histogram of the development. We want to see the comparison, the histogram. You understand?
Okay.
Yeah.
You don't have that one.
No. He's talking. No, this is another histogram. He's talking about the evolution of your improvements. For example, you can put a histogram of what people are doing usually and how much charcoal they consume. The volume of gas emitted. And after your improvement, after your calculation, how much charcoal you think you need and how much, a kind of histogram to visually see the improvement.
in this present work, I don't present this, but now people who use this cook stove, the efficiency of the stove is at 20 or 27%. But in our work, we aim to attempt half or 50%. Yes.
Okay. Thank you.
Okay.
Okay. So is there
Another
any
question?
any particular reason that you use Fortran? Is it something particular to that, or is just
particular to?
Is it something particular that for the use of Fortran, or is just Fortran which is available?
Okay.
No, because why I'm asking is because
yes, I understand you. I understand you. This work can be done with MATLAB. Can we with Python language and also other some logiciel Flint also you can use this, but at the University of Lome they don't accept this. If you use Flint, they call it I don't know, hein. En français, ils appellent ça, oui, ils appellent ça boîte noire, que tu ne sais pas ce que tu as mis dedans.
Ok.
Voilà, donc c'est à toi même d'écrire les équations de programmer.
No, that's true. That's true.
Yeah.
Okay.
So
No,
my question was about, so it's because like most of the time people decide to use Fortran or C because maybe the calculation are maybe very big, so they don't want to use some advanced programming languages like C, like MATLAB. So that's why I was asking. But then you still have some open source languages like Python. I think Python is like a very good environment, programming environment. But then
I think there is, okay, this is a big subject, but I think there is also something to consider is that in a lot of labs, there are already some functions that has been written in the past by your supervisor or by another PhD student that you may need. So it's difficult usually to change one programming language because of this. This is the first thing. The second thing is that the lab can decide that they need to have their own tools. That's why they don't want the black, the black, how you call it, the button or the.
But Python is not a black box. Come on.
Yeah. Python is not a black box, but the problem is that Python is very, in quotes, young, and a lot of our professors don't know it. So it's a little complicated. Yeah.
So I think we are now on lunch time.
Okay.
No.
Yeah. The problem is.
Mr. Kolani can present quickly, and then we go to lunch.
Thank you.
Is it possible?
No, I think we can have lunch. So we during the lunch we can then focus on those two presentations that were missed.
Okay. Okay, let's have lunch, and if everybody is okay with that, and then during the lunch we try to resolve the problem of Dr. Bimbola and Mr. Aoku. Is it okay for everybody, please? And maybe we can try to have 50 minutes of lunch so that we can be on time a little, not end too early, too late. Sorry.
Okay. So let's say we'll be back at
1 p.m.
1 p.m. Okay. And sorry for the disturbance. Is it even? It's not even. It's a technical problem actually.
Yes, technical problems. So
Now let's come back.
Yeah, please, Mr. Kolani.
What do you say, Gan? Any present it, huh?
No. No presentation now. For the moment, we will try to resolve the technical problems.
Okay.
Yeah. So let's start the presentations. The presentation will restart at 1 p.m.
1 p.m.
Yeah. 1 p.m. GMT.
So we still have another 45 minutes to rest.
Yeah.
Yes.
Okay. We are waiting.
It's the lunch time.
You can take coffee, you can take lunch, you can take whatever.
Okay, no problem.
Whatever you have. Yeah.
Thank you. So, Mr. Kolani, let's be sure that everything is good also with you before. Can you activate your microphone? We want to be sure that it's good for you.
He runs away.
Mr. Kolani?
Yes.
Activate your microphone.
Est-ce que...
Essaye d'activer ton microphone.
Ouais, il a déjà activé, je pense. Ah non.
Faut parler.
Non,
Oui. I understand you.
Ok.
Ah, good. Ok, donc ton micro fonctionne, ton partage fonctionne, c'est bon. Tu peux couper. On va maintenant aller avec Apédanou. Non, c'est pas Apédanou, c'est Aoukou.
Non, c'est pas Apédanou, c'est Aoukou.
Aoukou.
Est-ce que quelqu'un...
Abimbola is back.
On peut aller.
Abimbola is back. Dr. Abimbola.
Ok, on va commencer avec Abimbola et puis bon.
Yeah,
we can hear you now.
You can hear me now.
Yeah, it's a bit low, but
yeah. Can you be good. Close to the microphone, please?
Okay.
Yeah. Kolani, coupe ton micro.
Pardon?
Coupe ton micro, s'il te plaît. Ah, merci. Yeah, Dr. Bimbola?
Yes, I'm online.
Yeah.
Okay, now we can hear you.
Are you far from the microphone?
I am closer now.
Okay, good. It's a little better than the beginning. Yeah, we can hear you. It's a little low, but it's okay. We can hear you.
Okay, thank you.
Yeah. Okay, thank you. So now let's try to resolve the. Let's try now to resolve the problem of Mr. Oku.
So Dr. Abimbola, is it Abimbola?
Yes, it's Abimbola. Yeah.
Yeah, Dr. Abimbola. So we finally decided to have the break for lunch.
Oh.
So you'll be presenting after lunch. Is that okay
at
for you?
At 1 p.m.
That will be by what time?
1
Hello.
p.m. 1 p.m. GMT.
Okay. Can you see my slide clearly now?
Yeah.
Yes.
I think it's fine now. Yeah, it's fine.
Okay, thank you.
Yeah. You'll be presenting at in 45 minutes. In 40 minutes now.
Okay, thank you.
Okay, thanks. So you can stop your sharing, and we'll try to go with Mr. Uku.
Okay, thank you.
Yeah.
Où sont les dossiers?
Monsieur Aoukou.
Oui.
Okay, I should stop the sharing.
Yeah, you can stop.
Ok, Aoukou, on va essayer de voir.
D'accord.
Donc maintenant ton micro fonctionne. Donc, est-ce que tu as pu voir pour l'autorisation?
L'autorisation, je suis en train, puisque ça ne marche pas. J'ai changé de PC, j'ai changé d'ordinateur.
Ok, mais tu es toujours sur Firefox, c'est ça?
Oui, c'est toujours Firefox ici aussi.
Ok, je vais partager mon écran et on va essayer quelque chose voir, ok?
D'accord.
Attends, je partage mon écran.
Vous n'avez plus de problème. Il faut essayer de partager seulement.
Vous voyez son écran? C'est bon.
Ah, attends. Ok, je vais stopper pour moi, on va voir. Ok, partage ton écran.
Partage ici.
Ok, super. Donc maintenant, tu peux ouvrir ton PPT, on va s'assurer que c'est bon.
Je pense que c'est bon.
Donc, tu l'as en bas dans la barre des tâches déjà, non? Tu vas
Non,
où?
c'est pas pour moi.
Ah, ok.
C'est pas pour moi.
Bon, tu peux toujours essayer ça.
Ouais, tu peux essayer ça en attendant d'ouvrir le tien. Oui, c'est ça.
On dit d'essayer avec ça en bas.
Ah, ok, d'accord.
Oui, en attendant d'ouvrir le tien et puis.
Comme ça, on sait que bon.
C'est bon, ça marche. Oui, ça marche.
C'est bon.
C'est bon. Maintenant, on peut aller manger. Tout le monde est réglé. Le problème de tout le monde est réglé. Ou bien, il reste qui encore? On a, we have a question. Akinyemi Tomiwa, add me to the panelists for the next session, please. Okay, you are coming. You will be presenting. Let me see. Akinyemi.
C'est quel Aoukou? C'est celui qui a fait CIC ou bien?
C'est Aoukou, notre collègue.
Ah. Je me rappelle, non.
Ou bien c'est pas lui, c'est celui avec qui on a fait, non?
Oui, c'est ça avec moi.
Ah, ok. Ouais, ça fait longtemps.
Okay, Kinyemi, okay, he will be present. Okay, we will add him. Kinyemi will be presenting. Kinyemi is in attendees.
Yeah.
Okay. Akinyemi, please. You are connected with two devices. Can you deactivate one so that we can know which one you will be using for your presentation? Please disconnect yourself from one of the devices, and then we can know which one you will be using.
Tu peux fermer mon PowerPoint.
Bon, monsieur Aoukou, je vais enlever l'autre compte là qui ne marche pas. Hein.
D'accord.
Comme ça ne va pas nous créer des problèmes après.
D'accord.
Dr. Tomiwa. Dr. Kinyemi Tomiwa, are you with us?
I think he left.
C'est qui ne marche pas.
Let me try again.
Tu veux quoi? Si tu veux aller en truc que tu me dis, il y a seulement l'icône si tu cliques sur ça.
Mais il y a FC qui permet de faire ça maintenant aussi.
FC, où est-ce?
FC, mais si tout ça ne marche pas.
Okay, I think Dr. Akinyemi is there.
Yeah, he's there, but I don't know.
Oh, shit, I don't know.
I just wanted him to deactivate one of his devices, but I think he done it. Let me see.
Yeah.
Yeah, it's okay. I think he done it, right?
Yeah, he did.
Yeah. He did, yeah. Okay, good. So the good one is in panelists. So you can activate your microphone and talk if you want, Akinyemi. Now you have the rights to deactivate, to unmute your microphone.
So Dr. Mama Sangare is not there.
No, she cannot be with us.
Prof. Sukuti. I saw him before. Okay. Mr. Amuzovi Inyao is not there.
Regardez dans l'autre document que tu as pris, c'est toujours capture d'écran. Oui. Dans le mémoire qu'on a utilisé. Capture d'écran, ils ont fait déposer et ils ont ajouté, mais ils n'ont rien donné leur résultat. Quand tu fais capture d'écran de ça, là, ça ne va pas être bien. Non, je vais te montrer le document là. Arrêtez l'audio.
Okay.
What are you saying?
Only the president is the AOC. Hello, Tomiwa. Hello.
Hello,
Olare,
hello.
what is the problem? What is the problem?
Okay, Dr. Lasheni.
Yes, this is Shola Fayoshi.
Oh, Mtomi Abi.
Akiyemi Tomiwa is on the line.
Okay, test microphone.
Sir?
Are you in Togo?
Sir?
Are you in Togo?
Yeah?
You are presently in Togo.
I hear you. No, I'm Tomiwa.
Dr. Tomiwa.
Tomiwa Akiyemi, yes.
I was on flight.
Sir?
I was on flight.
Very fine. We thank God.
Oh, good, beautiful.
Great.
So when am I expecting you back in Nigeria?
Very soon, anytime you are around, just let me know. I will just come and pick you up anywhere you are.
Just let me buy something good from
Please.
Thank you very much.
Can you guys be serious for once?
So, when you are back, I'm ready.
Oh, beautiful. My regards to director, our
Can
director.
Are you see my screen too?
Can you guys be serious for once?
Is Dr. Fayoshe there?
Okay.
Dr. Fayoshe.
Can you guys be serious for once?
Okay.
Director there. They cannot hear me before, but now they can hear me clearly.
Sir?
What was the problem?
I have to change my system.
Oh.
I have to change my laptop.
Okay.
Yeah.
Yeah, that's the challenge with our online meetings. So
Break everything. Break everything. So they want to be too seriously in the math. Math, you don't break it. Only on the mathematics. You don't break mathematics meta. Why? Statistics, we do a lot of. No, most mathematics, we do a lot of. 2 point, to do a growth. Only one, wow. Wọ́n ṣe lọ ṣe bí méjì pẹ̀lú bá ṣáṣẹ lọ ní pé so they are recruiting the man ẹ̀gbọ́n ti gbàgbà tí wọ́n jáde. Gbàgbà tí wọ́n ti close ti pẹ́ báyìí wọ́n má ṣe wà lórí recruitment yẹn tí if not because of the housing strike. Wọ́n ní kó ṣàánú nǹkan yìí sì ní school wáyé. Ọ̀dà pọ́lọ́rẹ̀ mi gbóhùn ó ti lọ rí laptop mi lọ. Ok, ẹ kọ́ lè rí laptop.
He said you add it to panelists.
Also understand, Abi. Okay, well, I think you.
Donc, ouais, ici, normalement, c'est plus. Ça serait recommandé les commandes normalement qui vont tous être mis après sur du 12 volts. Comme ça. Bon, moi, je voudrais même essayer de trouver. J'ai vu qu'il y a des relais qui peuvent être commandés à 5 volts.
tous ces élèves soient convenables, soient progressés.
Non, eux, voilà, eux, en fait, l'idée, c'est qu'ils vont être commandés par la rue. Donc, on va utiliser une des sorties de la rue. Donc, il va être juste en place. Donc, cette sortie de la rue, on va être ou bien on va dire non, on va utiliser 10 sorties. Voilà. On a utiliser 10 sorties différentes. C'est-à-dire que donc, ça va être juste un poste comme ça. Et le temps du poste va être le temps de la musique. Donc, on va dire ça fait digital output. Donc, c'est nous qui déterminons le temps. On active, on active. Donc, là, on va programmer donc, toutes les heures, ou toutes les 2 heures. La biologie envoie un poste, il envoie un poste dans le poste. Donc, là, maintenant, c'est à nous de chercher les réponses.
On essaie d'avoir, pour que le tout soit opérationnel à tout niveau. On va mettre, on peut avoir une feuille de référentiel de parce que si on se base sur ce mobile pour faire ceci, et le réseau ici n'est pas important, c'est-à-dire que si on change de mobile, on risque de ne pas avoir.
Bon, on peut partir sur vraiment les balles, puisqu'on sait que de toute façon, si la licence est très c'est pas que voilà. Donc, de toute façon, c'est qu'il n'y a pas de panneaux. Est-ce qu'il y a des panneaux qui ont des sorties de plus de 40 ans? Je ne pense pas. Ça n'existe pas.
Ça existe, mais ça dépend. Ça dépend. Il y a des panneaux qui sont personnalisés.
Ah non. Mais est-ce que c'est cool?
Non, c'est pas. Ils ne sont pas
comme ça, en fait, on prend la distance minimale jusqu'à la distance qui peut aller jusqu'à 40 km. Et on prend la distance entre les deux. Ce qui fait qu'on a pas mis la comme c'est le fait, je me dis qu'il y a des gens qui vont vouloir rentrer ou des gens qui comme le médecin qui vont vouloir rentrer pour acheter les choses. Et puis on a on le paye pour qu'il nous balance. On le paye. Donc si tu peux faire un schéma complet et nous dire exactement
parce que il y a un autre qui doit être là, qui décide.
Ok, parce qu'il y a quelqu'un qu'on le présente.
Qu'on le présente. On a mon appelé.
Il représente là, non?
Donc, si tu dis qu'il rentre dans une protection en sortie, on va avoir apparemment quelqu'un qui une carte qui peut nous donner une information. Sortie digitale. On va voir. Si on utilisait une astuce des choses linéaires. Parce que j'avais vu aussi des gens qui utilisent aussi pour faire du binaire. C'est-à-dire on a dans ce cas en série. Si on fait ça si on a 3 sorties, on a possibilité de...
Bonne. Ah, coupe daddy.
Combien de combinaisons? C'est de puissance 3 en plus. Vous avez aussi enlevé des choses.
Which one? On peut les faire finir. On va estimater bid. On peut faire 2000.
C'est de puissance 7. Voilà. Donc, ce qui est 3, je peux m'arranger à ce que lui et lui me donne compte, ou c'est lui et lui qui me donne compte. Ok? Ou c'est lui et lui. Ah non, c'est pas de puissance 3, puisque il y a l'ordre de compte. Si l'ordre de compte, ça fait de puissance 3. Parce que si l'ordre de compte, lui et lui, c'est pas.
On compose chez moi. Ṣé mo lè lọ ra káàdì pẹ̀lú nọ́tọ̀ọ̀kì mú wá kí n lo náà 7,000 naira lóṣù? I don't think they are serious.
Ọ̀dọ̀ wa báyìí wọ́n tẹ ẹ̀ tí ẹ̀ pé.
Ça veut dire quoi? Ça veut dire que.
Wọ́n tẹ ẹ̀ tí wà bá mi báyìí.
Wọ́n ti wà báyìí. Ṣé ẹ ti faná wọlé?
Ìjọ tí mo ti dẹ̀ mo ti faná wọlé. Ìjọ tí mo ti débẹ̀ ni mo ti faná wọlé. Torí táìmù kìíní mo máa nídìí àti reduce slide. Àmú láti compress figures. And graphs in pause. So I just selected about 6 for discussion.
Non, c'est bon. C'est bon.
I think.
Okay, man. I want to be love me.
Et donc, en fait, par rapport à l'entrée, il active les sorties. Il génère un signal de chose. Donc là, maintenant, ceux qui sont dans la
Okay, but we are going to present. Kogalo present.
We are going to present.
So I think he has issues with his network. Boni. When are you presenting? Okay. Our on grant. Okay. Oh, yeah, I'm going to present this thing.
Present.
By you.
She work with me at last.
You know what I call change the laptop.
Laptop.
Okay. I didn't see you.
Okay. Well, anybody?
I can see you.
Okay.
So, it's online.
Protocol was looking by you. I'll update you.
But I think the network is from their own end.
Department, because I'll be update.
Dr. Tomiwa, can you hear me?
Sir? Alarm, go and sit down.
And he's on now. I can see him.
Alarm. Ìjẹ̀bú ló yẹ kó ti wá Ìjẹ̀bú. Ọmọkùnrin yẹn lárò tó yẹ pé. Àtúmọ̀ kan tí Simon máa sọ báyìí pé wọ́n fi sanwó. Ta ló pè yín? Kò pè mí. Kí lẹ rí? Kò sí àwọn ọmọ mi pé ó gbé àwọn méjèèjì kan tó ṣe lánàá. Àwọn méjèèjì yàtọ̀ àdàkọ ló gbé sí lánàá. Kò dẹ̀ ń kó àwọn èèyàn rò pé bẹ́ẹ̀ lè bá tẹ̀wọ̀n mọ́ṣá. Ẹni ẹni ló tù sí English oníkó wà specific. Ọ̀. Ẹni tó lè jà ẹni tó lè bá ní sẹ́ẹ̀lì ìjàmbá yìí kò ní dìde ìlẹ́wọ̀n. Wọ́n bá ìyàwó ẹ̀ tó wọ́n lálá máa bèèrè lọ́wọ́ sísẹ̀ pé kí ló dàn sanwó. Ìgbélé tó ṣe wọ̀nyí pé ayé ni. Comme ça, si le coup ne touche pas les deux là. Pardon. La date, l'heure, VOC, ICC, facteur de forme, V, max, puissance, si tu le colles. Wọ́n ló sọ pé mi ò wá sọ fún ọ̀fíṣíálì pé mọ́dà mi kú. Pé àfún àṣìṣ kan sáà pé òun wà wí àpéyà mi kú. Mo ń sọ kó bàa lè wàrà màálù àbí kí ìyá ń bàa lè dọ́rùn. Il y a un capteur qui a trois Àjọ olóṣèlú. Ṣé dáadáa sí jìnnà? Wọ́n ṣe dáadáa fún náà. Wọ́n ṣe dáadáa sí náà. Torí doc jìnnà dúlẹ̀ ní tiẹ̀ lọ́wọ́, but it's not being treated fairly. I'm not exonerating him of something, so, but sincerely, he's not being treated as secretary. You are àwọn ló ń ṣiṣẹ́ iṣẹ́ tó yẹ kó ṣe àwọn ló ń ṣe ìràbó ló ń ṣe vice ó ń ṣe secretary ó tún ṣe welfare esco náà ní wọ́n rí yan fíìlì esco náà ẹ̀yin bẹ́ẹ̀ ilé ẹ̀kọ́ conduct election.
Et par contre, on ne lève pas la première colonie. Non, c'est pas la première colonie. Le code. Donc, c'est juste la date. Et la date, je ne sais pas comment. La date. Nous, c'est juste la date et parce qu'il va falloir encore peut-être. Pour vérifier à l'internet, pour être sûr que
On est à jour.
Spécialement. Ginodo. Máa ní òní kọ̀ọ̀kan ní fún èdè o. Báwo ló wà lábí? Ṣọ́làbí lè ọlọ́dá yìí ṣó lè ní péjì ṣá. Ilé ẹ̀ka ló sì yẹn ló sọ fún mánéjìmẹ̀ntì sùúrù. Mọ̀ bí ó sùúrù náà ti pẹ́ tó yan tó 40 years. Okay.
Hello. Do you have Mr. Awuku? Do you have Mr. Awuku?
Yes.
Okay. Okay. Maybe you can start sharing your screen. The time for people to get in.
It's okay.
Yeah, it's fine.
Okay. I begin.
Yeah, I think we can. Yeah, I think we can start now. So, so welcome back to the after lunch session. So for this session, we'll have Mr. Awuku and Mr. Kolani, as well as Mr. Dr. Abimbola.
Yes.
So
Tommy is there.
Hello, sorry. Yeah, we are starting now.
Okay, okay. Okay,
So,
thank you.
Yeah.
I can
so
start.
You have 15. Yeah, you have 15 minutes for presentation and then 5 minutes for questions.
Okay, thank you.
Yes. Oh, you can unmute yourself. Sorry, I put you on mute.
Sorry for this problem.
Okay, the floor is yours.
The title
Yes.
Okay. The title of my topic is modeling of flows and retransfer in bioactive household waste storage facilities. My presentation is structured in 6 parts. First, an introduction, then a problem, then a general objective and a specific objective, as well as a mathematical model, result and discussion, and finally conclusions. Here is a household waste site in Lomé, one of a lot of. Then the increase in world population had led to an increase in the production of household waste in thousands of tons, which created a problem of waste management. Thus, the development of operating techniques will allow us to accelerate biological degradation, decrease stabilization times, reduce environmental risk, and optimize biogas production. A study was carried out in this regard in order to see to what extent the physical chemical parameters will improve the management of household waste storage centers and, on the other hand, control liquid effluent. The general objective or the main objective of this study is modeling of flows and retransfer in household waste. This study aims to determine and model the mathematical model of description of physical phenomena developed from the conservation equation of mass and energy rating for which component. Identify a model of biogas production that depends both on the nature of the waste, on temperature and humidity. Simulate the transition of leachate to relaunch the degradation processes, the production of biogas, and thereby accelerate the stabilization times. For the mathematical model, you have written the conservation equation, namely liquid phases equation, gas phase equation, vapor phase equation, and biogas coefficient. Then energy equation for each component and pressure equation. The combination of the previous equation and others allowed us to obtain liquid phase equation, energy equation, and pressure equation with the following boundary conditions. The system of equation is discretized using the finite volume method and solved using the Thomas algorithm and programming in Fortran language. The two-dimension simulation allowed us to obtain the following results. Concern water fields, we show an increase in the water at the bottom of the bin. In fact, the humidity level appears and becomes more and more important as you progress deeper in the locker. This deep transfer is essentially controlled by gravity. There is a drawing out of humidity of the upper part and the increase in humidity of the lower part of the body. For the temperature, we can see an increasing temperature if you go into the locker. That is a figure. The isothermic. And last, the evolution of pressure field. Concern this, as the humidity level increases, the pressure became more and more important. If you go down into the locket, pressure buildups at the bottom of the rack are controlled by the biogas position terms. Finally, you are notice significant production of biogas toward the bottom of the bin. To conclude, you can see the water content is a very important factor for optimization of biogas production, the acceleration of the anaerobic degradation of household waste. The production of biogas depends on the nature of the waste, the temperature of the middle. Thank you.
Okay, thank you so much, Mr. Awuku. Is there any question for Mr. Awuku? So the floor is open for questions now.
Mo ti connect lórí phone.
So, okay.
Okay, thank you, Mr. Oku, for this great presentation. I would like to ask some question. Yeah, can you go to the page, I think it's page 12, page 12 and 13. Yeah, where you have the figures.
Yes.
Yeah. So just I want to know what is the label of the axis. So the x-axis and y-axis, what is it?
The x-axis is the x-axis is the larger the value of larger of the system and
okay, the width. Yeah. And the y-axis?
You say? And the y-axis
and the
deep. Is the deep.
Okay,
Yes,
okay.
so
The x-axis is the width and the y-axis is the depth. Okay. Okay. And so this, if I understand very well, the waste, do you take in account the kind of waste we have? Because we have many kind of waste. For example, I don't know, is it a waste? Is it how you call it? Les déchets, aide-moi, le caca, quoi, les déchets dans les fosses sticks. Comment on dit ça? Help me.
Waste, like human waste.
Doji?
Like,
Yeah.
like human waste.
Yeah, human waste, yeah. Direct, is it human waste or is it kitchen waste? Is kitchen waste or human waste?
Kitchen waste. Kitchen waste.
Okay, c'est les déchets de cuisine. Is kitchen waste?
Yes.
Okay, which kind of waste? Because kitchen waste, we have many kinds.
Yes. You are submitted the in globally the house waste. If you are go to the house waste container, a plastic, a food, a lot of many components.
You take in account these kind of components.
You see?
They absorb the fact that because components don't have the same thermal coefficient or same, I would say, humidity coefficient.
Yes.
Parameters. So, for
Yes.
example, if in my waste I have a lot of plastic down and a lot of house kitchen waste up, for example, I don't know, up, I don't think I will have the same if the plastic is up and the food waste is down. I don't know.
Okay.
You got my question?
If you are taking the waste, the house waste, firstly you are do a training and to separate plastic to order the to save to separate plastic to the
other ways. Yeah.
So is it like a kind of controlled waste inside the bin?
Yes.
Because what Dr. Dambe is saying, it's like inside the bin you can have different type of solids. It could be it could be food, it could be a bottle, it could be plastics, as you said. So each solid actually have different is it coefficient of conductivity or whatever it is. So in your figure, it seems like it shows a kind of homogenized patterns in the water field, and I think same for the pressure field as well. So is it something that you homogenize? Is it like you homogenize the property of everything that you have inside, or do they have the same property, or is there any way that you can design the property of what is inside your bin?
This is a question. You can repeat the question. Can you repeat a question?
So the question is it like do you consider that inside the bin you have different type of materials?
Yes.
In your model.
Yes.
Okay. I think that's what Dr. Dambe was trying to ask.
For the work is for modeling, yeah, but we have considered a solid phase, a liquid phase, vapor phase,
okay,
and biogas phase to
Oh.
write the conservation, the mass conservation.
Oh, okay.
For the to write the mass conservation for programming. If I am going to the programming, we have a lot of property, and you use sometimes the correlation. For example, about the
Or maybe you can show the equations so that you maybe you describe what is what in the equations that you write.
You are, yes, you are, you which you are user the correlation to derive the property.
Oh, okay. Okay.
Okay, great. We go to the next. Goji?
Okay. So thank you, Mr. Awuku, for your very applied and interesting presentation. I think I can chat with you about biogas because it's something that I'm really interested on. Okay. So is Mr. Dr. Abimbola around? If yes, can you?
I'm ready.
Okay.
I'm ready.
Thank you.
All right, I want to share my slide again.
Okay, yeah.
Yeah, I want to share my slide. Can I start speaking?
Yes, we are hearing you. It's a little low. Yeah, your slide is coming. It's not open yet.
All right. Now, we're looking at, well, I want to appreciate the organizer of this program. It's one of the things we need to do to move Africa forward. So I'm looking at my title of my work is the effect of temperature on gas and.
Hello? Hello?
Yeah, I think we have
Dr.
a,
Oladomo?
looks like connection problem.
Yeah.
Don't present it. Don't present that. Okay, we'll finish slide there, right?
Dr. Oladomo? Hello? Dr. Ola? Can you hear us?
It's a connection problem, I think. At the
Okay, yeah.
It's
Okay,
not the right
maybe.
moment.
Hello?
Yes, hello. Okay, Dr. Ola is back.
Okay, great.
Yeah, can you try to share again? One more time.
Please, Dr. Fayose, can you mute your microphone? Yeah. Thank you. Great.
Okay, can you put it on presentation mode, please?
Hello.
Hello, we can hear you.
All right. So I'm presenting. I'll be guided by this outline. So first we look at.
Please, can you go on presentation mode?
Yeah,
Full screen.
Full screen.
Yeah.
Go from beginning.
Yeah.
Okay, okay.
Yeah,
you can see me clearly now.
Okay.
All right.
Yeah,
The
it's okay.
demand for energy, because of the increasing population, there is tremendous increase in the demand for fuel, energy, and petrochemicals. And presently, there is the depletion of the crude oil reserves and the production. So if you look at the trend from 1990 to date, there is a tremendous increase in the demand for energy because of the demand, and the demand will continue. But how do we meet up this demand? Now look at the sources of world energy consumption. We discovered that petroleum supply the bulk of the needed energy, followed by the coal, followed by natural gas. And of course, there is a depletion of these resources. Now, from the discovery of crude oil, we discovered that there's a decline in the discovery of crude oil. So the crude oil are no longer available. And if you look at the proven oil reserves around the world, we discovered that most of these countries that have conventional crude oil, they also have bitumen in reserve, especially Africa. My focus is on Africa. Now, the world reserve, we discovered that heavy oil and bitumen, the conventional crude available 30%, and the bitumen was also 30%. But in Nigeria, especially in Africa, we are not working towards combating this bitumen. Now, look at I have a table to show the distribution of oil and bitumen. In terms of the discovery of bitumen in Nigeria, so many researchers have worked at trying to estimate the quantity and the quality of bitumen reserve we have in Nigeria. And we have a reserve that is comparable, at least, with what is obtainable in Canada. And in terms of the quality, so many researchers, especially Adebi and some other researchers, they have worked on the quality on the bitumen we have in Nigeria, and they are very good, comparable to what is obtainable in Canada and in Venezuela. And the context of our work is to design a reactor to actually bring down, to crack the bitumen. So we design an in-house solar reactor, as you have seen. Now, this is an online assemblage for my research work. And we use an online analysis using a regional analyzer. Now, the description of the reactor. Now, the reactor is made up of stainless steel of 316 grade, and they are purchased from Swedgelove. Now, the diameter of our reactor is 1 centimeter, and the other parameters you can see. Now, the experiment. Now, the reactor was connected through the pressure line, and of course, when we are using pressure equipment, we need to use nitrogen to purge so as to expunge the air in order to prevent explosion, because it's very important when you're dealing with high pressure equipment. You need to make sure that there is no leakage before you start the work. And we'll put the bitumen, we'll purge, then we'll start our reaction time. The other parameters is as itemized above. Now, but the result of our work, we discovered that different gases are produced in thermal cracking at the different temperature, and will maintain ethane, propane, and lower molecular hydrocarbon were gotten from the process. Now we're able to capture and analyze the high molecular hydrocarbon because of the injection. We use from I show you from the computer, we try to capture the gases and analyze through my computer. And we use, from our design, we use an automatic injection that can actually capture the process online. Now, the plot I have show the distribution of at 400 degrees Celsius. Now, at between 1 and 100 degrees Celsius, you know, the high molecular weight hydrocarbon will be broken down into lower molecular weight hydrocarbon. After then, there's a decline. You know, what we are dealing with the high molecular weight hydrocarbon. So after a time, we discover that there's a decline in the production. Now, the same thing was observed at 450 degrees Celsius and at 500 degrees Celsius. Now, having a comparative analysis of what we obtain at different temperature, we know the higher the temperature, the higher the rate of cracking. And from my plot here, you see that 500 we have a higher conversion than at 450, then at 400. Now for ethane, follow the same trend, and all others they follow the same trend. As we increase the temperature, we have more evolution of gases. Now, so a summary of my results, and as we increase the concentration of the lower molecular weights as the temperature increases, as I've said clearly. So this clearly shows that thermal cracking becomes evidently significant as the reaction temperature increase. Why? Because there is a splitting of the higher molecular weight hydrocarbon into lower molecular hydrocarbon. And what we have done conform with what has been reported by other researchers for crude from different parts of the world. Now, in terms of the viscosity, you know, one of the problems we have with bitumen is it's very viscous. And that is why to develop a technology to combat them is really expensive. So the process, what we have adopted now, will reduce the temperature of the bitumen so it begins to flow like conventional crude. And that is the thing. That is the difference between the conventional crude oil and the bitumen. It has to do with the viscosity. How can you make it to flow? So in this process, we make bitumen to behave like a fluid. And we can achieve that if you look at the raw bitumen, at 400 degrees Celsius, at 450, at 500, you see that we were succeeded in reducing the viscosity apart from the other gases that was produced. Now, if we look at the liquid composition, so different class of hydrocarbon was produced. We have the alkanes, the aromatics, like acrylic acid, ethanol. So we discovered that the bitumen is the home of petrochemicals, and that is what we need for the industrialization of Nigeria and Africa. Most of these chemicals are being imported because the refineries are all offshore. So if we are able to continue in this process, we discover that most of the chemicals that we import, we can actually get them from a bitumen. And naphthalene from this plot, we discover that naphthalene is one of the things we use to grade the quality of crude oil. Now, from bitumen, we discovered that we have a lot of naphthalenes at different temperatures. So as we increase the temperature, the production of naphthalenes also increase. So it will help to increase the octane rating of our product. Now, looking at the kinetic parameters, I've just done a summary here. Let me just go down. We try to look at the rate constant and the activation energy for different products. Now, comparative analysis with other work. Now, Frey and Hebb, they discovered that the activation energy for C5 and for methane. And if you look at all the activation energy that have been reported, comparing with what we have done, we discover that it is easier to produce these gases from Nigerian bitumen. You need less energy, and that is the thing in this work. You require less energy to get petrochemicals and achievement to this work, that in order to further to produce petrochemicals and gases from our bitumen, we need less energy because of the activation profile. So in conclusion, the transformation of our bitumen to lower molecular fraction follows a parallel constitutional reaction scheme where the higher molecular hydrocarbon are converted into lower molecular weight hydrocarbon, and the gases are formed from the higher molecular weight hydrocarbon, and the reaction is affected basically by the temperature and time. So the products are higher are lighter hydrocarbon, mostly in the gasoline range. Now from C5 to C12, that is when we have the gasoline range, and we discovered that our products conform to that standard. So, and the liquids, they are also very important. So the decomposition of hydroxide bitumen perfectly fit into first of the kinetic model, and the lower energy of education is required for the conversion of bitumen into valuable products. So I appreciate my research group and that the surface chemistry and physics group in the University of Aberdeen, and my department in Adekunle University for the support. Thank you.
Thank you, Dr.
Hello?
Yeah. Yeah, thank you, Dr. Ola.
Thank you.
So now the floor is open for questions. So I will recall it. If you have question, you can just raise your hand. Then I will give you the floor. And if you cannot, then just type your question in the chat. Yeah, Prof. Falabi.
Okay, thank you for your presentation, Dr. Olaremu. My questions are as follows. How many groups of chemicals that are useful have you been able to analyze from your research? And can you advocate the kind of machine that can be commercially used for production of these useful chemicals? That's my question.
Okay. So Dr. Olaremu. Oh, I think he's having some internet issues. He is no longer part of the panelist. Dr. Olaremu, can you hear us? No. So maybe what we can do, we can keep the question for him. So when he's back, he can answer maybe after the next presentation. Is that okay for you, Prof. Falabi?
It's all right. It's all right.
Thank you so much. Yeah, once again, sorry for those internet issues independently from us. So now we can straight go for the next presenter. So is Mr. Kolani ready? Can you maybe unmute yourself and no? Dr. Tomia.
Wait.
Oh, okay. Okay, Mr. Kolani, can you share your screen?
Yes.
Okay, it's coming. So Mr. Kolani is going to present on contribution to the cooling of premises by using a provincial well. So it's a work done at the University de Lomé in Togo, in Laboratoire sur l'énergie solaire. So Mr. Kolani, the floor is yours. You have 15 minutes for your presentation and another 5 minutes for for question and answers.
Okay, thank you. You hear me?
Yes.
Yes. I am Mr. Kulani Wenduba, PhD student at the University of Lomé in the laboratory on solar energy. My presentation is about contribution to the cooling of the premise by using a Provençal word. My presentation is about the plan of my presentation: introduction, general objective, specific objective, methodology, result and discussion, and conclusion. The design of lower energy building has become a very important issue around the world in order to minimize energy consumption and associate greenhouse gas emission. The integration of passive cooling system into building is now essential to reduce energy consumption while improving thermal comfort. One of these systems is the air-ground exchanger, commonly known as the Provençal wall. It consists of tube buried at a given depth in which the ambient air is pushed in order to be cooled in contact with the ground, whose temperature is almost constant throughout the year. The air that's cooled is blown into the building. The main objective is to evaluate the performance of a Provençal wall. The specific objectives are to control the physical phenomena found in the Provençal wall, implement this model in a dynamic simulation software, validate the model of the air temperature in the exchanger, analyzes the influence of some parameters in the thermal dynamic. We start with our work of the R on air ground exchanger. The aim is to propose an air ground exchanger model that can be coupled with building model in order to allow the evaluation of the influence of this system on the energy and environment balance of the building. Elaboration of the numerical simulation code, test and validation of the model. Mathematical model, we have a continuity equation of movement according to x, equation of the motion flow according to I. We have the equation, energy equation, and water vapor diffusion. To this equation, we have added the initial and boundary condition. Method used. The equation governing the phenomenon are discretized by the finite difference method. The numerical approach is based on the implicit method of alternate direction AD. To solve our problem, we have developed a calculation program in Fortran language using Thomas algorithm. This part represents the validation the validity of the model choose of the result.
we valid our model before the model we choose. The model choose is the model of ID. We have our work. There we have a lower line, a power line, the power line of our work. There we have a isotherm for our work. Then we validate with the model we choose.
Sorry,
Sorry.
there are some technical problems here. But
Sorry. In this section, we present the velocity and the temperature profile for a soil exchanger building coupling. We have the profile of component of the vitesse, vitesse V, the component of the vitesse U, V, and the temperature. Here we have the profile of velocity VQ and velocity V and the temperature. In this section, we present the variation of the velocity field and the temperature field. The knowledge of the velocity and temperature field at the outlay of the channel give us information on the amount of energy gains by the air from inlet to the outlet of the channel. It is therefore important to examine the evolution of these two variables. We observe that along most of the evacuation opening, the air exits at a temperature close to that of the wall. The velocity for each part does not exceed to the dimensional value. In this part, we present the distribution of the usual value for the soil exchanger building coupling. We have there the distribution of power line in the exchanger, and then the distribution of power line in the building. We couple the two, and we have a distribution of power line in the exchanger coupled the building. And we have a line, an open line, and closed cells. In this part, we have a distribution of isotherm in the exchanger and the distribution of isotherm in the building. If we couple the two, we have a distribution of the isotherm in the exchanger coupled to the building. You can say in this work, the analysis focus on the rate of that and heat of heat transfer through the cold hole. The flow structure consists essentially of the open line, which represent the post-convection flow, and the closed cells, which are used to the upward recirculation movement of the jet. In the conclusion, in this work, we have developed a program of a fairground exchanger in laminar regime using the soil thermal model with vegetation cover as boundary condition in order to cook it the building. In perspective, we plan to do the same work in turbulence regime in order to evaluate the influence of the flow regime on the heat exchanger in the provincial one. Thank you for coming.
Okay, thank you very much for your presentation, Mr. Kolani. Is there any question for Mr. Kolani? Any questions? Yeah. Proper follow B. You can go on.
Thank you for your presentation.
Okay.
Checking your work. I don't see diagram of your installation and the diagram of your measurements. Did you measure the temperature gradient there? So start by showing me your installation, the construction, how, and then I'll see where you do the measurements. Diagram, I mean, I can ask for that. You have in the diagram. Hello?
I don't understand you.
Yeah, do you have
the diagram of installation?
Do you have
you pass pipe into the ground. Okay?
I don't
You
understand.
pass pipe into the ground. So, and then you pass it to the house. Where is the hair coming from? And I want to see the diagram, your diagram.
Wait,
diagram of your setup.
Diagram, yeah?
No,
No,
that
do
is
you
a
have
chart.
do you have
That
any
is a chart. The physical diagram
do you
of
have
the setup.
any
Yeah?
the setup?
Yeah?
No,
Maybe
the
the last
machine,
one.
the equipment, the house, how do you took your measurement? You're talking about the measurement stage.
Diagram.
These are the results. And methodology, the diagram. The house, the pipe, the instrument used for measurement. I want to see the setting.
I don't think he showed any diagram in
I don't understand you.
the presentation. So the only thing he
Yes,
showed maybe is the last one. Can
That's
you
not
go?
good enough because
Can you go?
somebody this thing now, the main basis of this thing is collection of data from a setup. Okay. If the setup is wrong, this data will be wrong.
Please, Mr. Kolani, can you go next slide?
Next slide.
Next again.
No.
I think.
Yeah.
Let's go to introduction.
Yeah.
Introduction.
So
Methodology.
yeah. So
Introduction methodology. Let's see your methodology.
What slide?
This is your methodology. The second one.
Back.
Okay, methodology. Yes, methodology after introduction.
So this is the introduction.
Yeah, methodology. Can you let me see your methodology? Methodology.
Methodology.
Oh, is this a theoretical?
Yes.
It's a theoretical work.
You say?
Okay, it's a theoretical work, right?
Yeah, it is a mathematical modeling.
Mathematical modeling of the provincial world.
Oh, I'm talking about the experimental aspect. I thought it's not completely theoretical. So it's completely theoretical. All right.
So it's actually only at the last slide that he showed. I think they made like a kind of sketch of how the house looks and how the wall
Oh,
and
that's
everything
what
looks.
I'm asking to see.
Yeah.
Can you show me?
Mr. Kolani, can you go to the slide where you show the wall and
what slide?
Le slide sur lequel vous avez montré vous savez, les murs et puis le mouvement de fluide là.
Ah. Here?
No.
Non, le plus was. Je pense que ça commence ici. I think it starts from here.
Okay. Now in the morning, the ground will be hotter than the inside the ground will be hotter than on the surface of the ground. Okay.
It is
so
the hair.
Yeah, the hair is circulating like that. When the cool hair enters the ground, by compression, it gets heated up, right? Then it gets inside the house. Then the house becomes warm in the morning when the outside is cool. So how can that be remedied? The undue heat that is coming from the ground, entering the house. Are you saying you will close it and not use it in the morning? Please answer. Do you understand what I said?
Oh, I don't understand you.
In the morning.
In the morning?
In the morning, like 7 o'clock.
Yes.
Inside the ground is hotter than the surface of the ground, isn't it?
It is true. It's true. It's true.
Then the hot air will enter the house, isn't it? Then how do you cool the house then?
Il dit le matin, l'air chaud du sous-sol réchauffe l'intérieur de la chambre.
Oui.
Bon, maintenant, comment peut-on faire pour garder cette chaleur-là? Ou comment peut-on faire pour
refroidir
si on veut refroidir, comment peut-on faire?
Oui, parce que là, si la température du sol est élevée, ça veut dire que l'air qui entre doit être à une température supérieure à la température du sol. Donc, c'est cet air qui va gagner des calories de la température du sol pour réchauffer la chambre.
La chambre.
Oui,
Bon, maintenant, la question.
C'est là on parle du puits provençal.
D'accord.
Mais le contraire, ça s'appelle le puits canadien, au moment où il faut plutôt chauffer, refroidir l'air qui entre.
Et comment ça se fait?
Ah, ok. Ah non, il y a un problème. En fait, ok, toi, ton système réchauffe les salles, il ne refroidit pas.
Non, pour ce que j'ai fait, ça refroidit la salle.
Oui.
Puisque moi, j'ai pris pour le cas de notre pays, c'est-à-dire nous sommes dans un pays à climat chaud. Donc, l'objectif est de refroidir le bâtiment.
Oui, et il dit que le matin, est-ce que ça va refroidir aussi, sachant que plutôt le sol est chaud, très tôt le matin, le sol emmagasine la chaleur de la veille.
Non, la matinée, ça veut dire que le système, normalement, ne doit pas fonctionner.
Okay.
On n'a pas...
So Dr. Falabi?
Okay.
Yeah, he said that the thing is that in the morning, the well should be closed because in the morning, it will not do the right job.
But I think a suggestion is to make a regulated air pump available on the left so that you can adjust the rate of air entering the well. That would be a better improvement.
OK. Il dit que improvement, comment dire, sa suggestion serait...
Oui.
Voilà, c'est ça. L'amélioration qu'il peut proposer, c'est qu'à l'entrée, en fait, de ton puits, qu'il y ait un système qui gère le flux d'air qui rentre dans le puits, en fait.
Oui.
Donc, en fait, quand on va insérer ce système de qui est le flux d'air, même au niveau des calculs, ça va te permettre donc de savoir le matin quel est le flux qu'il faut envoyer. Donc, ça peut être une pompe qui aspire l'air, un truc comme ça. Donc, le flux qu'il faut envoyer dans le puits pour avoir la bonne régulation de température dans la salle.
D'accord.
Tu peux le remercier en anglais.
Nous avons...
Is that okay?
Yeah, I said it to him. So, thank you.
Okay.
Okay. Is there any other question?
Hello, sir.
Yes, Dr. Olaremo.
Yeah, sorry, my network went off when doing the question and answer session after my presentation.
So
I don't know
actually,
if,
what I suggested that after this presentation, so you can get the question from, I think Prof. Afolabi asked a question where you were away.
Okay.
So you can, if Prof is still around, you can then ask the question before we close the.
Okay. And if it's not
Or
available,
let's first close this one. Then, if there's no question for Mr. Kolani, then we'll get back to you, please.
Thank you.
I think there's no question for Kolani. So thank you, Mr. Kolani.
Okay.
Yeah, Professor Afolabi.
Okay. Is he around now?
Yeah. Dr. Olaremu is back.
My questions are this. You have successfully analyzed many important chemicals, right?
Yes.
In laboratory. Now, you are supposed to classify those chemicals and their uses on a table. Then you will be able to advise on which kind of machine will be appropriately suitable for producing these gases. Then your work will be very applicable to solving problems. Can you shed light on this?
All right. Hello. Am I on?
Yes.
Yes. Now, talking in terms of a classification of chemicals, what we are trying to do is on my slide. Sorry, I am not right now. We are trying to classify those chemicals that are available because we know that people are into the chemical technology or people are into the end users. They already have the understanding of the usage. Now, but I pointed out that most of the gases are in the petrol in the petrol range. You know? So then I also pointed out that we have naphthalene, naphthenes that can be gotten from it. Then we also have aromatics. And of course, these are chemicals that we use day in, day out, and we know their applications. I've talked about aromatics. Now, you know, we have the phenols, the xylene, and you know that they are used as solvents. They are used as solvents, and they have a lot of applications. And if I'm to outline the application of some of these gases, that will be another seminar. So that's why I narrowed down to the production of those chemicals, but the applications can be another time because we have wide loads of applications. That's why I didn't go into detail. I only classify them that well. Most of them, the chemicals are in the petroleum, in the petrol range. Then I only pointed out naphthalene and aromatics because at least that will be familiar with. Thank you.
It's okay. Since you said you've continued your research on that so that you can make it applicable to applicants, that is a good answer. And when you are classifying them and their uses, then I implore you to advise on the type of machines that can be very, very useful for production of these important chemicals. In that, your next. Thank you.
Thank you. Thank you.
Thank you so much. So, if there's no further question for Dr. Olaremu, then I think we can go for the next. The next talk, which is a plenary that will be given by Prof. Musa Sugoti. So Professor Musa Sugoti is from Université Joseph Kizerbo in Burkina Faso. And he is working on the Laboratoire de Physique et de Chimie de l'Environnement.
Yes.
Thank you. So maybe you can translate. It's a laboratory of physics, or is it physics and chemistry or chemical physics? Okay. So we'll say environmental physical chemistry lab, something like that. So Prof, the floor is yours. You can start sharing your screen. And you have 1 hour.
1 hour. Let me
Can you find the green?
Find the green.
The green button. Okay.
I have just tested my. Aha. What happened?
Okay. So I can see now. Oh. No, sorry, we are having the plenary before. Dr. Tomia.
Tomia, yeah.
Yeah, can you please stop sharing? Because now we are having the plenary session before.
Okay.
Then you can present. But in case we lost Prof. Sugoti, then you will come back.
Should I stop sharing?
Yeah, please.
Okay.
Thank you so much.
Hello.
So after Prof. Sugoti, you can, yeah, we'll then go ahead.
Hello.
Yeah, Prof. Are you back? Can you share?
I try to share.
Okay. Okay.
Do you see my screen?
No.
No, not yet.
No.
Not yet. How to do?
Hello, sir.
Are you using your phone?
I use my phone.
Yes,
Yeah.
Yes.
Oh, take me.
Hello.
What do you think?
I have my PowerPoint in my phone.
Hello.
Hello.
Can you still see the sharing button, le bouton vert là, vous pouvez toujours le voir?
Dodi.
Oui.
que je peux bloquer le microphone de ceux qui ne sont pas en train de parler pour ne pas que ça...
Allô?
D'accord.
Allô? Allô?
Yes, yes.
Yeah. J'ai cliqué dessus. Je pense que je dois partager mon écran, c'est ça?
Oui.
Oui, c'est ça.
Voilà. Et puis, commencer.
Voilà.
Vous voyez mon écran?
Yeah, now you need to go to your PowerPoint.
OK.
En mode paysage maintenant.
Perfect. En mode paysage, maintenant on peut tourner le truc là
Mode
pour
paysage, comme ça. Yeah. Oh. Comme
Non,
ça?
il faut pas bouger très vite le téléphone. Comme ça, c'est bon.
Comme ça, c'est bon?
Non. Il faut
Can you...
pas en paysage là.
Oui.
Hein?
Le téléphone n'est pas en paysage.
Ah. Ah, comme ça?
Oui,
OK, là c'est bon.
Là, c'est bon. OK.
Yeah, thank you.
I'm sorry. Don't care about my English.
We are all in the same problem, so you
this
can
is
go.
the science that matters. So
Okay.
English is just an intermediate step.
So I will try to talk about the role of physics in the environmental struggle in Africa. First, by my plan, I will introduce, and I will talk about African environmental problems, and the second party, excuse me, I will talk about science and technology for African solution, and I will finish by a conclusion. How to go to the next?
Can you just tap on the...
Okay. Okay. I think that for its development, Africa has many challenges to meet. I think that appropriation of science and technology is one of the priorities. African scientists have an important role to play in Africa's development. Training in science and technology can lead to have African solutions related to our environment problems and our needs. I would like to address the role of physics in the environmental struggle in Africa by presenting some environmental problems of Africa and some scientific research themes for Africa solution in this field. To do this, I help myself by using Global Environment Outlook, regional assessment for Africa. According to Global Environment Outlook, Africa priority comes in three aspects: Africa rising, changing demographics, land management, and use. Each aspect is linked to specific problem in Africa. Let's turn our attention to a few issues. What happened there?
Je crois que ça dépend si tu mets le doigt côté gauche ou côté droit, un truc comme ça.
Ah.
Dans un sens, ça te renvoie derrière, dans un sens, ça te renvoie devant.
Oh, what happened?
Là vous ouvrez.
My
non,
God.
tapez deux fois. Cliquez, tapez deux fois sur l'écran. Voilà.
Okay. The first issue I will point out is pollution in Africa. We have waste management problems, hazardous and non-hazardous waste. We have air pollution, biomass, air pollution due by the use of biomass, urbanization, industrialization, motorization. We know that in our country, the car is the whole car we get, and pollution is high. Another issue is about pollution is the management of wastewater. We know that potable water is a problem in our country, and if you can manage wastewater, you can get more potable water. Another issue is energy in Africa. Energy supplies and demand. Electrical network can not satisfy all the demand in electricity. So you have to find solution to reduce demand. Biomass, the use of biomass has for cooking and so on, lead to loss of forest and biodiversity. So renewable energy can be a solution like solar, the wind, the bioenergy, and hydropower. Next one. Another issue I can point out is weak environment in Africa. We have land degradation due to climate change, agriculture, mineral extraction, and so on. With material, we know that our country we don't have enough infrastructure. So in building, we have to use a lot of material like cement and so on, transport, industry. The environment, because you have to, for example, if you take agriculture, you have to have more land to do it. So biodiversity, the problem with biodiversity. So I think that the issue I talk about later, I think that science and technology can be a solution for Africa to solve the problem. So I think that African scientists, each in their field of expertise, can tackle the problem mentioned above in their research. African countries are called upon to build flexible and adaptable scientific research structure. In particular, scientific research must be financially supported and oriented toward African development priorities. As far as physics, oh, what happened? Oh. My God, I lost. As far as physics are concerned, I think that element of research may consist in finding sustainable energy source and material, but the result of research should allow the development of technology adapted to the African environment. We are here some themes that can be taken into account. Build sustainable material, sustainable energy source, waste management, soil and air pollution, preservation of biodiversity. But it's just some few terms I propose, but I think that everybody can propose some other term. I will conclude because I want to debate with you for my opinion. So I take my presentation to short. Africa's population is young and the continent has a lot of resource. Africa must develop, and this can be done with African scientists. In particular, physics will be able to play a crucial role if scientific research is focused on priority areas. Material and human resources are available to find solutions to African problems. Africa is poor in infrastructure, and sustainable solutions in energy and material must be found. Thanks for your attention. This is just my opinion. Let us debate. Thanks.
Okay, thank you, Professor Sugoti, for the presentation. So now, as you said, the floor is now open for questions and debate. So just raise your hand if you want to say something. Then we open the debate. Thank you. I can see, yeah, Dr. Tombe.
Yeah, thank you, Professor Sugoti, for this presentation. On my point of view, I completely agree with you. But I would like us to talk about the different possibilities we have and why we still a little, if you can say late. I don't like this word because when you say late, it's like comparing yourself with a reference. Why I would say why we are still late in attending our objectives. This is better. So I think we have the scientists who can do the job. And on my point of view, the problem is first on how we are orientating our subjects. And also the second point is the collaboration between African scientists. Because for long, it looks like we were looking too much outside of Africa. And usually the problem of that is when you, even if you want to develop a subject which concerns your country, but you are doing it in collaboration with a laboratory which is in, I don't know, USA, for example, their needs is somewhere else. And usually they are far from what you want to do. And they cannot go back down to help you to do something. So you work almost more than 50% of your time for their goals. And the rest, you are working for your goals. So I think the first is orientating our subject. And the second is increase more the collaboration between African scientists. So it's just a point of view. I don't know if you want to debate, if someone want to add something. Thank you.
Okay. So I can see, thank you, Dr. Tambe. So we have Dr. Latif. But before that, if Prof has any comment on that. So before we move to Dr. Latif.
I will comment. Well, I will say that I agree with his comment. I will say that in our countries, research, financial, the support of research is not in a high level. I will say, not in high level. So you need what I will say material and so on to do research. I will take for example in solar energy. Solar energy, I think that our researcher can do good research to solve our problem, energy problem in our country. But what we do some other researchers, they do research, they create, what to say, they take, they make some device to transform solar energy to electricity, and in the environment, but you have to adapt it to our environment. Why not? Our researcher can try to make device within our environment to satisfy our needs. Not all they want to come and I will need something. I will do it for you. What?
Yeah. You're completely
So
right.
I see, yeah.
What?
And I think it then get to the point that Dambe raised before. So if someone is giving you money to do research, he'll be actually tempted to propose his interest on you.
Yes,
of course,
Yeah.
of course.
So
And
can
also,
you,
I would like to add something is that that is very clear that we have a problem of research funding. That's very clear. But I think this problem can be tackled in another way. Why? Because, for example, Professor Folabi have made a presentation of what they are doing for batteries, for example.
Yeah.
Usually, some labs, African labs in solar energy, they want to buy the MPPT, they want to buy the electronic device that charge the batteries. Okay.
Yes.
But we know that these devices are very expensive. But
Yes.
what Professor Avalabi and his team has done is, okay, we know how to this device works. So we just buy the component, the little components, and we can charge our own batteries, even if the efficiency will not be 90%. We can go close to 90%. Even if you have 80%, we can do research and propose something for our people. So you have funding problems, but it depends also with the less money that we have, we can do something which is adapted.
Yes.
I think.
Okay.
And Latif, you can talk, I think.
Thank you.
You don't need to wait.
I can see Dr. Latif was waiting for a long time now. Yeah, you can go ahead, Dr. Latif.
It's a debate, so you can go.
Latif?
He raised his hand and he went to it.
Yeah. Sorry, can you hear me now?
Yes.
Yeah, we can hear you.
Thank you very much. So thank you, Professor Sugoti, for the presentation. It encourages us to think inwards to find solutions to our challenges, because like Dr. Dambe said, it's not always easy to copy and paste and get solution, because we have a lot of changes in our environment and atmospheric conditions are not the same. For example, if you let me take you an example of Nigeria, for example. If you're in Nigeria, the northern part of Nigeria and the southern part of Nigeria do not have the same rain abundance in a year. If you're in the north, maybe you have like 1 or 2 months of rain in a whole year. Yeah, in the south, you can have up to 4 or 5 months of rain in a year. And this has some impact on the quality of the roads that we have. You know, for example, you make roads and then after 2 years, you have to rehabilitate the roads again because they're already spoiled because of the heavy rainfalls we have around here. And then because of the way we do things generally, maybe when you copy on internet that if you put asphalt and maybe granite to make your bitumen stuff, and then you have quality, and then that quality can work in some places, it does not work in some other places. And the beauty of it is that people have done a lot of research, even in Africa here, to show that some of these things, we know we can do some things in a very local manner and it should be very good quality using what is available locally. And I think that is where we should be shifting now. Solving our problems, trying to look for local solutions to them. This is the only way to do it in a way that will last. So, Prof, I actually agree with you in your presentation, and I believe that we should do more collaboration in this line to find local solutions to most of these environmental challenges that we have, like electricity generation, water supply, like Mary CMU presented in the morning, and so many other things like this. This way, I think we shall move forward with time. Thank you.
Thank you, Dr. Latif.
Thank you
for comment. So we also
I think
have
Professor
Prof.
Afolabi wants to say
Afolabi.
something.
Can you go ahead, please?
Okay. Thank you for your presentation, Professor. My observation, when I saw your presentation, I was very concerned when you wrote that we must get our material sustainable. And I know that is economical and political. Although our contribution is very minimal in that area, but if we have people in government, we should address them to make our materials sustainable, because we have people from outside just coming to mine our minerals illegally. That is not permitted in their country. You cannot even go there and buy land. But here they come, they mine our gold, mine our copper easily, but they have their own reserve on mine. France has the largest gold reserve. They are not mining them. They will come to Africa and mine our own cheaply. And then we'll go and borrow money at higher interest. So we should all look at how we can maintain our materials. And then we should not be too greedy at demanding too much. Some of us, we want all our road tarred. The road in the bush, we want them tarred, and we are wasting our money instead of doing research and using our material economically to improve the situation in our countries. I'm really sorry at what is happening in Africa. May God help us. Thank you.
Thank you so much.
Thank you,
Professor Afolabi.
And also, I will add something. What Professor Afolabi said. I think that's also one part of our role that we should not forget is the lobbying. I think since we know, as Professor Afolabi said, the problem is just economic, political, and as is scientific. So what we know, what we have learned to do in our life is science, but we know that without economic and political influence, our work will keep in the journals, will be kept in journals. That's all. So I think it's the right time also to remember that organizations like scientific organizations and the think tanks, their roles is also this, is to make this kind of lobbying. And we should try to think of how we can organize ourselves to make this lobbying, because without this, I think our contribution to development will be very low. That's an observation. Thank you.
Okay, thank you so much. So basically, you mean we know how to communicate scientifically,
yeah.
But then the problem will be how to then bring our findings to the people who are deciding.
Of course, yeah. Not only bring it to them, but also try to convince them to choose our solutions best.
So to convince, I agree.
Yeah. That's it.
So is there any?
Yeah, Professor Gochi, we're saying something.
Yeah, Prof, go ahead.
Oh yeah, I think it's not evident to convince a politician and they can decide to put more money to research. For example, in Burkina Faso, they say that researchers who look for researchers
But we are not finding the finders.
Yes, well, yeah. But our country don't give money to do research, and they don't give orientation. I think that in solar energy, for example, you have to found African solution. I am not satisfied because yes, now actually in our country you use what we say solar panel. It's solar panel for, but it's not African African made. You use electronic part. It's not African made. You use wire, we say it's not African made, and so on. And why? The solar resource is in our countries, and solution go over there. Why?
I think on that point there is something. One observation that I've made in my country, for example, is okay. Let's say two observations, because I've tried to analyze a little how our politicians are choosing their decisions. The first thing that I've remarked is that, of course, that is a true law. I would say always a true law is, if you want someone to choose your solution, try to orientate your solution to his advantages, because he, of course. But in my country, for example, I'll give you an example of the solar panels that are used for. One moment, please.
Hello? Oh, okay.
Yeah, sorry. So my example was on our routes, they are installing now some solar panels for l'éclairage. Comment on dit ça déjà?
Yes.
Lighting. Yeah, there is some lighting with solar panels that they are using. They are putting everywhere now in West Africa. Did you remark that?
Yeah.
Yeah. And
near my house, I have someone.
Yeah. And what I've remarked is that I've talked with some persons, and when you try to analyze how these things are made, you see that they are the advantage of politicals are in two aspects. The first aspect is that they use it for their campaign. When after they will come in the village, or they will come in the region and say, yeah, we bring you lighting, we do that, try to vote for us. The second advantage for them is that they try to give the market to their friends, to their relatives, so that they can buy it a little. They can, if the project should cost 1 million, they will say no, it's 2 million, and 1 million is for them. So usually. So this is the two advantage: economical and political.
Ouais.
So that means I think it's in our turn now to exploit these two, trying to make some proposition, and that's the role of lobbying. Try to make some proposition where they can find this advantage for them. So, of course, I'm not saying that you should go and try to corrupt them, but the point is, okay, we know we can make some kind of proposition, analyze the regions where we know that they would like to have some political advantage. And we can try to propose some solution where we will have our advantage for finance, for funding our research, and they will have their advantage for political promotion and things like this. So it's just a point of view. I don't have the universal solution. It's just my thinking. So I don't know if someone who can add something on how to do this kind of things.
I think it's okay. I understand your point of view, and you might take it into account. Yes.
Yeah.
Yeah.
So,
Hello.
so we have Dr. Beltaco, we have Prof. Afolabi. So we start with Dr. Beltaco, then we go to Professor.
Okay. So I think I'm mostly agree with everyone on the topic. So the question on how we make impact as scientists regarding the environmental question, and this is basically linked to the general question of science and research in Africa. So as most of the people said, this is linked to politics, and I think it's mostly linked to politics because yes, we can do something. I agree we can use, let's say, what we have as scientists, the small things we have to do research. But I think what we can do with what we have cannot be so impactful if there is no political decision behind. Like if there is no global awareness from the political side on the question, because most of the research or the the research that could make impact actually is globally in a vision that comes from the top of the country. So today, I think, okay, most of the political people, their problem is basically in what I call our educational systems. Because as I was discussing with someone yesterday, the problem is the same. If, for instance, one of us today become a politician, like I know most of the political guys highly ranked in politics are mostly academics or let's say scientists or people from law side and these things. And if you look back in the past, most of them promise, oh, when I'll be there, I'll do this. I think, what is the problem? When you reach there, they will corrupt you, and then people are looking for money, full stop. This is what I understood. So what we can do, or from my understanding, is first, we need to have a kind of to make our educational systems in such a way that people will be aware of the fact that if I fund, for instance, research, I'm avoiding people to be dead in a hospital tomorrow because it is too hot, or I'm avoiding people to go and buy stuff in China tomorrow. They can buy it here, and the children or my children can have job tomorrow. This is something that I think we don't have. For instance, I can give you an example. Like because I'm very like when you look at someone stealing money from the government in our countries in Africa, basically the person is not scared of anything. The person can even shout on you if you tell him that. But if you look at let's say Asian country like Japan, no one, like people, even if someone steal the money from the government, and the person would like if you once someone says, okay, this is not good, the person actually will just say, okay, I'm no more at that responsibility, or the person will commit suicide or something. I think it's mostly in our educational system that we should make the best politicians so that the best decisions could be made. For now, maybe we can continue trying to do the lobbying and also try to work with what we have. This is what I think. Thank you.
Okay, thank
sorry,
you.
can I say something, please?
Is it linked to what Dr.
Yes,
Beltaco
Dr.
said?
Beltaco just said, yes.
Okay, yeah. So,
Dr.
yeah.
Beltaco, how do you think we can do something in our educational system as you and I, as teachers, university lecturers, and researchers? How can we do those things to make those changes you are referring to? I'm saying this because the politicians, as you mentioned them, they are the super class among us. We know them. They are the privileged ones. They are the ones with all the care when the ordinary people do not get the care. We know all those things. But remember, most of them do not study even here because they are privileged. They have parents that have the money or that are also politicians. So when they are leaving the university, they go abroad for their masters. Top university in the UK, US. For Nigerians, for example, most of the time they go to UK, US. And maybe in Togo, maybe they go to France or Switzerland. This is what happens. This is the truth. They go to the best school. I don't think they don't get the proper education. They get the education, but they are just wicked.
Yes.
They are wicked.
I agree with you. Are you done? Hello, Dr.
Yes.
Latif.
Yes,
Can I
I'm with
speak?
you. Yes, please.
Okay. I fully agree with you. The fact that you point out that they go to the best schools in the world sometimes, and most of the time, this shows that they know exactly what they are doing. They just don't want to do it good because they know exactly how things are going elsewhere. You see my point? So, okay, for most of them, okay, for a part of them that have schooled in our system or something, at least for those who have the chance to go through our educational system, what can we do? I think the problem is not to change what we are teaching to people. I think the problem is even in the primary school, the values we put in the educational system, the national values. Because I think basically most of the countries, the strength of most of the countries are based in their values, not let's say the mathematics or the equation. No, the strength of the country is based on the values. When you take China, the only value people know for them, they work hard. And this value is what makes their power. They work hard and they obey to the law. And like Japanese are really ethic people, like working hard, but they are very ethic as well. So when you take French people, you know exactly, and you can actually see the level of economy or the scientific performance of these countries regarding their values. But if you compare people, if we don't, I think what we missed at the beginning was that, like putting the right value in our educational systems. And I think we still don't have a control over that point. This is why.
On this point, I completely agree, but I think we should remember that there is 2 points. We have the emergency actions and we have the long-term actions. For me, the problem of the value is we cannot solve it now. It's progressively that we can change it.
Hello.
As emergency, Professor Folabi. But as emergency action, what should we do according to you?
Hello.
Let's maybe move to Prof. Folabi, then we can come back to that interesting point.
Okay. When Prof said, let us debate, everybody smile. Now, we are debating now, and the solutions are coming out. So we can start. Even anybody that did anybody that does anything on mathematical modeling of this and that, there must be a physical diagram from where that mathematics will evolve. Look at the question I asked concerning the well air conditioner.
Mm-hmm.
You saw that can be done and be particularized. Now, that is improvement on the building. Now, we have started, our politicians, they like to get electricity to people in the remote area with solar power. Okay, let us tell them, this solar power, when they spoil, you cannot repair them. Then let us tell them that we can import the cells and join them together here in parallel and series and get this. It demonstrated to the Ministry of Science, which every country has. If we demonstrate that, we have done the practical in physics, electricity, and we did that in the laboratory, that practical and series arrangement of cells, photovoltaic cells now. Then we do the practical in the school. We practicalize it to them. We show them this is what we can do to the Ministry of Science. Then the Ministry of Science minister will interact with the people, policymakers, and then they will say, "Oh, these are our panels that are spoiling. If we can be manufacturing them here, we will know how to repair them instead of increasing electrical waste." So step by step like that. Now Ghana is assembling cars. Nigeria, they are assembling cars there. So from there, we can be putting local materials, adding them. Then we are emanating, we are getting ourselves free from this foreign country domination. And if we start from our university step by step like that, even if it is mass, let us look at the physical diagrams. Let us try and improve from our research to apply them to the society. Then our country will start developing. And let us also contribute when they talk about the resources, how we can improve on our resources so that outsider will not come and be mining and be taking them away. May God help us.
Okay, thank you. And
thank you, Prof.
And I will add something.
It's a very interesting point.
Yeah.
Yes.
And I want something is we can even say a more general. You can even use a more general word instead of saying physical background. Is I would say the practical. You know, it's not only physical. It can be chemical. I don't know chemical, but just how to use what you are developing.
Yes, how to apply them.
The
experiment, the practical aspect.
Yeah, of course. Yeah, and that's the way. There is something also I want to propose is when we are making our lectures, when we are making our course with students, something I've remarked also is that since in the primary school and in the college, they didn't get the value as Betako was saying. They didn't get the orientation, I would say the Afrocentric way of thinking. You will see that it's usually when you are making your course and you ask them question about how can we use this thing, they will only give you an example about Europe. You see, and it's in rare cases they can think about usage near them. So what I've remarked is that we have not been formed to try to use our knowledge to solve the problems which are near us. So maybe we should also try to input these kind of reflections in when we are making courses, trying to recall to the student, to recall to the students that anything we are doing, they should first see around them to see how to use it, to see how this can be useful for themselves, or their mothers or their fathers, because science begin by solving the problems we have, not the problems that others have. So.
Yes, okay.
Okay. Is there, I can't see questions for other people. It seems like the debate is now among 3-5 people.
Please, Dr. Fayose, Dr. Sama.
I can see
debate.
Dr. Olabi.
Yeah. We are not hearing you, Professor Olatunji.
Hello, everybody. Hello, everybody.
Yeah, hello.
Hello,
yes,
hello. Well done, well done.
Missimi, you want to talk? Doji, Missimi, you want to talk?
Why my presentation is short. I want debate to do debate.
Of course, yeah.
So Yeah.
No, I say I want everybody to debate about what I would say about the subject. This is why I make my presentation short. Less time to debate.
Okay. So I think we have.
Well,
I think we have Mary Simiyu.
Mary wants to speak as well.
Hello.
Hello.
Yes, you're welcome.
Yes, I'm Sister Mary Tabu Simiyu from the University of Nairobi, Kenya.
Okay.
First, I'm wondering why I was the only person from Kenya in this conference. And I was talking to my colleagues; they had no idea of what I was talking about. So I don't know how public this conference was made, but I think it's good also that when we are planning, we can mix so that we collaborate. There are some things I realize you are doing. I saw somebody presenting on housing, which is a very good topic in our side here, especially in Nairobi. So if our people, like our young people, are able to participate in such, they can also take up similar topics. So if the publicity can be improved so that can involve many of us. I don't know if it was just a regional side of West Africa or something like that. Then
Go on.
my last concern was about are we publishing this work or we are just are we sending the papers after the conference for publication? And if it is that way, in which journal? Or are we just sending back the abstract? Thank you.
Okay, thank you.
Okay.
So for your first question, I would say, okay,
you can go.
Okay, so for your first concern, I would say, yeah, it's it's actually a network. So the way a network is built is like if you have someone who knows someone. So probably you are in Kenya now, and we'll then give you the job to maybe spread the news about Crepas conference, about Asking Network in just around you. You see, so that's actually how we started. So it started in, I would say, in Togo first. Then people say, oh, look, in our lab, I have someone from Nigeria, I have someone from Ghana. So let me talk about it to him. So that's actually how it started. So I think with this idea of networking, we'll get somewhere, and maybe in next year we'll cover, let's say in 5 years or 2 years or one, or next year we'll then cover the whole Africa. Who knows?
I'm sure we'll cover the whole Africa, because we are almost from at least 4 or 5 countries already. You see, so from here, if each one can just try to contact one person, 2 persons from another country, is finished. Africa is only 54 countries, so I think we can cover all the Africa. And we are very happy to have Miss Simiyu from Kenya, because it's the first Kenyan, she's the first Kenyan in the network. So we are spreading to Kenya. Unfortunately, we had someone from Burundi who normally should present, but he cannot be here. But we have now someone from Rwanda, Miss Bettina, and Rwanda, Burundi is the same, so she will spread the good words to the both countries for us. And that's all. And for your second concern, I think there will be a possibility to make publication, but there are some points we should point out at the end of the conference during the round table. So if you can stay with us until the end, and then we'll make a round table and try to talk about this point. And I don't know if Dr. Latif want to add something on this point.
Yeah, thank you very much, Miss Mary Simiyu. Like Dr. Dambe just said, the original plan we had was to make sure that we have a proceedings of this conference immediately after the whole conference. But along the line, we had some challenges because the first thing, the fact that we changed the date of the conference also affected a number of things. You know, initially we planned to have it in July, and then owing to the COVID situation, we had to make some changes. And then initially planned to be a physical presence thing that they were supposed to travel down to Togo for this meeting. We couldn't because of the travel restrictions we have all over the place. So a lot of those things have really distorted our original plan. And those who were planning actually to publish with, it is the Institute of Physics Conference Series, IOP. You must be conversant with that. And IOP, actually, we have entered into some agreement to some level with them. But one of the things that they want us to meet up with before we can get it published in their journal is the number of papers, because it will cost some money to get it in that print form and all of that. And then, so they can only accommodate a minimum number, which I don't think we have at the moment. And they also gave us some guidelines concerning the kind of topic they can accept to publish, which are also issues to discuss. So as Dr. Nambe said, I think we are going to have a final roundtable and then planning and finalizing the whole thing. And I think there we can make some final conclusions on that.
Thank you.
No problem.
So I think, yeah, I think we are almost done with our time. We only have 2 or 3 minutes.
I don't know if someone wants to do something else about the subject, about the debates.
So maybe I'll add 2 words. So just to highlight something that Professor Apology said, I think the first step is actually on our side too. Like we have some research, we have some work done, theoretically, practically, and in our society, we most of the time have challenges. So most of the time, I used to take the example of people like in Asia, mostly in India. So you will see those people where some engineers will just design something simple, not very expensive. Let's say you want to put plants like rice in the ground. So you will see someone who designed just a tool to do that. You have someone want to design something to maybe select seeds, like bigger and smaller. They use maybe they use something that use they call it electromechanical design, and I've seen plenty of documentary or some videos like that. So it's something that we can start, because in order to convince politicians, you have to do something to show them this is what we can do. But if you give me more money, I can do better.
And that's actually people, one of the mottos that we have people have now in the world is the fourth. I think the fourth of the third political force now is communication.
Yeah, the fourth.
The fourth, yeah, the fourth strength is communication. So I think it is that you are talking about.
Yeah. So maybe we can give the speak back to Professor Sugoti, maybe to conclude, and then we'll move to the next presentation.
Okay, thanks. Donc, I'm very happy because everybody have an opinion not so far away from my opinion. So I think that African scientists, physicists in particular, can be able to play a crucial role. And I want them to find solution for African problem. And why not you can look for the person who have a lot of money to support research in Africa. Okay.
Yeah, why not? Okay, thank you so much, Prof. Sugoti,
for everybody.
for doing.
And let's go on.
Thank you so much. Okay. So I think we can. So let's say thank you to Prof. Sugoti again for the plenary, an interesting debate that we have. Thanks to all of us. Thanks to everyone. Prof. Afolabi. So let's go back to science. So I will then ask Dr. Tomiwa to start sharing his screen if you can still hear us. Okay, there you go.
Can I hear you?
There you go. Yes.
Yeah.
So I think you already know the rule. It's 15 minutes of talk and then 5 minutes of questions.
Thank you very much for allowing me to present in this second edition of the Regional Colloquium of Physics. My name is Tomiwa Akinyemi Clement. I'm here presenting. Can you hear me, sir?
Yes, it's fine.
Can you hear me?
Yes,
can you hear
we
me?
can.
Yes,
Yeah,
sir?
we can hear you.
Okay. The topic is in situ investigation of raindrop size distribution using micro rain radar and its effect on microwave radio signal in tropical region like us. Here are my outlines. As a way of introduction, the quest for more communication services are increasing daily, and more access for higher frequency up to super high frequency and extremely high frequency band are now being proposed for satellite services. In the quest to move to high frequency band, rain has been identified to be a major cause of propagation impairment at frequency above 10 gigahertz. So attenuation, which is the reduction in the signal power as communication network travels from the transmitter to the receiver. Effect of intense rainfall on the part of communication satellite. To further compound this problem, the quality of signal received in tropical region, that is Sub-Saharan Africa, is often hampered by very intensive rainstorms that are characterized by large raindrop size distribution along the path of the communication satellite. A model is therefore needed to predict propagation impairment through rain. To predict propagation impairment through rain in order to estimate the link budget and performance of communication along the Earth satellite link. These parameters needed for this prediction to optimize the empirical models. The parameters include the rain rate, the liquid water content, the radar reflectivity, and the falling velocity. Some of these parameters has been measured even at a high at ground level using the rain gauge and the disdrometer. But profile data are very scarce, especially in the tropical region. So hence the need to hence the beauty of my work, because the equipment that I use is a micro rain radar that has the ability to measure rainfall parameters from the ground level up to the height of 4,800 meters. Some of the parameters has been estimated at surface level using that those equipment mentioned, but profile data are very scarce, especially in the tropical region. This equipment used in measuring profile data are readily available in the temperate region, just like the last presenter, what we were discussing the other time. The equipment for measuring profile data are very scarce in Sub-Saharan Africa, especially in Nigeria too. We don't have equipment to measure except for the local rain gauge or whatever. The equipment I use now is only one that we have in Nigeria, the whole of Nigeria. The other one that was installed the other time in the eastern part of Nigeria was not even working up to today. The need for profile data for modeling cannot but be justified, as it has been observed that at times rain continues to fall at high altitude up to the troposphere without necessarily getting to the ground. And the effect, and this can be seen. Are you hearing me, sir?
Yes, we are with you.
Okay. This can be seen in our daily usage of satellite services as it transfers through the atmosphere.
example is our DSTV, the telephone, the telemedicine, teleeducation, and so many other things. So many other communications and satellite devices that we use in our various homes. In this, therefore, understanding the vertical profile of microrange structure is a key tool on physical process of rain attenuation, which is the loss in reduction in the signal power. In this study, we parameterize rainfall parameters into different categories. That is into two different types of rainfall types. We have the stratiform and the convective rainfall type. And I categorize them based on the amount of rain rate. As we proceed, we'll see how I categorize. The main aim of this work, of this study, is to parameterize, that is to categorize micro rain structure based on profile measurement using a vertically pointed micro rain radar to reduce the effect on radio wave and to deduce the effect on radio wave propagation. The objectives are stated below: to measure and analyze all these rainfall parameters, that is the rain rate, liquid water content, radar reflectivity, and the corresponding fall velocity for a period of 4 years. The experiment was carried out for year 2008, 2009, 2010, and 2014. Also to determine the DSD, that is the drop size distribution of the backscatter signals from raindrops, the rain rate, radar reflectivity, liquid water content, and the corresponding fall velocity over different heights. Then parameterize extinction coefficient of rain event into drizzle, widespread shower, and thunderstorm. Also, I use the rain rates, radar reflectivity data so obtained to model the ZR relation and make comparison between values obtained for the A, that is the multiplicative factor A, and the exponent B, with theoretical values for various rain types in other parts of the world to validate my study. Methodology. The experiment, like I said, was carried out in the southwestern part of Nigeria, specifically at Federal University of Technology, Akure. Here is the longitude and latitude of that location and the map of the area. The equipment used, like I said, was a micro rain radar. This equipment we have is divided into two. We have the outdoor section and the indoor section. The outdoor section has the module or the radar control and processing device. This is the transducer. This is the parabolic dish. And this one is now connected to the indoor component. The indoor component has this connection bus that will now be connected to a PC just for analyzing our data. Yeah, the raw spectral power is defined by equation 1. Like I said, the data for the study is for the rainy period of year 2008, 2009, 2010, and 2014. The spectral power is defined by equation 1. Equation 2 defines the number. Equation 3 defines the number of drop size distribution, and equation 3 is the drop number itself. And also, the radar reflectivity is as defined by equation 4. And the rain rate is as defined by equation 5. The liquid water content defined by equation 6. These are from literature. While the fall velocity is defined by equation 7. Then, Z and R, that is the radar reflectivity and the radar rain rate, are related with equation 8. A and B are, A is the multiplicative factor, while the B is the exponent. And the values I got from my results, like I said, will now be compared with results from other researchers from other parts of the world. By the time I linearized equation 8, I got equation 9. And specific attenuation, that is specific rain-induced attenuation, were further obtained using relation in equation 10. The gamma is the specific rain-induced attenuation, while K and alpha, their temperature, their frequency and polarization dependent parameters. They have experimental value that are already in literature. So, and equation 10 was used to now derive to obtain an equation, to obtain a table to plot a plot of specific attenuation with the frequency which would be my discussion. The result, like I said, presented in this work were obtained. Yeah, there are two main classifications of rain: the statutory and the convective. This is how I categorize the rains into drizzle, widespread shower, and thunderstorm based on the values of rain rate. When the rain rate is between 0 and 5, you refer to such rain type as drizzle. When the rain rate is between 5 and 10, the rain rate is widespread. When between 5 and 10 and 40, it is shower, and thunderstorm when it is above 40 millimeters per hour. The result for ZR relation is as shown. The time might not permit me, and the slide might just be too long if I should be presenting all the results. But I have few of them just to demonstrate how the graphs looks like. The figure 3, A, B, C, and D, they are the scatter plot for the radar reflectivity, rain rate, and drizzle for drizzle rain type for heights of 160, 320, 640, 960 meter height. Like I said, this equipment has the ability of measuring rainfall parameters from 0 to 4,800 meters, and it has now been divided into a 16 range gauge, beginning with the first one to be 160, followed by 320, 640, 960, just like that, it will go to 4,800 meters. These are figure 4 is the scatter plot for the radar reflectivity and rain rate for widespread rain type across the heights for year 208 also. Also for the combined from 160 to 340, the combined data, the plot too. As you can see, the values of Z is equal to this, is equal to this. This is the A, this is the B, this is the B, and it has all the plots has good correlation. The scatter plot, because this is the scatter plot between radar, so they all follow the same pattern. So figure 7, the scatter plot between radar reflectivity for thunderstorm rain in the types across height of 160 meters in the year 209. And these are the combines for 209. The same thing with this. These are the values of Z, A, and B, just like that. These are the correlation coefficient. So that these are the Z-R relation for different classification of rain types that we have. And this is combined for year 2014. And the summary of the values of A, B, Z, and R, the correlation coefficient, was summarized in a table like this. This is for 2008. I can't see what it's. Yeah. Then these are the values. That's Z at height 160. You have this. At height 320. You have this. Just like that. Then the next, the same thing with this. These are the summary of the results that you got from the ZR relation. What we have here is the ZR relation. Z is equal to A, R raised to power B. So that's for thunderstorm. Yeah. I now made my comparison between what I got for 208, that's the summary. For 208, for satisform, 208, 209, 2010, and 2014. These are what I got. And from theory, Jones et al. 1970 got this. Marshall and Parman got this. Fujiwara got this. So as you can see, they all look almost the same. So, and for convective, we have something like this. They are a bit higher. And these are my results for convective for year 2008, 2009, 2010, 2014. Also, the result for time series rain rates, liquid water content. So that is the figure 13 is the rain rate, liquid water content, and local time relation across various heights for 7th of March 2008 for a specific day. So I just selected some days where we have enough rain events. So for the first one, the A is this for height of 160, 320, 480, 640, like that. And as you can see, the bulk of the rain that we have here falls between 0 and 20. So that means most of the rains we have here, they are low rain, or otherwise called certiform, because certiform rain is also referred to as low rain, while the convective is referred to as high rain. The same thing with this, the rain rate here, except for this particular day, we have a bulk of it to be convective, but still we have majority still falling under certiform. So also the liquid water content. If you look at equation maybe 4 and 5, the LWC and rain rate, they have the same, they are almost the same, except for the multiplicative factor of the density of water. The density of water, so LWC can be seen to be related to rain rate, where the density of water is a constant. Hence, this explains why the plots of rain rate and the liquid water content versus liquid time follows the same pattern. The same thing with the...
You only have 1 minute now.
Yeah, sorry. Okay, yeah. So let me just go to specific attenuation. From here, we can see that the specific attenuation increases gradually with increase in frequency, both for drizzle, widespread, shower, and thunderstorm. And it is very, for thunderstorm, it can be as high as 80 here, as you can see. 80 here, and this one, if not properly taken care of, it can lead to fading of the communication signal from the transmitter as it gets to the receiver. So the specific attenuation was evaluated for frequency of 1 to 100 gigahertz. This is just to give room for further system design. In general, specific attenuation increases with increased frequency for styrofoam and convective range, and at critical frequency, which ranges from 40 to 85 gigahertz, the attenuation decreases slightly and reaches saturation at 100 gigahertz. We also observe, okay, like I've explained this. Yeah. As a conclusion, vertical profile of range microstructure have been analyzed for different range types based on the propagation point of view. Using an MRR, some case studies of tropical rain over Akure southwestern part of Nigeria are presented in this study. And from MRR observation, rain is classified into 2 different types. That is the drizzle and the stratiform and the convective on different microphysical parameters mentioned above. The DSD at different heights gives an insight of the physical process associated with rain in this region. The result of the analysis will produce a further insight into the tropical rain structure and applicability for satellite communication links, designing at high frequency for tropical sites. As a way of recommendation, as communication networks are growing in Nigeria, it is recommended that more of this research work are carried out at more locations in the country in order to validate results obtained in this region. There should be research collaboration between industries and university research institutes, since government cannot do it alone. Just like the last presenter, the last discussion, since government cannot do it alone, there is need for us to collaborate with the communication network providers, since they are the one making money out of it. And if possible, collaborate with some of our colleagues that are into instrumentation. Maybe it is high time we start developing our own equipment that can serve our purpose here in Nigeria. Furthermore, it is recommended that the measured and validated values of rain rate, liquid water content, Z and W, that is the fall velocity and specific attenuation for particular locations, should be employed by a communication system designer instead of relying solely on the recommendation of the International Telecommunication Union. Thank you for listening.
Okay, thank you.
Thank you, sir.
Thank you so much, Dr.
Thank you.
Tomio. We already have a question for you.
Excellent.
From Dr. Aulabi. The floor is yours, Doctor.
Thank you, Dr. Tomiwa, for a very beautiful presentation. Actually, I have a question. In the presented work, you classified rain into 2.
Yeah.
Depends on the result obtained at the particular location in Nigeria. This classification, is it general to different countries? For example, now,
it's general.
In Saudi Arabia, that we always have rain, maybe drizzling, maybe 2 or 3 times in a year, and that is all. Is this classification, is it general to every location, or it is specific to the location where the data was collected? That's my first
classification
question.
is general. When the rain rate is between 0 and 5 millimeter per hour, it is drizzle. When it is between 5 and 10, it is widespread. It is general. It is widely accepted, and I quoted the references there. The shower is between 10 and 40 millimeter per hour. When the rain rate is above 40 millimeter per hour, it is referred to as thunderstorm. And the first two, widespread and drizzle, they are stratiform type of rain, while shower and thunderstorm, they are convective. It is general.
Thank you, Doctor.
Thank you,
We're talking, I mean, I could not contribute during the Professor Musa presentation. Maybe later I will also add my comment, because Nigeria, to be specific, with Africa, it is very difficult to collaborate. It seems many Africans are lazy. Maybe we need to change our orientations. Maybe later in the plenary section, I mean, a discussion forum, I may add some things.
Yeah.
I just added
Yeah,
it because you mentioned it in your presentation also. Thank you.
Okay, thank you, Dr. Awolobi. Do we have another question? So I think now we are late. I think we are even going to sacrifice our coffee break. Okay, so if there's no further questions, so we'll say thank you to Dr. Akinyemi Tomiwa.
Thank you very much, sir.
Thanks for your presentation.
You're welcome.
So if Prof. Musa Sugoti is around, can start sharing your screen.
Okay.
Okay. So after this presentation, if Dr. Dambe is around, may I leave you the control?
Okay.
Okay. Okay. Thank you.
Hello.
Yes, you can hear you.
Hello.
Hello, we can hear you, Prof.
Do you see my screen?
Yes.
You can see the slide, Prof. You can see the slide.
Okay. Yeah. So I will talk about signal properties of passive remote sensing of insects. Basically, after an introduction, I will talk about passive remote sensing, insect detection, insect signal properties, and conclusion. It's important to monitor or track insect pests for preventive treatment to avoid damage in the area of interest. Conventional method may be time consuming, especially if you have to monitor a large scale. So we can use a light detection arrangement, so-called LIDAR methods. LIDAR methods can be done in active remote sensing that enable to get information as insect wing beat frequency or insect color spectrum. But a real insect event are hard to reproduce or to repeat. So to study the physical properties of insect signal is hard when you use LIDAR methods. So you make a test target which can reproduce a certain behavior of insect and can help to study physical properties of insect signal. But now I don't present here the work on the test target because it's not published and it's a new work that I am planning to publish. So let us talk about passive remote sensing. Passive LIDAR remote sensing. The scenario assumes the source, the light source in the sun. This is we say passive remote sensing. And in the setup, The sunrise assumed to be parallel beam. Hello. Hello. Hello.
Continue, Prof.
It's okay.
Yeah, it's okay, Prof.
Okay, and I continue. No. I say that in passive remote sensing, the light source is the sun. The sun rays assumed to be parallel beam are defined by two angles, theta sun and phi sun, with respect to Cartesian axes. The angle between theta sun between the sun rays direction and the horizontal plane can be determined by the shadow of a vertical rod. The angle phi sun is set between the observation direction and the projection of sun ray direction on the horizontal plane. You can see it in the figure. The angle between the observation direction and the satellite trajectory of insect dotted line is said to be the hidden angle P insect. In the horizontal plane, a graduate disk whose center coincide with the vertical axis of rotation of the satellite trajectory of the insect makes it possible to determine the two angles phi sun and phi insect. So this is the experimental set of top view and current photodiode orientation. To detect signal, you use a quadrant photodiode. It's a detector having four photodiode directly in the four photodiode combined. It has a detector. So light from the insect is collected by a Newtonian telescope, and you use a dark field box at the end of observation to reduce environment noise, light noise. Why you use a current photodiode? Because when using current photodiodes, you have the possibility to detect the relative position of the insect, up or down position, left or east or west position of the insect. If in the figure here. Insect signal look like this. In the left, we have a real insect horizontal upper signal. Horizontal means that the detection will take two detectors horizontally, and we will look for the signal given by the both detector. Both detector for upper signal and lower signal. The lower signal is the lower detector. The upper signal is the upper detector signal. Okay. You can see that we have a time gap between the two signals, the red one and the blue one. The red one is west up east. No, red one is a west signal, and the blue one is the east signal. So if you because you have a time gap, you can distinguish east and west signal and west signal because by using this time gap. Because firstly, the west signal is first detected, so it seems that the insect come from west to east.
Yeah.
Okay. And if you see You compare horizontal and upper signal. Intensity difference can let you know if the insect is in the upper position or is in lower position. So you use signal property to detect the relative position of the insect in the field of observation. Another information you can get from signal is power spectral density you can take from insect signal. If you take the power spectral density, it allows to detect to determine the frequency, the beat, the insect wind beat frequency. The first harmonic frequencies correspond to the insect wind beat frequency. But if the signal is the signal is low, intensity of signal is low, or is weak, or signal is so weak, if you take the power spectral density, it's difficult to determine the wind beat frequency, like the figure for a real insect power spectrum at lower signal. If you see the signal, it's not evident to detect your frequency, your first harmonic of the signal because of noise. The signal property, if you can see the effect of flight speed on signal. This flight speed have to, if the insect cross the field of view with a high speed, you don't have enough oscillation, so that it's difficult to determine insect wind beat frequency. The hidden direction effect, if the insect is not, for example, perpendicular to direction of observation, you can lose insect signal, or you can signal can change. Signal shape can change with hidden direction. But with wind beat amplitude on signal, exchange the modulation of signal, but not the frequency of insects. So I don't present here the system here, but you design a device called a phantom insect to simulate it a real insect wind beat, and this device allows us to study I will say in a common way, in a convenient way, all the possibility to have signal property in all situations. You can repeat experiment because the device can you can make experiment all the time you want. So the first figure with phantom insect low speed, you can see that we have more modulation, oscillation than when we use insect in high speed. When we have the modulation used to the oscillation, we get oscillation, but not the number of oscillation is more is lower than the lower the high speed, the low speed signal. If you take you take the power spectral density, you can see that sometimes you can get the intensity of first harmonic can be low, and the second harmonic intensity can be high. For I give here two spectral density, power spectral density, who we get the opposite situation. For example, for low amplitude wind beat, power spectral density presents a second harmonic. They are more intense than the first harmonic, and we should see another power spectral density for low amplitude wind beat. We have the first harmonic is higher than the second harmonic intensity, so that if you don't care, you can take the second harmonic has the first harmonic, and you can do mistake in wind beat frequency evaluation. Aha. So I will conclude by saying that a combination of heading direction and sun ray direction can make a change in power spectral density of harmonic. Spectral harmonics are important to identify wind speed frequency. In general, the first harmonic has the highest power spectral density in spectrum. However, our study shows that the second harmonic may have the highest power spectral density in spectrum. First harmonic power spectral density can be negligible. The change in wind beats amplitude affects the modulation of signal. The hidden direction can make drastic change of signal intensity. The change in flight speed can lead spike in hidden direction modifies the transit time of insects in the field of view. The use of quadrant photodiode gives the possibility to extract more information from signal. The sense and insect hidden direction can be determined. Thanks for your attention.
Okay, thank you, Professor. Time for questions. So is there any question?
Hello.
Hello, yeah.
Hello?
Hello?
Can I speak?
Yes, doctor. Go ahead.
Okay. So I have a question for Professor Sugoti. Thank you for the presentation first. So in your study, can you distinguish between the signal of different insects? Like, can you distinguish the signal of mosquito from another signal, for instance?
It's possible if the mosquito crosses the field of view.
Mm-hmm.
But because it's a passive remote sensing, the source light is the sun, and to have a mosquito to cross the field of view in this case is not easy. You have to put mosquito here to have a signal from the mosquito. To have a signal from mosquito, you must use active remote sensing, LiDAR active remote sensing. You can use a laser and go on somewhere where you are sure to have a mosquito, and you can get a mosquito signal.
Okay,
Hello?
I see. Yeah, I understand. Thank you for your answer. I thought it was kind of easy, so that you can actually create some kind of equipment to track mosquito and specifically
Yes.
something on mosquitoes, you know.
There are some other researchers make it, but in this work, I want to study signal shape and want to study signal shape and want to see how more information you can get from signal. If you do it from a real insect, we don't have enough signal
data
data to do the work.
Okay, I see.
Because the signal you get is depend on sun ray direction, is depend on insect eating direction, it's depend of sun light intensity you use, is depend of the direction of observation and so on. So if you want to take a collection of data of insect to look about signal property, it's difficult because you cannot have an insect to repeat its movement in your field of view.
Mm-hmm. Okay, thank you.
Maybe you can move to the next.
Okay, if there is no other questions, okay, I think Dr.
Professor Falabi has a question.
Yeah, has a question.
Yeah.
Yes, Dr. Falabi.
Oui.
Dambe, I think you need to give him the.
He didn't have a right to
Okay.
talk. Yeah, sorry. Yeah, it's okay. You
Hello?
can activate.
I want to know whether the presenter actually measured the signal of the insect.
You want to?
Whether he actually measured the signal of the insect.
How he do it?
How he measured the signal of the insect.
Okay.
As a signal insect.
Yes.
The photo diode cadran give a signal, electrical signal, and we use
I think you can show if you can show the page where there was the there was the scheme. Yes, I think it's this one. Yeah.
This one. You use the quadrant detectors.
Let me see. This is your apparatus, right?
You use a cadran photodiode, and we use a data acquisition device. Hello?
Oh. Are these devices fixed or they are in the air? Are they in the air? Whether they are suspended or are they free to move around your device? because these mosquitoes can move anywhere, so you cannot know their direction. They are in binary. Sometimes they move in binary motion.
The setup I use. The setup I use is to study insect like flower and other insect, big insects.
Fly. Okay, but your apparatus, they are fixed. They are not moving, and this set is moving. How can you know the direction when they are just moving anyhow?
Actually, if I understand very well, the point is to detect the insects which go through the dispositive.
The insect was crossing the field of view.
Exactly.
Where cross the field of view, the light reflected on the insect is detected by the Newtonian telescope. The signal was concentrated to detector, and we get electrical signal because the wind beat, the insect wind beat will modulate the signal. So you get, and you use data acquisition
let me see the other diagram. After this one, next one.
Huh? Next
one after this.
Voilà.
No.
No,
The electrical diagram. Yeah, up. Okay, this one. So
yeah.
Stop there. Okay, this one.
Yeah. Actually, there is a space between the dark field box and the Newtonian telescope. So
yes,
all the insects that go through that field.
Here I don't present in the figure because I use a laptop. If you do a data logger to get with time.
So did you transmit any signal? Where did you generate the signal?
The signal.
You see the black one that is
because the
signal is generated, right? Then it collide with the insect. Then something measure it at the end. Is that it?
What?
What signal? Are you generating signal?
Now his question is: are you generating any signal?
The question is:
are you generating any signals?
No, I don't generate. This is the signal I get came from insect. When the insect was lightened by the sun, the insect the light was reflected by insect. The insect I get, it come from light reflected by insects.
Actually, their source, Mr. Falabi, their source of light is sunlight. So when the insect is going through the system, the insect is reflecting the sunlight. It's a diffusion actually.
The Newton telescope
is telescope
reflected by insect.
Yeah.
The
so
telescope
light, they are measuring light reflected.
What is the work of the David box? David box. What is the work of that big box?
The David box. That box can reduce noise from environment.
Exactly. It's a reference. It's a reference. The dark field box is used as a reference to be take off from the after. So it's a kind of reference to increase the signal noise reference, the SNR.
Yeah, when no insect don't cross the field of view, you have what I would say a plate signal, reference signal. If you, it's a reference signal, constant.
Reflection from the dark box.
Well, from the dark box is constant signal. And when the insect cross the field of view, the reflected light coming from insect will give intensity higher than the reference signal.
Actually, I think your concern, Professor Farabi, is that the dark box did not generate any signal. The dark box is just a black screen.
The role of the dark box is to get a reference signal.
Yeah.
Voilà. Because if you don't put the dark box in the direction of observation, you can take reflection from the soil, from something over there.
Okay. I think this work is just on light. Like the telescope there will show that something is passing. You can because it is only aligned to that dark box. So anything that crosses it.
Yes.
So just one mosquito has been studied. How can we apply it to our environment?
We use a program. You use a program is using to acquire signal periodically. You know.
A program.
Program you
just
use
one mosquito. When we can have 100 of mosquito around, one mosquito crossing another one. Okay. I think
any insect crossing the field of view generates a signal. Maybe it can be a flower, it can be a mosquito, and so on.
I think if I can add something, another point that Wasafabi is pointing is how you can use this device. Actually, this device can be used as it is. We don't need to make any modification. We can use it like this. And as you said, your question maybe is about mosquitoes. Yes, we can use it. Everything will depend on the distance between the dark box piece and the telescope. So this can adapt.
Yes.
The application.
All insect crossing the field of view can generate a signal.
Yeah.
Okay. Thank you.
Can I ask something, Prof?
Yeah.
Yeah, just in line with what Professor Afolabi is trying to bring out. How do we take this to our advantage? For example, how can we apply this for pest control? Or for pest control, to control insects, for example. We don't want it.
That is what I was thinking. Just one mosquito is there. We can have many mosquitoes. Just one can be traced. How can we apply it to our environment for pest control?
Yes. Because if you can, for example, if you want to have honeybees, to control honeybees flow, when honeybees go away from the, I don't know, go from their home and come back, you can control the honeybees flow around their home. And you can also control, for example, honeybees predator can get. You can say, if you can know the frequency or the wing frequency for honeybees, you can detect them. You can make a difference with honeybees predator and honeybees. So by detecting the wind beat frequency, you can detect if it is a predator or if it is honeybees, for example.
Yeah, Prof, can I ask something?
Yeah.
Yeah, I think it should be, because I can see from the design here that it's more of a passive receptor. It is when an insect comes, you know that this insect came. Yeah. From the signal. Why can't we generate the signal ourselves to chase the insect? For example, you know the signal that honeybee emits. Why not generate what will affect honeybees such that honeybee does not have a place to stay? Why don't we generate a signal that will send away the mosquitoes? This is the point I'm trying to make.
No, let's pause. Yeah.
Oui. First,
Prof, peut-être que je dois m'exprimer en français, ensuite je vais traduire pour peut-être ceux qui ne comprennent pas. Je ne sais pas si ce que j'ai dit est clair.
Oui, oui.
En fait, la question c'est quoi? C'est que apparemment par rapport au design, comment on appelle ça, comment ça s'appelle, la conception que nous avons ici, c'est que les insectes viennent et puis avec le setup qu'on a, ils émettent des signaux.
Oui, oui.
Et ces signaux sont détectés et à travers ça, on arrive à savoir qu'est-ce qui est venu et on arrive à savoir la différence entre l'insecte qui est venu, soit un moustique ou autre chose. La question que moi je pose, c'est de savoir si on ne peut pas trouver un moyen de mettre, comment on appelle ça, les signaux même qui vont chasser ces insectes.
Allô.
Si nous ne voulons pas, avoir de moustiques, on va générer des signaux qui vont chasser, qui vont repeller les moustiques. Et on fait pareil pour les autres, selon ce qu'on cherche à éliminer dans l'environnement pour contrôler, comment on appelle ça, les insectes, quoi.
Hello.
Dr. Afolabi, please.
Yes. I want to advise the presenter that after this, you should generate different types of light and see which one can attract the mosquitoes. And then when it attacks them, then there's a sticky surface that will just hold them and kill them. Maybe a gum, as they pass, they are attracted to the light, then the gum around that light, they stick them and then they cannot move away. That's a way of controlling the insects.
Okay.
I think if different light, you can try electric field. Maybe some electric field, if you emit them through the generator, it can kill them.
Okay. Okay, I think the discussion can continue. Actually, if I can add something, just because it's a kind of ECL in my research field, also these kind of things. To answer your question, how can we use it as it is? Actually, this kind of setting can be used to estimate the population of mosquitoes, for example, in a region, in a restricted region. Let's suppose that you have somewhere that for example, you have humidity, and we know that mosquito like places like this. So you can put this component at a place, okay, and then estimate the population of the of mosquito at that place. Can be,
if you want to get
I disagree with you. If you want to count mosquito with this one, I disagree with you, because mosquito can go up and come down. You can't similar mosquito. You can count one mosquito 3 times. If you have a video recorder, that is okay. But this one, we just produce confusion. You can count one mosquito 5 times. It goes up, come down, goes up, come down. You have many kinds of counting them.
Actually, we are not just counting. There is a lot of signal processing behind. So this concern can be treated also by signal processing. So it will depend on how you make your signal processing, and because you can try to find some characteristics in the signal to discriminate if you have the same component coming back. So
it's okay. You understand the objective, the purpose of the device.
What I can see is that if you improve this setup, so a signal generator, then some mosquitoes can be killed by some signal, electric signal, magnetic signal. You can attack them again with some light. Experiment how you can reduce the population of mosquito. That's just what you can improve on.
Okay.
This work with that.
Thank you.
Yeah, may I suggest that we move?
Yeah.
Or we postpone the debate for maybe to the end.
Yeah, of course. So let's go to the next presenter, who will be Mr. Yaovi Minyanu Amuzuvi. who will make a presentation on evaluation of pollutants along the national routes in Togo using IRMO dispersion model. He is from the Department of Physics in University of Lomé. So, Professor Sugoti, can you stop your sharing? Or I can do it for you if you want. Okay, it's okay. I've done it. So, Amuzuvi, you have the hands now.
Thank you very much. I'm sharing my presentation.
Okay.
C'est sur la clé. Attends. C'est sur la clé quoi. Donc est-ce qu'on peut aller dans la clé?
Maybe if you are not ready, Pachali can start.
I'm coming, please. Ici. On peut écrire dessus pour... C'est bon, il peut pas. C'est bon? Oui, c'est bon. It's good now. I can speak.
Yeah. Just put it in presentation mode, and then you can start.
Mode présentation. C'est bon? Non.
Vous pouvez cliquer sur diaporama.
Ouais, là-bas, c'est bon.
Vous pouvez défiler ici.
Non, c'est bon, ça vient.
Okay.
Thank you very much. I'm coming.
Okay. Great. So you have 15 minutes, 15 minutes. You can start. You have 15 minutes.
Yes, I'm coming. Thank you very much. My name is Amusvi Yawi Minyanu. I'm working under the supervision of Dr. Mirobum Mikesupo Jagli, and the co-director is Dr. Ejame. The theme of my project is evaluation of pollutants along the road, National Road number 2 in Togo, using the IMO dispersion model. This is the plan of my work. First of all, I will have the introduction, after the material and the method, the result and discussion and the conclusion. You know that pollution refers to the presence of pollutants, gases or particles in the atmosphere. The source of this pollutant pollution can be either natural or relative to activity, especially combustion. We have motorcycle, industrial, and energy production. Exposure to air pollution is responsible of respiratory disease, lung disease, and have led to major death every worldwide. We have 42 million deaths in the world, according to WHO. We have, for the pollution, we have the mining and manufacturing industrial pollution, road traffic pollution. They are matching using poor quality of fuels, commonly Togo we call Bude, and also the domestic pollutants are the biomass pollution. We have different sorts of pollutants. We have polygen pollutants, which are primary pollutants, CO2, SO2, CO, COV, CH4, CF. We have also secondary pollutants, NOx and aerosol. Those pollutants have harmful effect on the health and the environment. For the environment consequences, we have the scarcity of the rain, the drought, global warming to the green due to the greenhouse effect. We have also the acid rays, low alert, the disappearance of certain aquatic and plant animal species. On the human health, the pollution have also the consequences, like the nitrogen cause significant inflammation of the respiratory tract. The PM is an important vector of the respiratory tract intoxication in the area of traffic. At higher concentration, sulfur dioxide have also serious health effects and impact pulmonary function. Almost we have 50% of the fuel imported to West Africa come from Amsterdam, Rotterdam, and trade studies show that 80% of diesel export to Africa have a sulfur content. At least we have 100 times above the European standard. Apart the industrial processes, road traffic is an important source of atmospheric pollution in the world, especially in developing countries, due to the age of the vehicle use and the poor quality of the fuel. In Togo, more than 50,000 motorcycles and taxis travel on the traffic road daily, polluting the atmosphere. And we have also many roads, but the road number 2 in Togo, we use fuel which are hydrogenated with a non-content of sulfur. In this, it is necessary to determine air pollution in this area by the determination of gases emitted. The objective of this work is to evaluate the pollution rate in Togo, the estimation of the concentration of sulfur dioxide, nitrogen oxide, and particulate matter on the international road number 2 in Lomé. After we compare this concentration to the World Health Organization standard limit. For the study area, we have done it in the road number 2 in Togo, Lomé to Aneho. The road is about 15 kilometers. For the simulation, this study was carried at the national road number 2, precisely a distance of 15.4 kilometers. The case of study focused on the evolution of the air quality in this area for the pollutant like SO2 and OSPM emission. The figure below shows the road number 2 in the south of Togo. In the south of Togo, and this is the road on which we have the simulation. We have this road, the traveling of truck, motorbike, lighter car vehicle, and a car. For our simulation, we take the SEIS3 model engineer complex short-term version number 2, which is developed by the United States Environmental Protection Agency regulatory model. The name of our simulation model is REMOView software. This model was used to perform the dispersed simulation of the pollutant. The model was used to predict air concentration and ambient impacts around the point area and the volume sources. For the model, we use the data like the emission rate and the meteorological condition, like the temperature, winds, speed, direction, saline weight, cloud cover, pressure, relativity, and precipitation. We have this data from the station of Togo. We have the hourly data for the year 2018. The model is composed of our meteorological processor, AMET, where we assert the meteorological data to assess the data quality, and we use also the RMOD terrain processor. The concentration for the data use also the concentration who was calculated using the EMEP EEA, European Mountain Evaluation Program, European Environmental Agency, Air Pollutant Emission Inventory Guide Book version 2016 updates. This is the program, the program we have used in the simulation. We have here the source data. In the source data, we put the emission rate of the 3 gases, NOSPM and SO2, who go to M-model dispersion. Here, we put also the geological data, the position of the road. We put it go to M-app. We put also the meteorological data, who we take from the meteorologic station in Togo, who go to M-app. And after we have two results. We have the wing-rose plot, and we have the result of the simulation. For the emission data of NOx and PM is calculated by using the algorithm approach, whose formula is here. This is the formula. This AE is the emission of the polyethylene E, FCG, the consumption of the vehicle category, and EF, the fuel consumption special emission factor. Here is the emission rate of the polyethylene. We have here the NOx and the PM. We have the engine traveling in the road. We have passenger car. Here is the NOx emission and the PM. We have light motor, light commercial vehicle, the heavy duty vehicle, and the L category are motor or the wheelers. For the SO2, we use this formula to calculate the emission rate. Here is the formula we use to calculate for the data. For the SO2, we use this formula to calculate the emission. This is the fuel. For the gasoline, we have here the minimum, the maximum, and the mean value. For diesel, we have also the emission and the emission, the minimum value, the maximum, and the mean value. To know how many vehicle or engines travel in the whole, our investigation on the transport route in Togo, who give us in 24 hours the number of the hosts who travel in this road. To have an idea, we have 10,000 vehicle, motor, car, all. This is the gasoline vehicle, the engine using the gasoline. We have it the day and the night. For the day and the night, we have also the vehicle using also the diesel, the small car, the truck for the day and the night. After for the result, our result gives us the maximum hour concentration of NO2. This is the graph of the result we have for the road. For the NOx, for the maximum hours concentration, we have the value of 16.78 microgram per meter cubes. For the maximum 24 hours concentration, this is the result of our simulation. The simulation gives us for the maximum 24 hours concentration the value of 9.89 microgram per meter cubes. For the maximum annual concentration, we have also the result from the simulation. The simulation gives us the value of 2.46 microgram meter cubes. For the SO2, we have also the same results for the simulation, who give us the value of 71.91. For the 24 hours concentration, the simulation gives us the result of daily maximum, who is 42.41 microgram per meter cubes. For the maximum annual concentration, this is the result of the simulation. We have the value of 11.23 microgram per meter cubes. For the particulate matter, the model didn't give any value graphical representation because of the low concentration obtained. But we have the value of the day and the annual value. The day and annual value give us a low value, like for the daily value, we have 0.62 microgram per meter cubes. And for the annual, we have the value of 0.15 microgram per meter cube. Those values are compared to our WHO limit value. In this table, we compare the value of NOx, 1 hour's value, 24 hours, and annual value. We see that all those values are low than WHO air quality value given in 2000 by WHO 2005. The same result also for the PM, who is low, is low for the WHO value. But for the SO2, we see that the 24 hours value for the daily value is 42.41, but the W2 give us the value of 20. We see that only the mean concentration of SO2 is almost twice the permissive limit set by WHO, which is 24 microgram per meter cube. This is higher value. This higher value allows to confirm the poor quality of the fuel used in West Africa, which may be very rich in sulfur. Effort must be made to control the level sulfur contained in the fuel to avoid impact due to the sulfur dioxide on human health and the environment in Togo. This work helped us to make an article which is accepted by Journal of Health and Pollution. The title of the article is Evaluation of Pollutant along the road number 2 in Togo using the Atmo dispersion model. For the conclusion, the SO2 pollution by handling in our traffic road in Togo is real. This work illustrates the poor quality of fuel used in West Africa, which may be rich in sulfur. This study came as an alert to our government to take decisions in pollutant emission to save environment and human life. Effort have to be made to control or to avoid harmful impact due to this SO2 in human health. For our perspective, the Atmo simulation work for detecting the concentration of SO2 PEM, NOx and PEM must be verified by the measurement for good on the traffic road from sensors. After, our other simulation work will be carried out in the future for desulfurization of fuel used in our road. For the announcement, we thank the Agence Universitaire de la Francophonie for the UNESCO Doctoral Fellowship in Romania, where a part of the work is done. We thank also Société Nouvelle Frontière du Togo, SNPT, for their financial support. We thank also AFSIN, Spectral Imaging Network AFSIN, for their financial support also. Thank you very much.
Okay, great for this very good presentation on time, Dr. Mr. Muzubi. So it's time for questions. So people who have questions, just raise your hand. Even if you are in attendance, we will give you opportunity to activate your microphone. So questions are welcomed. Okay, we have one hand raised from Professor Olabi. Yes.
Oh, thank you for your presentation.
Thank you very much.
Said, what instruments did you use? And hello?
Yeah, we are getting you. You can talk.
What instruments and what is the arrangement of your setup? Let's start with that.
The instrument.
Did you make any experimental measurement?
No, now our work after, I say in the perspective that after we will do the experiment in the road to compare.
They did not make any experimental measurement.
No. But this what you call simulation setup is used in all the world and it is verified. But now I don't do any experimental. Now we have to pay a sensor to compare the two value. Now it's
Is it okay, Professor Falabi?
He said it's using sensor.
After. No. They did not make any experiment. It's only simulation.
It's simulation now, yes.
But you have data on the sulfur content, on the number of cars, the trucks. You have data. How did you get those data?
I have this data. I see it in the If you go to the we have this. We calculate all using this emission inventory guidebook version number 2.
No. His question is about the number of cars that you said that. How did you count them?
Yes, I have the number of cars. I go to the road, to the terrain. I go to the road. We have the station. What we call?
With your instrument.
Yes, they say me that while there are what you call? You say péage. Toll. If you go to toll,
okay.
The toll give us the number of vehicles, the average number of vehicles who go to this road in the day.
They got the number of vehicles from the administration, which have at the customs. Yes, as the custom, they have a system there which counts the
who count it. We say it here a péage. I don't know how to call it in English.
Toll gate.
A toll gate.
Toll gate, yeah. Okay,
yes,
great.
Okay, so at the toll gate, they gave you the data.
Yeah.
Then you went to Europe again. You collected the space data.
Yes, he give us the data.
For those,
the average number of the vehicle who pass in this road. He give us this value
for the period in the year, right? How many weeks did you use to collect the data? How many weeks data are they?
I have. He give us a data for the my work. I have done it in 2018. I have the data of
for what?
He give us for 6 months, and I calculate. He said to calculate the average, and the average give us the value. And they said that also I went there, and it said that it is a minimum of car who pass in this road is about 1,000 vehicle like motor and particular. But what you do, it is the average. Hello.
Okay.
Because at the toll gate, they will give you a sad value because they actually made the count. So yes, you collected the space data from where? From Europe, and that is covering 6 months.
Please,
isn't it?
No, not from Europe. From toll gate in Togo. No, toll gate in Togo, not from Europe.
Toll gate in Togo. It is from my country.
That is possible. So
it's from my country.
How did you get your other data? You collect Arumad terrain data.
The collect
meteorological data. Okay, you collect the meteorological data.
From Togo.
Collect
from the administration, from
administration for Togo, and
from the meteorological service.
For the simulation, if you want to do the work, you want the meteorological station and where you are doing the work, the distance won't be higher than 50 kilometers. I take also the meteorological data from the meteorological station here in Togo for the day for hourly data.
What, please? About 50 kilometers from that road.
The distance between where you do the experiment and the meteor station won't exceed 15 kilometers. That I take the value there, the meteor got the value there.
What instrument can distinguish between SO2 and NO gas, nitrous gas? Please? What instrument did you use for collecting the?
Professor Falabi, he did not use any. Professor Falabi, he did not use any instrument, any word. He just took all the data that he has. He got it from another institutions who are in charge of these data.
Oh, now he didn't have any control over the data, and those data are to tell him the amount of covered outside.
No, the data are from the institution who are in charge of these data. So he don't have any control on the data, but he believes that this institution has made a good collection. His work was more on simulation.
I think.
Okay, I think we should go. We should go from a little up forward. Yeah. To go forward in the discussion because we are going so a little we have Professor Sugoti, if you can ask your question very quickly, and after Dr. Fayose.
Okay. I think the way of collecting the data on the gases is somehow. So maybe you should next time make sure that all the instruments are positioned and it monitors them.
Okay.
For accurate data. Thank you.
Okay, thank you, Professor Falabi. Yeah, Professor Sugoti, yeah.
I just want to ask one question. Do you plan to take measurement in the route?
The experiment,
experimental measurement.
No, now we have a simulation. If you have money, we will pay. I say in perspective that if I have money, I will pay the sensor to confirm the wealth of the simulation and the wealth in the terrain or the road.
Because my question, what kind of sensor you plan to use if you get money?
It is a sensor who make. When I went to Romania Romania, and when there we have the sensor who have to. The sensor, I have the sensor. I see sensor who can measure this pollutant.
Okay.
I work as a white man who use their sensors who can measure SO2, NOx, and also for my simulation, I compare the value I obtain to those value in some country. I compare the value of my simulation. And
okay.
I see for Morocco, for that person make also the same thing in Abidjan and Shuru. And to see, okay. I see also my value is.
Thank you. I think the answer is okay. Dr. Fayos, you have a small question quickly.
Yeah, not really a question. I'm just making a reference to the question raised by Dr. Falabi.
Okay.
The researcher use an instrument that has been calibrated, an instrument that has been done in such a way that precision is guaranteed. So, asking him to go and start looking at the position of the instrument may not. Those issues raised by Dr. Falabi might have been taken care of by the people that manufactured the instrument. So the concern of the researcher is to use the data, measured by those instruments. And for him as a researcher, he too must be aware of some errors, inherent errors in those instruments, which will have to use his software or program to remove those errors, in such a way that it will not affect his results. Thank you very much.
Okay, thank you, Dr. Fayose, for this contribution. I think Mr. Muzovi take notes, and he should, as he said, for his in his perspective, he should take in account all these propositions. We move forward with the next presenter, who is Mr. Kehinde Ajekigbe. Are you here with us, Mr. Kehinde? Yes, he is there with us. So, if you are there, can you share your screen? Are you hearing me, Mr. Kehinde?
I think we have Mr. Pachali before.
Okay, sorry. Let me check. Okay, no. Yeah, Mr. Pachali. Mr. Pachali, with Mr. Hazu, yeah. Mr. Hazu, I will add you. Yeah. Okay. Mr. Hazu, now you have the rights. You can share your screen and
Hello?
Hello, yes.
Okay. Can you hear me?
Yeah, we can hear you.
Okay, so good afternoon, everybody. Good morning, good evening. It depends on which part of the world you are
Good
right
day
now.
to everybody.
Okay. So my name is Pachali, and it's great pleasure. I'm going to present the topic on high background radiation level exposure in the phosphate mining area of Pugame in Togo. I will do this presentation with Azu Eyakifama. So as introduction, we all know that natural radionuclides are found everywhere, like earth materials.
You don't have you don't have a PowerPoint to share.
I'm sharing it. I do not see my screen.
No, you are not seeing your PowerPoint.
No. I thought I was sharing it already.
No. You didn't share it.
Oh, sorry. Okay, sorry. Oh. Is it sharing now?
Not yet.
Not yet.
Did you click on the share screen on the green icon?
Yes.
Maybe.
It's not coming.
Can Hazu try? Ah, okay. Now it's coming now. Wait, it's coming. Okay.
Okay, all right.
You can go on presentation mode. Yeah.
Okay. So can I go ahead?
Yeah.
Okay.
You can start. Yeah.
Okay. So it's okay. So I was okay. So I was saying that natural radionuclides are found everywhere, such as earth materials, human body, and so on, in different quantities depending on the local geology of each location. And if you take uranium-238 and thorium-232, they are parents of two complete series of radioactive elements, and both parents and their daughters products are gamma emitters, and they contribute mainly to background radiation role in the adoption studies with geochemical and physiochemical parameters. Recently, advances on a good deal of care were made concerning the possible effects on human health and the ionising radiation given off from the radionuclide concentration of 226 radium, 232 thorium, and 40 K potassium of naturally occurring radioactive materials, which are maintained in the petroleum and gas products and their wastes such as crude oil, scale, sludge, polluted water, and songs. And they can be present in phosphate mining areas and in processing facilities. So the amount of norm can be also increased due to the effect of some industrial processes, which is non-naturally radionuclides present in phosphate mining areas can induce to gamma radiation external and internal exposure, beta and gamma particles released from uranium and thorium and their radioactive daughters, as well as from 40 potassium. Most of these radionuclides that in phosphate rocks belong to uranium and thorium series and potassium as well. So people living around for sure have been exposed to natural radiation coming from within and outside the earth. If you take international organizations such as UNHCR, in their report, they gave different results of mining industry. So the case of Togo, particularly the fact that the main industry in Togo is the phosphate mining, produced by these largest fields located at Pugame in southeast in Togo. They pollute the environment. So to safely dispose of phosphate sludge produced during phosphate ore mining is a serious challenge faced by phosphate ore producers. So in this country, Togo, the use of phosphate in industry is increasing, and it's important to examine the potential radioactivity exposures of phosphate ores. Also, there is need of a higher quality environmental management to reduce the resulting safety problems for both environment and population. So far under Togo legislation, there are no radiological controls on the operation of these industries or restriction on how waste is discharged to atmosphere, to landfill, to cellar pits, and so on, which relate to its radionuclide content. And no research works done so far address the natural radioactivity in soil sample and its health implication on the workers and the general public of this region. This paucity of information raises radiological concern. It is then imperative to provide information on the amounts of concern. So this work therefore assess the radiological quality of soil and also evaluate the radiation dose in the phosphate mining area in Bogame region. So it provides information on natural radionuclide, 226 radium, 232 thorium, and 40 potassium concentration, and other indices such as rates and annual effective dose rate. So I mean internal, indoor and outdoor. So in Bogame, phosphate mining feed for individuals living around. So especially for employees for sure. So results obtained are then compared with that in literature and internationally recommended levels. So on this note, I call Mr. Hazu to present the methodology of our sample collection and how we treat the data and how we work so far. Mr. Hazu, you can take the floor.
Okay. Thank you for giving me the hands. I have to share my screen. Oh, okay, already shared. Hi, evening everybody. I'm Hazu Yakifama, collaborator with Pachali. Here is the methodology
Mr. Hazu.
Yes.
Are you using the same screen as Pachali, or you have your screen?
I think it is the same screen, the same slides.
Okay, it's okay. Go on. Make a presentation mode, please.
Okay. Okay. Then we have to do it in two ways. Software, we use software and material. Also, to arise to objective, my colleague have already listed, we need to collect soil sample because in this area, it is easy to get soil sample and check inside this sample by techniques. Therefore, after collecting samples, we have to use a tool, which are the gamma ray spectrometry detector. We use in this high pure germanium detector from the Joseph Stefan Institute. And this detector are using a cool system, which are using nitrogen, liquid nitrogen, and we use some polyethylene breaker, and before collect sample, we use the global positioning system to mark the point for future assessment or future relevant or routine in this area. Here are the detector, if I can detect the overview of the detector used in this laboratory, and we have the crystal, which here crystal of germanium. All of them are working with a cooling system in order to avoid noise, to have less noise in results. So the area of sample, we are here in West Africa, and we have Togo, which are located between Ghana and Benin. And in Togo, we have the location which are in southeast. In this location, we are seeing the Bogame site here. And we have just take 11 samples from there, some soil sample from there. And those 11 soil sample was collected in the same manner like this. Every sample comes from 5 sub-sample. We have to take like 200 grams of each and mix to have a composite sample and have all the 11 samples. Then for all the 11 samples, we have 55 points of collection. And the distance between two samples is 100 meters. After this, we have to dry these samples and have homogeneity, try to remove vegetable on this soil sample and try to weight it with this balance and have all the weights to use in measurement. After this, we have to put the sample in the container. Here is the containers with sample already packed and sealed. We have to seal correctly the sample in order to avoid the emanation of radon. Radon is a gas which can emanate on the sample if we didn't seal it. We need to sell it for this reason, because all the decay chain he have listed at introduction. We have the uranium 238 and the thorium 233. In both decay chain, we have radon with short half-life. The two radon have short half-life, and as we cannot assess directly the uranium 238 activity, we have to assume equilibrium with all these radionuclides in the chain. Then we have to store the sample and sell it in order to avoid the emanation of radon and have this equilibrium, which will help us to measure the sample without any error. After getting the activity of every radionuclide, we just move to find the parameters which are going to help us to quantify the radiological impact. And therefore, we have the radium equivalent, which are the common parameter used to compare the activity concentration of material containing.
Please, just for presenters, you have 3 more minutes.
Okay. Then we have those assessments using this tool with Monte Carlo getting coefficient for simulation. And therefore, we will have the dose indoor and outdoor and compare it for the literature and take a decision. Then I can invite the Mr. Pachali to end the results. Thanks.
Okay, please stop sharing your screen.
Audit.
Okay, so our main results and discussion are as follow. So to go quickly, you can see this table of radium, thorium, and potassium. So you can see the value range between 27 and 319, and so on for radium. And you can see also for thorium and for potassium. So our main results are that you can see the mean values here and then the worldwide value. So you can see that radium and thorium values are higher than the UNRCR values, except for potassium. So it's what we are saying here, that the activity concentration of radium were found to be higher for all the samples. And also the variation of activity concentration of radionuclide was following the order: radium greater than thorium and greater than potassium in all the collected samples. So here are our radiological assessment values that we obtained. So the values, for example, for radium equivalent was between 57 and 386. And you can see also for the absorbed dose rate and indoor and outdoor IDR, it is annual effective dose rates. So here you can see in red the limit values recommended for the wall length. Here is our values that we have obtained. So we can say that the radium equivalent of sample 2 was above the recommended, also that it has been compared with other countries, which are Nigeria, Tunisia, and India. And you can see that overall, we are having higher values And the same thing is applied with absorb those rates and so on. So from there, as we can present everything, we just go to the conclusion. So this was focused on the measurement of natural radionuclides and concentration for gamma phosphate mining in southeastern part of Togo. And results were obtained. Results obtained were compared with that in literature and internationally recommended levels. So the values of radium equivalent activity obtained in the present study were higher when compared to the value reported for some other countries. Finally, a comprehensive assessment of environmental issues associated with the phosphate-related activities in programming phosphate mining region, including the quantification of impacts, were highlighted, and recommendation for responding to future environmental contamination from phosphates or operation were made. So these were our recommendations. It was recommended to restore the mining site soil after extraction of the ore and put these areas under control to avoid public access. Avoid also any kind of activities like agriculture and grazing animals that can expose population by ingestion. And finally, this will help to optimize the probability to have diseases such as cancer in this mining area of programming. On this note, I thank you for your kind attention.
Thank you, Mr. Pachali and Mr. Hazu, for this presentation. Time for questions. You can raise your hands if you have questions. Any question? Okay. So we thank you, Mr. Pachali, for this great presentation. I think your work is very important for us who know how this region is. So thank you for this good work, and Hazu.
Thank you.
We go forward with the next presentation from Dr. Fayose Sola, who is in Nigeria and who will present work on quality of global positioning system services within equatorial ionospheric anomaly region in Nigeria from Adenkule Ajasin University. Thank you. You have 15 minutes, Dr. Fayose. You have the floor, Dr. Fayose. Yeah, you didn't unmute your microphone. Unmute your microphone. Okay, I unmute it for you. You can talk.
Yeah, thank you. So the work is on global positioning system signal using within the equatorial ionospheric anomaly region of
Excuse me, Dr. Fayose, are you using another device which is connected?
Sorry.
Are you using another device near you which is connected?
Yes.
Can you switch the sound of the second device because there is lag? Yeah.
So,
good. Thank you.
This is the outline of the presentation. The global GPS, which we refer to as Global Positioning System, is a satellite-based navigation system, consists of at least 24 satellites orbiting the Earth altitude at approximately 200,000 kilometers above the Earth's surface. It orbits in 6 different orbital paths, and the satellites are constantly moving, making 2 complete orbits around the Earth in 24 hours. This is a picture of how GPS looks like. It is developed and operated on DoD, and it enables three parameters, that is position, velocity, and time. There are 3 segments of the GPS: the space segment, the control segment, and the user segment. So the space segment is where you have the satellite being orbited in space. and you have the control segment where you have access to maintain the health of the satellite. The major source of error in this work is the ionosphere. Let me leave this for sake of time and look at the Earth atmosphere. The Earth atmosphere is divided into two parts. We have the lower part and we have the upper part. These studies is carried out in the upper part of the atmosphere, specifically within the ionosphere. That is a region of 50 to 1,000 kilometers above the Earth's surface. And this is where you have the ionosphere that is being embedded in the thermosphere. The ionosphere is divided into three layers. You have the D layer, you have the E layer, and you have the F layer. The F layer gets divided into two during the day because of solar activity from the sun. You have the F1 and F2. This is what we have, F1 and F2 during the day. And this F1 and F2 combine together at night to form a single layer. It gets combined at night because there is, the solar activity at night is nearly zero. It's not completely zero, but it's nearly zero. So this work we are looking at the feasibility of satellite at every point in time. If you look at this small animation, you will discover that the figure changes as the Earth rotates, as the satellite moves around the Earth at a specific time. So what interests us is that we want to look at the number of satellites available at every point, at every time of the day in our local environment here, Nigeria. If I look at this, you see the satellites changing figure from 8, 10, 9, just like that. That is moved around as the Earth revolves around the sun. Again, we have the basic function of our GPS receiver. It separates the signal from satellite in view. It's used to estimate the user position, velocity, and time. It's also used to decode the navigation message to determine satellite position, velocity, and clock parameter. I think that is where people that are flying with a vehicle, that is the air vehicle, will be able to communicate with people on the ground. I just have here a figure of a typical satellite, RTN Task Force 1, that gives us the greatest opportunity in order to enhance the aviation system capacity, efficiency, safety, since the introduction of radio. Well, this is the formula to determine the period of a satellite at a given time. The T there is the period, G, the orbital constant of the Earth, equatorial radius, and I, the angle of inclination. So, like I said the other time, that there are errors that are discovered in the measurement of satellite. The errors are listed here. The sources are due to ionospheric and tropospheric delays. We have the signal multipart effect, receiver clock, orbital error, number of satellites, the availability of satellites, the geometry of the satellite. The instruments used in carrying out this research is what we refer to as SINDA, that is Scintillation Network Decision Aids. The instrument was donated by the United Air Force Research Laboratory, with the principal investigator as Kate Groups. Currently, Kate Groups has moved from Air Force Research Laboratory, but when this research started, it was with the Air Force. CINDA is a real-time data-driven communication, data forecast, and alert system. What that one is saying is that with this system, we have access to real-time data. We don't have to depend on data measured in the past. And its purpose is to aid in the specification and prediction of communication degradation due to ionospheric scintillation in the equatorial region of the Earth. This is a schematic diagram of a CINDA setup. This is the receiver, and this is the antenna. This is the system that is connected to take the data, the real-time data, online data. So this is, the equipment was sent to us here in Nigeria. The one we handle here was the one we installed at Federal University of Technology, Akure. This is the building that houses the Department of Physics in Futa. And this is what we have during the installation. The room here is where we have the GPS monitor. And this is when we're climbing the building to install the antenna. And from these are the people that participated in the installation. And the small figure here represents my very self. So this is the room. This is where we have the complete setup. It was set up in 2006 and still in use up to today. So that was the first in Nigeria. Thereafter, we have some other stations across Nigeria. So these studies, we are going to use data from Futa Station as well as the Center for Geodesy and Geodynamics Station in Toro. That's towards the northern part of Nigeria. And the data we got will determine the hourly value from X hour to 24 hours. What we are looking at is we are taking data from 00 hour of the day up to the 24th hour of the day. Like this, from 00 hour up to 23.59 hour of the day. So we are having a complete daily data, and in the analyzing our data, the seasons are divided into the D season, the ECC, and the J season. Therefore, the available feasible satellites is what we have there. Sorry, there is a mistake in that line. The line is on top of 4. So this is a typical diurnal variability of GPS available at every point within. So what we have here is just for a specific period of the day. And because of our time, let me just tell us that we have over 24 satellites in space at the initial time, but currently today we have close to 120 satellites in space. So how do we determine that? Each of the satellites is allocated with a number, which is referred to as pseudo-range number, PRN, pseudo-range number, pseudo-range number. So each satellite has its own number. So it's easier for us to see if it is PRN1, PRN2, PRN3, and PRN4. So for a particular day, this is the feasibility, how feasible, number of the satellites that are tracked for that period. And this is, from these two figures, it shows that we have the minimum number of satellites available at the earlier part of the morning, that is around between 5 o'clock and 6 o'clock local time here in Nigeria. And we also have the highest available between the hours of 9 a.m. and 5 p.m. look that is 10:00 hour and 17:00 hours local time. This indicates that the quality of the signal received by GPS at this hour is high. That is between the hours of 7:00 to 17:00 local time, and feasibility is low at the earlier part of the day. Again, we are looking at daily mean. What this one is saying, what this one mean is that we have to look at a daily feasibility of the satellites. And if you look at this figure that is being shown here, to around between 22nd and 26th of 26th, 27th of a particular, this is for a particular month. So we have to look at it from day 1 to the last day of the month. And the mean value of satellite track was highest between 22nd and 27th, while we have the minimum around the 29th of the month. And it's, that is an indication that the quality of GPS signal received on between 22nd and 26th is more than that of 29. This is another particular month of December.
2 minutes again.
This is December 2016, if I'm not mistaken. The maximum value occur on the 26th. This is what we have here.
Dr. Fayose?
Yeah.
2 minutes left, please.
Okay. So the next is to show us the monthly variation, and the quality of signal received increases from the month of November to that of April, with the exception of December. We have a low value in December. If you look at it, there is an increase around this point, but there is a decrease in the month of December. And it also indicates that clock error associated with GPS signal, it decreases from November to April. As the feasibility increases, the error, we have a minimum error. So except in the month of December, where we have a low value, and that gives us some little bit of high clock value. The results of this work shows that the feasibility of GPS satellite varies diurnally, daily, and monthly. This result is going to be useful for users of GPS worldwide in the area of geographical information system, remote sensing, navigation, agriculture, weather, as well as weather prediction. The high accuracy of GPS mode allows continuous collection and analysis of GPS satellite location data, and then capture a GPS location that is more accurate than a single satellite data point. Like I said, this result gives enhances the prediction of space weather. Thanks for listening. The data, the figures show here just some figures because of space and time. Because we have that, this work was carried out for a period of 5 solid years. And it was a measurement carried out on site in our area here. Thank you very much.
Okay, thank you, Dr. Fayose, for your presentation. The question session is opened. Okay, we have Dr. Taoritz, who is there for question. Dr. Taoritz.
Hello, can you hear me?
Yeah, we can hear you. You can talk.
Yeah, thank you, Dr. Fayose, for the nice presentation. Well appreciated and well detailed. Some things are not clear to me. In your question where you show the period of revolution of the satellite. Can we go to that slide?
You mean this?
No, you show equations through which we can determine the period of the satellite.
Okay. Yeah.
Yeah, this equation. What does the R represent itself? The R.
Oh, sorry. In this the R represents the radius of the Earth. Mind you, we have geographical location and we have a geomagnetic location.
Okay.
Yeah.
Thank you. And
Yes.
the simulation you show in which the satellites are orbiting around the Earth, which software do you use to, this. Which software do you use to do the simulation?
This particular one, we use MATLAB for this simulation. Yeah.
Good. Thank you, Prof, for the presentation. I think I'm okay.
Yeah. Thank you, Dr. Olabi. So I think we'll close this presentation. If people have more questions, you can write by message to the presenter directly. Okay, thank you, Dr. Fayose, for this.
Thank you.
Presentation.
I wish you a successful deliberation for the rest of the day.
Thank you. Thank you. Okay, so next presenter is Mr. Muzili, who is back for a second work, who wanted to talk about the description and comparison of aerosol properties over Cluj-Napoca, Romania, and Cophoridia in Ghana using aeronet data. So, Mr. Muzuvi. Mr. Muzuvi. Mr. Amuzuvi Yauvi Minyanu.
Hello, guys. I think he's currently moved out, so someone went to call him. I guess he's coming right now. But if they don't find him, maybe switch to the next presenter.
No, anyway, we'll move to the next one. So next presenter, please, you can present is Mr. Kehinde Ajekigbe. Mr. Kehinde Ajekigbe, please, can you present your presentation? Mr. Ajekigbe, I hope you don't move from your post also. This is the problem with online conference. You cannot keep people on the same room.
Please, please.
Okay, Mr. Muzu, you are back?
Yes.
Okay, so you can make your presentation.
I will share my PowerPoint.
Okay. And when Mr. Omuzuvi is doing his presentation, if someone can make a call to Mr. Jekigbe to prepare himself, because I think he is out, he's not in front of the laptop. So if one of you know him, you can make a call to him. Okay, Mr. Jekigbe is back, right?
No. Please, we are coming. Please,
no, Mr. Jekigbe has unmuted his microphone, that's why. You are back?
Wait.
Anyway, prepare yourself to make the presentation just after this one, Mr. Jekigbe. Okay, thank you. Now, Mr. Muzubi, you can make your presentation.
Yes, here. We are coming.
La présentation. Ferme l'autre. Il y a un autre.
You ferme ça.
Let's be quick because we are a little late.
C'est ça, non? Now it is good now.
Yeah.
It's good.
Mr. Kehinde Ajekigbe, are you with us?
No.
Mr. Ajekigbe.
It is good now.
Yeah, you can prepare yourself. You can make a presentation.
Yeah, I come again. Here is also Amuzuvi Yaovi Midjanu. And I said before, my director is Mirohum Itosport Jagli. The co-director is Ejame. The second theme of my presentation is this description and comparison of aerosol properties along the Gulf of Guinea using AirNet network photo metadata of Koforidua station.
Please go on presentation mode.
Oui.
Okay, you have 15 minutes.
Yes.
Go on.
We have for the plan of the work. We have the first of all, the introduction, the material and the method, the results and discussion, and the conclusion. An aerosol is defined as a liquid or solid particle suspended in gaseous medium and located in atmosphere. That aerosol can be natural, anthropogenic origin, and have different sources depending on geographical location, weather, and environmental condition. We have terrestrial aerosol or dust from desert and background. We have also oceanic spray aerosol from maritime area, soluble aerosol, sulfate and nitrates coming from urban environment. We have also biomass fire and house fires, and we have industrial emission, traffic, and volcanic aerosol. Aerosols have major impact on environment and human health. Effect on the environment, aerosols affect the climate in variety of ways, directly by diffusion or radiation absorption, indirectly by acting as conditioning for cloud formation or altering optical properties and cloud life. On human health, the inhalation of aerosol film particles result in different diseases, such as different allergies, asthma, and lung cancer. They have a negative effect on human health that associate with a significant mortality rate. The objective of this work is to evaluate a kind of aerosol which predominate along Gulf and Guinea, especially in south of Togo. For this work, for the material and method, we have the study area. We analyze and compare the optical properties of aerosol developed for means of passive remote sensing using robotic network AirNet measurement with some photomet data of Koforidua station of Ghana along Gulf and Guinea in West Africa. Because Togo don't have this machine, we use this photometer for Koforidua. Koforidua station is located at University College of Koforidua. The AirNet Global Net provides information regarding the aerosol, optical and microphysical properties, and precipitated water contained using solar-powered CML electronic. The data was collected at the station and are automatically transferred to the AirNet processing system through the internet. The data are processed with the inversion algorithm and then made available to user. We have the level 1 data on screen. We have the level 1.5 automatic cloud screen data. We have the level 2. We use the level 2 data because it's a data who is have a quality assured after the calibration and the instrumental at the calibration center. For the parameters, the AirNet network provides two types of data. You have some spectral data based on the extraction of the light through the atmosphere. We have also the inversion data from the angular disruption of sky radiance. We analyze the two parameters derived from that sun measurement. We analyze the two data. The two data are also optical thickness or optical depth. We call it AOT. It defined there as the integrated extension coefficient over a vertical column of unit cross-section. The AOT is the degree to which also prevents the transmission of light. We analyze also the Armstrong parameter, who describe the dependency of also optical thickness on the wavelength. We analyze also the single scattering albedo, which represents the ratio of scattering efficiency to total extension at the wavelength corresponding to the sky radiance measurement. we collect the envelope measurement daily average from January 2016 to December 2018 level 2 data. Use the data which are calculated for every day when the envelope number of measurements is higher than 3. The number of the day for the measurement is shown in this table. We have totally 583 days for the measurement. For the measurement, we have for RT, we have the maximum and the minimum average data. This is the table containing the minimum, the average, and the maximum. If you see in this table, we see that the monthly data of RT has a higher value from December to February. This is shown in this table, December and to February. To have a global idea on this value, we calculate the monthly average RT44 data. This graph show the average value. For this average value, we have the value between 0.106 and 2.580. The average value gives us a value of 0.742. For the Armstrong parameters, we have also in this table the minimum value and the maximum value. We have all those values in the table, and we calculate also the average value of those values. We have seen that for all the months, all the values are lower than 2. All the value of lower than 2. We calculate all the average value of Armstrong parameter data, who is in this graph, on this graph. We see that the value of Armstrong are between 0.12 and 1.93, with the average value of 0.77. For the size distribution of the cost and file volume concentration, we see that we observe a clear dominance of coarse mode value. This is typical of mineral dust originating from Sahara and also marine salt. For the single scattering albedo, we see that the single scattering albedo have a value of 0.088. For the conclusion, at Koforia staging, a RT value have a value between 1.0106 and 2.58, with average value of 0.742, who is higher. We have also the Armstrong value, who is between 0.12 and 1.90, with average value of 0.77. At Koforia, we have also an average value of albedo, who is 0.088. Those values confirm in South Ghana and their neighbor countries like Togo, Benin, they are a predominant of mineral dust like Saharan dust, aerosol mani dust, and harmattan winds. Aerosol pollution is real in those zones like Togo due to the predominance of those mineral Sahara dust and aerosol salt, mineral salt. For the perspective, this came led to take a decision for aerosol emission to save environmental and human life. In future, our research work on the comparison of the value of the variation of aerosol property in Togo during all the term, or during all the term will be done. For the acknowledgement, we acknowledge also the RUF, for our joint UNESCO total fellowship in Romania, where a part of work is done. Also, we acknowledge also Nouvelle Société Favorable du Togo for their financial support, and also AFSIN for their support. This work led us to have a paper. The paper's name is Description and Comparison of Aerosol Properties over Crude Napoca in Romania, where a part of work have done, and Koforia Ghana using Aeronet data. Thank you very much.
Okay, thank you, Mr. Muzuvi, for this presentation. There is a lot of work. So time for questions. Quick questions. You're a little late. Okay. If there is no question, I think you can write to the presenter by messages and discuss. Anyway, all the presentation will be shared, and you can contact the presenters when you want for questions. Thank you. Thanks to everybody. Okay, we have one hand raised. We have Professor Folabi here who have a question. Okay. Professor Folabi. Okay.
Okay. You said that this data were collected at
the Koforia station in Ghana.
Romania, right?
Koforia station, who in year of Togo, Koforia station in Ghana.
You collected in Togo?
Yes, we collect the data in a station from Ghana who have this machine to measure the aerosol. The photometer.
I saw that you said you use photometers. Photometers is a photon counter, right?
Yes.
So how are you able to use photometer to get the particle size of aerosol? Now, how can you distinguish Saharan aerosol from oceanic aerosol?
To distinguish this value, we have to have the value of the Armstrong parameters, their size. If the size is under 2, you have an aerosol from Sahara or oceanic aerosol. If those value is over 2, we have the industrial aerosol. It is the 2 kind of aerosol we have.
So how is it that your photometer, did you actually mount the photometer or you use a data from the space?
Please. I don't get very well the question, please.
I said the photometer that you use, can you show us the setup or is it the space data you used?
If I have the photometer, I don't.
His question, I think, is to know if the photometer, do you use the raw data from the photometer, or is it, or the data has come from a special software?
I use the data from the photometer.
So the raw data, and you make the signal processing to know the size of the particle?
Yes, I have a signal processing to have. The photometer give us the parameters. If we collect the information, in doing information,
Let me see your photometer, please.
Please.
Let me see your photometer setup and the arrangement.
Please, the question.
Did you build the photometer?
If I build it?
Yeah.
If I build it myself?
Yeah.
Hello, I think the presenter can further contact Professor Folabi later for this content.
Yeah. I think you should contact Professor Folabi later, and then you can make a discussion about instrumental tests.
Thank you very much.
I think he is very concerned about the errors and precisions. So
thank you. If I have his addresses, I can do it.
Yeah. You can write message to him through, and then you can contact.
Thank you. I will do it. I will do it for more information. Thank you very much.
Okay, good. Thank you, Professor Falabi, for these precisions. The next presenter is Mr. Ajekigbe. Are you back? Mr. Ajekigbe. Is Mr. Ajekigbe back? No. Okay, if Mr. Ajekigbe is not back, I will ask Dr. Latif to make the next presentation for us. Dr. Latif will make a presentation on elemental characterization of some selected natural fluorides, ORS, I don't know what it is, fluoride ores, using PC technique. Dr. Latif is from Center for Energy Research and Development, Obafemi Awolowo University, Ile-Ife, Nigeria. So, Dr. Latif, can you share your screen? Are you with us, Dr. Latif? Amuzuvi, you can stop. Okay, I will do it. I will stop sharing of Amuzuvi. So, Dr. Latif, you can share your screen and make your presentation. We have 20 minutes late. We are 20 minutes late, I think. No, 30 minutes. Yeah.
Let me share my screen as you said.
Yeah, Dr. Latif, raise a little your voice or be close to the microphone, please.
Sorry, come again?
Yeah, can you be close to the microphone, please?
Can you hear me better now?
Yeah, it's a little better, yeah.
Okay, thank you. Let me maximize
your screen not shared yet.
Yeah, I'm trying to do that. Where's the presentation? It's here. Can you see?
Yeah, it's coming. Okay, great. The floor is up to you. You have 15 minutes.
Okay. Sorry, give me 1 minute to fix something here. Yeah, this one. Thank you very much. Good evening, ladies and gentlemen. I'm Muftaul Latif from the Center for Energy Research and Development. I'm presenting this work of ours at this August gathering championed by ASKIN in collaboration with the University of Lomé. I am from the Center for Energy Research and Development at Obafemi Awolowo University. And also we appreciate our sponsors for this program. To mention the two of them, the ICTP, International Center for Theoretical Physics in Trieste, and also the Uppsala University for their support. So we are looking at the elemental composition of fluorides and some of the implications that might have on the application of these mineral. Fluoride occurs in natural form as calcium fluoride occurs naturally as fluorides mineral. And then why is calcium fluoride or fluoride of this importance? Because it has a number of applications that we are going to mention a few of them. One of the common areas, like Dr. Onia was presenting this morning, he talked about quartz, and then some of, at times, quartz is mined with some sort of fluoride associated with it. We'll also notice this in this presentation. So calcium fluoride occurs widely all over the world. And if you look at the map here, you see a number of places that we are familiar with where calcium fluoride or fluorides in natural form is in large deposits. If you look at the southern part of America, the northern part, let's say the eastern part of the Northern American subcontinent, in a number of places in the US, we have very good deposit of fluoride. Also in Africa, in the southern part of Africa, around Namibia, Angola, they have very good deposits of the fluorides. And also in Morocco, there are huge deposits. In Nigeria also, we have some deposits, not too much, but also quite important because of the application and the good use that we can make out of this important mineral. So in Nigeria, in this particular study, we mined fluoride from two places, two states, particularly in the northern part of Nigeria, Taraba State, and also in Plateau State, around Jos. In Taraba State, it was in Bukari local government. So as I was saying about the application of fluoride, what could push us to do this kind of studies? Why would you want to know the content? Because number one, fluoride among the applications that are widely known of it is smelting. Fluoride is used for smelting, and that allows for the extraction of other minerals from other mining sites. So, and in addition to that, fluoride is also generally called as a very colorful mineral because it occurs in various forms, various colors, and that suggests the content, I mean, in terms of trace elements, and which could be of interest. And in this particular case, we are looking at the rare earth elements and also some other specific elements, and also try through this to explain the origin of these colors. So areas of application also, fluoride is widely used for glass production, for lenses, and then yeah, so glass, in the fabrication of glass, fluoride is highly solicited, and then also to filter light. For example, we know the general study, let's say the what they call this, principle of established by Einstein about photoelectric effect, when the frequency is actually the factor that determines and not the kinetic energy of the electrons and all of that. Because when you do this kind of experiment, you have to filter lights out, the colors you are not interested in, to be able to get the particular color, because for each of these colors, we have an associated frequency, and that determines the energy, because the energy is proportional to the frequency as a factor of the Boltzmann. Someone talking to me? Okay. So the samples that we looked at were taken from these places. We had a purple sample from Jos. We have a green type from Taraba State, a brown type of sample also from another deposit in Jos, the white type from Jos, and then the light purple type also from Jos. So in short, we had 5 locations. And then for each of these locations, we characterize by the color of the sample. We go from there. And then if you note, you see that virtually the purple type and the transparent type were all taken from around the same area in Jos. And then the green type was taken from Taraba State. So the measurement that we do is carried out here because we need to first pulverize our sample, put it in powder, fine powder form to make a pellet. Why do we do this? Is to have a type of homogeneous material. We have to make it homogeneous so as not to exclude some component that are supposed to be there. For example, if you cut out part of the sample and then you take it to the lab and then you analyze, you might have not a holistic view of what the content of the sample is. So here you can see the student who did, it was the master's work of this student, Kingsley. So Kingsley here in the picture was grinding this using the this special miller, this machine for grinding, especially designed for grinding minerals like this, to have very fine powder. And then after getting the fine powder, we can then make pellets of about 13 millimeters that we load into the accelerator. Up here, you can see the accelerator setup of the Center for Energy Research and Development here. So you can see the accelerator tank, and then you can see the control unit. Sorry, the control unit, and then you can see the beam line, and then we have the detectors. Well, the detectors are actually at the other side. We have actually 3 detectors. We have a detector for PIXI, which is this measurement, particle-induced X-ray emission. We also have another detector for PIGA, particle-induced gamma ray emission. And then we have an RBS detector, Rutherford backscattering spectroscopy detector. And then here you can see the data acquisition setup. This is where we acquire the data after connecting, after loading the sample into the scattering chamber and delivering the beam to interact with the samples. And then the backscattered or the scattered particles are detected into the detector to identify the element that is being identified in the sample. So yeah, basically, in terms of the theory of what PIXI is, as I said, particle-induced X-ray emission, but in this particular case, we use proton beam. So people at times call PIXI proton-induced X-ray emission. But we have to note that it is not only proton that can do that. We can also do it with alpha particle. So that is why people prefer to call it particle-induced X-ray emission. But most of the time they use proton because as the lightest element is the sharpest and give the best result. So basically, when the proton beam interacts with the sample, it hits the sample and excites the innermost electrons of the sample. And then when that happens, the sample excited, de-excites, and emits a characteristic X-ray that is detected into the system. And each element that interacts with the proton beam to leave the characteristic X-ray being emitted is identified because it has a specific X-ray, which we call a characteristic X-ray. For that specific characteristic X-ray, we have a corresponding energy, which identifies the element of interest. So we use this to know in details all the elements that are contained in our sample. And the beauty of PIXI, as we have said, is that it has a very wide range of identification of our samples. You can identify as low as even light elements, although it's best for heavy elements, but you can detect as low as, let's say, around sodium in some cases, especially when the calibration is properly done. So the result we got from this study, this is the calibration sample. These are the certified values by the manufacturer. You know, when you want to do this kind of studies, you have to calibrate a system to be sure that what you get is reliable. So the sample, because we are looking at some soil sample, we have a standard for soil. And when we analyze that, this is the value that the manufacturer got. And these are the values that we got. If you compare, you can see there is a very good correspondence and agreement in this results. So our own result, we can see that we have about 25 elements that we're able to identify all together. Of course, calcium is a dominant element. It has about 50% of the content of the element is calcium. Also, fluorine is also the second most important element. And by the way, I need to mention that calcium fluoride generally occurs in a phase cubic crystal structure. And then you can see on the edges, we have the fluorine isotopes, while on the other corners, we have the calcium isotopes. And in them, you have some impurity atoms. You can see in this particular case, fluorine was not identified because it is too light for the setup to be detected. But we have some complementary results from XRF done in one lab in South Africa, which also allows us to extract the concentration of fluorine to be in the range of also very close to 48%. On the average, calcium was in the range of 48 to 52%. So other elements that were identified were sodium, magnesium, aluminum, silicon, chlorine, potassium, scandium, iron, copper, selenium, rubidium, cerium, strontium, yttrium, and all of these elements were able to identify. Though for some of these elements, you can see that some were not detected. The BDL sign you see there means below detection limits. So those were not detected, but some of them were identified in some samples and then not identified in some other samples. Yeah, basically. So this is the distribution of the samples that we had, the elements identified for each of the samples. So you can see the blue one represents the purple sample taken from JOS, while the light blue is a white sample taken also from JOS, the brown from JOS, the green from Taraba, although we present it with a different color here. And then the
Please, Dr. Latif, you have 2 minutes more.
Thank you very much. Yeah. So basically, you can see, and that's some of the elements that are most pronounced in concentration. I mean, the trace elements are silicon, scandium, iron, and this is also in agreement with the previous studies. So now, if we compare our results here with some other reports on the elemental composition of fluorides, although using some other techniques, you can see the difference that this particular study gives us a more detailed concentration and elemental composition of our sample compared to what was reported in previous studies. For example, the second column, well, I'm not sure if you can see it because the panel here, let me see if I can move the panel, is blocking my view. Yeah, I can move it. So you can see the second one was also a PhD study done by Professor Olabanji. He's a senior colleague here. He just retired about 3 years ago or 2 years ago. He did a similar study on the same sample. I think it was taken from, or maybe collected from the geology department in OAU here. The measurement was carried out with a different accelerator. This is the point I'm trying to make here. It was done with a different accelerator. You can see that sodium was not detected in their physics study. Magnesium was not, aluminum was not, silicon was not, chlorine was not, potassium was not, scandium was not, iron. You see, only iron they were able to identify. I also carried out a similar study. Somebody helped me do the same thing from a lab in the UK. And then I had something very similar to this one. So this also tells us how accurate and how detailed this particular setup is. It is a smaller setup, but very, very, very efficient in terms of detection. But also comparison with other techniques like INA, instrumental and neutron activation analysis carried out by Professor Aigbe in 2012, or even Professor Balogun in 1997, you can see that some of these elements also were not detected. Sodium, sodium was seen, magnesium was seen, and then aluminum, silicon, these ones were not also seen. So this tells us the efficiency of. So partial conclusion. The study has shown the power of PIXI, especially with this very sensitive machine, to accurately evaluate the elemental composition of mineral fluorides. We're able to identify 25 elements, which we have not seen before now in all the studies carried out on Nigerian fluorides. These are the elements that we are able to identify. And then the other important thing is that scandium, rubidium, yttrium, plasmodium, and promethium, also samarium, are all elements of a class that are important. Why? Because they are used in light production. For example, to be specific, yttrium is used for exotic light sources. Neodymium, for example, although we did not see neodymium in this case, is used for laser. Samarium is also used in laser, and scandium is also used in strengthening some materials, in some alloys. So these are things that we might be interested in looking at. And in addition to that, the student also carried out, these are outlook, things that we need to redo. I've asked somebody to do this analysis again, another student, so we can be sure before we publish that this correlation, statistical study, further statistical studies carried out by the student is actually accurate before we put them to the public to see. And this is with a view to establishing the role of the trace element in the appearance of the fluoride samples in connection with their respective locations. This is all I have to say. Thank you very much for your attention.
Okay, thank you, Dr. Latif, for this great presentation. It was very instructive. Time for questions. Time for questions. Okay. May I have a question? But it's not a question, it's an observation. I've seen, I can confirm that the calcium fluoride itself can be used also for laser. And the fact that you show that we can have this kind of rare earth in it, maybe it can be used for as a pumped medium. So that's very interesting.
Yeah, maybe the other thing that I was not, because of time or so, that I didn't have time to talk about, I have worked on this. If you remember at Crepas 2018, I presented the paper. That was the paper from my MSc work. It's also on fluorides. And then it is very, very good for thermoluminescence. Professor Dr. Oniya is an expert in that. He knows what I'm talking about. It's very, very good for thermoluminescence because in addition to the fact that it has a very good response, it is also extremely sensitive. In my study that time, I discovered it was about 36 times more sensitive than lithium fluoride that everybody uses. You understand? And this is locally available. We don't buy it, just go and get it and then come out. So these are the things that we are trying to see how we can improve on and see how we can get the best out of them. Thank you.
Okay. Thank you. Thank you.
Yeah.
So if there is no other question, we move on the next presentation, which will be made by Dr. Charity Adeze. Is she there? Dr. Charity Adeze. Okay, I should promote you to panelist so that you can, so you can now share your screen. Yeah. Dr. Charity Adeze Enemunya. You can unmute yourself. Okay. Dr. Enemwe. Dr. Charity Adeze Enemwe. Okay. Good.
She's sharing the screen.
Yeah. Not very well. Your microphone is too far or the volume is too low. We are seeing your screen, but we cannot hear you. Not still. It's very, very low. We just noticed that you are trying to talk, but we cannot really distinguish their words. What? I think it's just because I'm hearing some noise, electrical noise of connection. So I think if you are using a headphone, try to check very well the connection of the headphone in your laptop. Still not. We still can't hear you. If your laptop has a microphone, maybe try to use it directly. I don't know. If someone can hear her, because I cannot hear her.
No, you can't.
No. It's very, or maybe you can speak very loud. I don't know.
Okay, I can't see my screen.
More loud than there. It's a little better, but more loud. Or you can scream.
Okay, let me try and scream.
Are you talking now? Because we cannot hear you. I'm really sorry, but okay. No, we still have some audio problems. Okay, when waiting for you, if Mr. Kehinde Ajik Ajikigbe. I'm really sorry, but Dr. Charity, we cannot hear you at all. There is no audio. You have a problem, yeah. You have a problem with your audio. I don't know why. So if you can try to solve the problem, in 10 minutes we'll have the talk of Jekingbe, who was absent, if he can make his talk very quick. And then we come back to see if Dr. Charity has resolved her problem, has solved her problem. Okay? We still, or you can write, because you can write in chat, because I can't hear what you are saying. Mr. Jekigbe, can you share your screen and make your presentation very quickly? Mr. Jekigbe, he's not there. Okay. If he's not there, that's not a problem.
I'm there.
I think it's here. Yeah.
I'm with you.
Can you share your screen?
It's Miss Ajekigbe, I think. Can you share your screen? Can you share your screen? There is connection problem. Yeah, something coming, Dr. Charity, but not good yet.
I am trying to do that now.
Okay, Dr. Ajekigbe.
Okay, good one.
Yeah.
Is my screen shared?
Yeah, your screen is shared. Yeah, hello.
Yeah, the topic of the presentation is
Hola, there are some connection problem.
Properties of some synthetic introduction. We have two commonly used things. We have which are the commonly used for radiation monitoring. And these particular emission materials, like organic light emitting diodes, are you hearing me? Are you hearing me?
Yes, we are hearing you a little better.
Hello?
Yes, we can hear you.
Okay. It's also applied in a fluorescent lamps, even in a radiation as a radiation detectors. And there are so many researchers, trying to search for active and efficient phosphor as a result of a growing radiation around us. Many ways of improving the properties of luminescent materials, and which ranges from methods of preparation, sizes of materials, syntonic acylation, types of concentration, types and concentration of dopants. And here are so many ways of making the preparation to save our time. Have another aspect is comparing the microparticles and the nanoparticles, because of particular sizes, they also thermoluminescence. In short, this study seeks to survey some factors luminescence in some
radiation detectors. This particular study is just a review of some commercially made detectors. During the 2002 investigated properties of aluminium doped with europium. Prepared by evaporation method, 10% of the concentration of EU was used as dopant, and it was found that this EU doped aluminium was 10 times lower than aluminium doped with carbon. So also, those response was linear in the range 2.4 to 300 microjoule per centimeter cube. Aluminium doped with europium has low fading compared to aluminium doped with carbon. Also, Barros et al. 2010 reported here properties of activated aluminium oxide activated with a terbium, TB, and TF. Combustion route was employed. The sample was annealed in the range 1,000 to 1,400 degrees C, and the annealing optimized the TF intensity of aluminium oxide with TF, but the TF intensity of TB doped aluminium is deteriorated, telling us the effect of annealing temperature. Response of the TL shows linearity, covering a small a total 10, just for the properties of their TL properties. That is the pure, as in the undoped and the ND doped aluminum oxide. Two methods were used here. The Kinney and the soldier methods were used to compare their TL properties. And we can see here that for the material doped with prepared by a soldier method, it shows low intensity at 190 degrees C and very intense peak at 335 degrees C. So also the same TLPs, but with extra one at 125 degrees C were shown from the one doped with neodymium. Aluminum oxide neodymium exhibited TLPs, all of higher intensity than that of an aluminum oxide. For the sample synthesized by a precision technique, aluminum oxide showed one peak at 190 degrees, which is undoped, while the one doped with the neodymium exhibited three separate peaks at 125 degrees, 125, 190, and 205 degrees C. Now I move to the radiation induced electrical conductivity. That is, when this one was measured during gamma neutron irradiation, it was discovered that radiation induced electrical conductivity in the crystal increased with gamma ray. Near tissue equivalence, which is 7.1, make it a promising radiation detector in the medical field. Atuna and 2019 discussed the effect of sintering temperature on dosmetric properties of a BEO. Radiation method was used. The sample were pelletized and sintered at the 1,200, 1,400, and the 1,400 degrees C. The results showed that the total OSL signal a linearity in the range 0.1 to 50 gray for the temperatures. Also, 3.1% and 4.3% of the signal at 1,200 degrees C and 1,400 degrees C, respectively, were faded after 24 hours. Sample center at the 1,200 degrees C showed no fading. This particular makes the latter medical dosimetry. We can also see a work for polyacrylic gel route for BEO. Celsius temperature at 690 degrees C used is much lower than 840 degrees C known for temperature of the traditional method, which is the soldier method. Also, the sintering temperature of the powder is 1,400 degrees C, about 200 degrees C lower than the conventional sintering The physics is to tell us that using this method, it reduces the value of the temperature for the calcination, even for the sintering. Kiko et al. 2004 ceramics higher method of pressing. And pressure was used, such as lithium carbonate, barium oxide, and rare earth metal oxide were used as dopants. Here we can observe that the barium oxide show a positive effect on the of the ceramics. The ceramics show a high sensitivity to ionizing radiation, and this particular ceramics, it can be used as a candidate for use in a laser technology and also in an ionizing radiation dosimetry. Said 1987 investigated the effect of gamma and neutron irradiation on electrical conductivity of VEO. Now, sensitivity decreases as the gamma dose increases from 0.001. Decrease in resistivity with increase in absorbed dose gamma dose is higher for VEO, because here there are 3 types of beryllium oxide used. But for the one which is blue and that of white, you could see the high decrease. Decrease in gamma. So samples of VEO show decrease in resistivity with increase in absorbed fast neutron dose. Displace atoms from the material, and each of these activity of the detector is determined by the number of secondary. It has effective to 16.57. Therefore, it is not tissue equivalent. Also, Singh et al. 2012 studied the transparent calcium fluoride with ceramic for its TL application. Prepared by pressing of a nanophase powder, the dopant concentration that was used given as 1.5%. Ability to measure low level doses down to about a 3 milligray. So as 3.0 more percentage dopant concentration and at a nearly temperature of 673 Kelvin. Another sample which it is a bit lesser.
Please, Mr. Jekigbe, you have 2 minutes more. Okay, we lost Mr. Jekigbe. Since the beginning, there has some problem. Are you with us, Mr. Jekigbe?
Good sensitivity, good linearity of a yeah, I'm with you.
Okay. I was saying Hello? You have 2 minutes. Yeah. We lost. We lost your PowerPoint, and you have 1 minute left, please.
Okay.
Yeah, you can share your screen.
Actually, I'm struggling with the network here.
Yeah, we saw that. Yeah.
Is it shared already? Is it shared?
No. It's not shared anymore. You can share it and.
Okay, let me share it again. shared?
Yeah, yes, it's shared. You can finish. You have 1 minute.
Hello.
Yes, yes. Finish. You have 1 minute, please.
Wow. All right. Let me just go to. Actually, there are a lot of but let me just.
Okay, I think there is some problem with his network. We will stop here, I think, because we are a little late and you still.
You can see that various factors improve the luminance property of some material.
Yeah. Mr. Taurid wanted to ask a question.
Well, it's difficult to ask questions now because I don't even know. Maybe he listens now.
Yeah.
Yeah.
I think Mr. Yeah.
How many presenters do we have now after him?
No, it's finished. Normally, it's Charity who
The question is very, very difficult because of the poor audio.
Yeah, that's the problem. Normally we finished, but you know me. Dr. Charity has
But
some
can we
problems.
allow the woman to try again?
Yeah. That's Charity. Can you try one more time? Okay, and okay. You want to see if your microphone works a little better now?
You are muted. Can you unmute the?
Yeah, you are muted. You are muted, and I've seen that you are connected with two devices. Maybe the second device you can activate the microphone on it. I don't know. You are muted, still muted. Okay.
Okay.
Can you try to talk? Hope this time it will work. Okay, you can try.
I think we can. We can go with that one. Yeah.
Yeah, you can go and try to speak loud.
We'll try to follow. Yeah.
Yeah, very loud, please. A little, but it's really difficult to get you.
Sorry?
Yeah, it's better now.
Okay, so I want to mute the second one.
Just one more thing. Can you switch? Can you the second device that you are using for sharing the screen? Can you diminish the volume there?
Okay.
Yeah. Or just yeah.
How about now?
Good. Very good.
Thank you so much for your patience with me.
Yeah.
Okay.
Very good. Yeah.
So this is Charity Adaize Nemuwe from Covenant University, Ota, Nigeria.
Good, thank you.
And I want to present the work titled Construction of a Remotely Managed Access Control System.
Okay, go on.
And this would be
presentation
my
mode, please.
presentation outline.
Go presentation mode, please.
Okay.
Yeah.
Okay, this is my presentation outline, a brief introduction, then selected literature review, the material and methodology, the results and discussion, conclusion, recommendation, and references. Security plays a vital role in our community, especially in apartment rooms, offices, in school premises. Many institutions do not have a security camera in academic and non-academic areas. So individuals try to proffer security by themselves by using different kind of locks. They try to lock their door, their cupboard, in whatever way they think is the best way to keep security. But that does not stop intruders somehow to find a way to go into the premises to take one or two things that they feel is worth stealing. So this has been the trend in the surrounding community in Ota. So, but Covenant University have a little sense of stronger security by using security guards. But that does not stop the fact that these intruders can use the window of them not being at a particular area to go there to find a way to take things. So it becomes needful to devise a means of remotely managing the access into our offices, home, and other important areas in the community. Some persons have done work on trying to remotely manage access into places or secured areas. The work of Ushe et al. In 2013 designed a remotely controlled device to manage security, to manage access. He devised the security prototype door. But this door has a little setback in its design because it could not alarm. Yes, you can remotely manage the access, but it could not alarm or alert the user that there's an intruder into your premises or your office or your house. So we looked at another work by Anupriya et al. 2014. He used MATLAB software to also design a security system that they can receive messages on their phone whenever there's an intruder. But we also know that you can have text messages if the phone is not with you, you didn't hear the beep, you might not know. So we want something that can give an alarm system to awaken you that an intruder is getting into your office or house. So looked at the work of Crystalline et al. 2016. He developed something like that could sound. And then he also went further to do this kind of lock using microcontroller for different systems. So this informed our choice to design something that we can integrate to our doors, that we can use different security systems. We can also receive alarm or alert or siren blowing in an area if there's an intruder. So to do this, we decided to purchase this readily available component from the market. We purchased the fingerprints, the SIM, down to the buzzer, the DC jack. After purchasing these components, we are to couple it together to produce that kind of remotely controlled security or access system that we want. By that, we mean an access system that you can access your door, check the status of your door from your device. Once you are enabled, you can choose or just check if the door is still locked. And if there's an intruder, you receive a message. There will be a kind of buzzer on your phone, and there will be a siren alarm, such that the security guard will know that something is happening there and quickly go there to check it out. So after purchasing this component, we went further to print the circuit board layout, which I'll show you in the image in some of the slides ahead. Then the 3D is designed to simulate what we want to do. So we went further to put this component together into the breadboard device and the Arduino display system to connect it together to produce this security door lock, a simulation of what we want to propose as the remote access control security system for enhancing security in our communities. So we went further to test it. And then the key feature for this research is actually the fingerprint, because if you are using a fingerprint door, you have a normal door and you can integrate a fingerprint to it. That automatically denies anybody who is not enabled to have access to it. We know of cases where if you go to market to buy about 100 set of keys, there are chances or 0.1% chance that one of those keys will open each other. And then if another person gets hold of your key, person can copy your key or reproduce the key. So, but if you have a secondary lock where you have to use fingerprint, nobody can clone your fingerprint easily, although we know of advanced technology, yes, but not readily available for intruders in our communities at the moment. So we have that, and then we have the other part, which is the siren alerts, apart from the text message and the buzzer. So we use the Internet of Things. This cloud MQTT is the host where we can remotely from our devices check what is happening once we are enabled. So these components that were purchased from the market, we decided to check if what the specification on them at the time we bought them is the same thing. So that is what you have here, the voltage and current specification as it is stated on the device during purchase. And this is the tested. You can see that some of them varied in value. This one measured 50 microampere, while this is 48 watts. The total in the end, we can see that the values are really close. So we could use the device the way we purchased them. So this figure 1 here, figure 1A, is showing us the printed circuit board, just an idea of how we will be coupling each of these purchase components together. And this is the 3D simulation of what we want to do. So this is the experimental setup, like the rough connection. You see, after connecting it, we put it together like this. This is not the final outcome, but this is like a neater one compared to what you can see here, wires everywhere. No. So this is like the package device. You can see our lock there that I want to use to test it. You know that the first question they asked is if this kind of device will not consume energy, because in our community, we use the prepaid meters. So everybody wants to conserve their energy. So why should I do a door that will be consuming my energy when I'm not around? So we're able to show them that it will only take little, something not to worry about. So this is the coupled system. Once it is coupled, you see here, we initiated the Arduino. At the initial, you have to set up your password to become an admin, to know, have the right to be able to add and remove persons. So after the setup, we began by registering fingerprints. So the registered fingerprints were stored in the system. We use these 4 push buttons to do the registration, the add and deleting of individuals. And then we started trying out the registration. When the person puts the fingerprint to open the door opens. It will show on the screen when it's open and when it's closed. When an unauthorized individual tries, you will see the intruder alert. It will show on the person's registered number. The text message will be sent, and then the siren attached to it to blow for the security guards to take prompt action. So this is the internet, IoT, Internet of Things interface, where we put the message to alert when you check the status to know if your door is open, if it's closed, the messages will go to your phone. So after coupling this device, we tried it out because another concern was, is it going to take forever for the door to open or close? If it's going to be time wasting, then let's stick to our old method of using our lock keys. So we tried testing it. We had 6 attempts, that is 6 trial for open, close, and checking of status. So it took an average of 8.5 seconds. And that is not too much a time to open or close your door. So we see that it took us 5 minutes to open, to check the status, 7 seconds, to close 15 seconds, and at the average to operate the system, because sometimes it might be due to network before you get the prompt. It really rely on network, and because we used the 2G system, so because it's just a trial. Once we want to couple to reproduce for mass production, we will be recommending the use of 3G network system, where even the seconds or response time will be far, far, far lower than the average of 8.5. So in conclusion, we were successfully able to design the access control system where you can remotely manage it using your device. And then we also were able to implement the intruder siren to alert the security guards or neighbors for prompt action if in the event where there is an intruder. And we want to recommend that institutions where we don't have surveillance camera, this kind of lock or remote access control system can help the security men or the guards around to enhance security in our communities. We also want to recommend that if this work is to be taken further to the marketplace where everybody can adopt the use, it should be done with the 3G or 4G network mode for faster response. And I would recommend that industrial testing and sponsorship for mass production be supported. These are some of the references for this work. Thank you for your attention.
Okay, great presentation. Thank you, Dr. Enemuye.
Enemuye.
Enemuye, yes, not Iye, Muye. Enemuye. Time for questions. If you have some questions, you have some little time for questions. It's very good. I think this is how we can try to stop using things from outside. We can read them. That's very interesting. Yes, we have Professor Falabi who want to ask a question. Professor Falabi. Yeah, you can go on.
Okay. Thank you for your presentation. You didn't show us a circuit diagram. Then you said that the power consumption is 6 volts, how many milliampere?
It's 0.7 on the average, 0.7 amperes.
What's the wattage of your power consumption?
Okay, I did not calculate that here, but I have it in the main work. I don't know the figure straight off, but I have it in my main work.
Okay. She didn't have it yet, actually, in this presentation.
In this presentation, no.
Is it the circuit diagram that you don't have?
The circuit diagram.
Okay.
Okay, I did not include the circuit diagram in this presentation, but I have it. But I will add it before I submit for sharing.
Yeah, if you can add these data in the PPT when you will send it to us, so that.
Okay, I will add the wattage and the circuit diagram.
Okay, great.
I only added this one, but I'll add
Yeah.
the circuit diagram as well.
Okay, great. Thank you.
Thank
And
you,
we have your contact, and I think this is something that we can reproduce in our university. And since you have done that, we can try a collaboration. So people who want to do these kind of things, don't forget to make a call to write to Dr. Charity, and I think she'll be happy to collaborate.
Yes, very happy, sir.
Yeah.
To do that.
Okay. Thank to everybody. This was very great presentation, and this day was very full of good presentations as the 2 other days. So we are a little late, but we'll try to. Yeah, Professor Sugoti said very interesting as a system. So once again, congrats.
Thank you.
Yeah. So we'll try to anyway try to make the last turn. The last round table. Welcome to the person who are coming back. It's now time for the round table. So it will be very quick since we are a little late. So the idea is first a little conference report, and we will try to make a presentation of our scheme. Yes. Okay. We try to make a presentation of our scheme, and also we talk about the next conference. So I will share my screen very quickly. Okay. Can you see my screen?
Yes.
Okay. So Dr. Taurit raised his hand. So yes, Dr. Taurit, you want to say something? Yeah.
Yeah, I can see your screen.
Okay, great. Thank you. And also, I think I will unmute everybody because after this, it will be just, yeah, it will be a round table. So now everybody is on mute. Is not on mute, is allowed to talk. Okay, so let's go very quick. Oh, come on. So this was a very, very, very good conference. The first time for us to make a online conference. And you know, when you are a baby, you are only 2 years, you are a baby and you have this kind of challenge, I think we can be happy that we did it. That was very interesting experience. So a little report. We got 55 presentations, okay, with I think 3 or 4 absences. So this was very good in 3 days. That means we were almost at the same busy conference, like some international busy conferences. Okay, the only difference is that in the big conferences they have many sessions, but they cannot make more than 50 presentation in one session in 3 days. So I think we were very busy in these 3 days, and that's very good. Little statistics, we got 13 countries which participate, and this is an increase for us if we compare if we compare if we compare with the last conference, we got 6 female researchers with 49, over 49. So that is an increase also for us because we want to be sure that everybody is represented, and we want to go on the good basis, if you can say it like this. And another good improvement is that now we have 7 non-English speaking countries which have participated, and that's very good. And one big thanks to all these persons who make the effort to present in English. Once again, it's not that we are going to become English persons or something like that. It's just because the official language of science is English, and we should try to make the effort. It's something which is very important for us, is to stop this partition which has been made since colonial system. And you have Francophones who make their research in their room, Lusophones make their research in their room. Now we can say that it's all Africans who are making the research, whatever their country they come from, and this is very interesting. The second thing, so all the countries who were there, so we have Mali, we even have Japan. Okay, it was a Togolese from Japan, okay, but it's Japan who was there. We got some friends from Kenya, we have South Africa, Cameroon, Niger, Benin, Rwanda, Burkina Faso, Ghana, Ivory Coast, Nigeria, and Togo. So Nigeria and Togo win the the percentage of participation. And we hope that next year, next conference will be more than 13 countries, and this will be a great improvement for us. So I think, yeah, this is the quick reports that I can make. The next points that we would like to talk about very quickly. Okay, we have one person who wants to talk, I think. Effectively, we have to improve the gender balance. Yes, you are right. You are right, Professor Sugoti. But we hope that we can do it. Yeah, we hope that we can do it. And yes, we can, as someone said. So next point is a little talk about Askin. So I will ask one of my fellows who want to talk about Askin very quickly for us. 1 minute, just take. My screen, okay. So can Doji talk or Latif talk a little about Askin for us quickly? Doji?
Yeah, hello?
Yes, I forgot. Professor Olatonji was not included. Yeah, we have Saudi Arabia also, of course. So it's 14 countries. Yeah, a great improvement for us. The first Asian country coming in the conference. That is great. Thank you, Professor Torres, for the record. So yes, Doji, can you make a quick resume about what is Askin and the goals for us, please?
Okay, I think I will make it very, very extremely short.
Yeah.
So Askin is the denomination of African Scientist Integration Network.
Yeah.
Scientific Integration Network. So it is a kind of network that was developed from an idea from people like African from diaspora first, who actually think that we are a lot. Like when you travel, you meet many people from Africa who are doing great job. So we thought that we can actually make something that we gather us, and we can first share our work, and then secondly make some collaboration, because most of the time we actually find that people are very excited to make collaboration with the Western countries or in like in US, China, India. But then when it comes to be collaborating among ourselves, we kind of hesitating. So Askin is actually this kind of organization or this kind of network that build this connection among us. So what else can I say? I think the other part of asking the other idea of asking is to make science in Africa by Africans. So what we mean by that is we don't necessarily so the idea is not to necessarily wait for someone to give us money before we can start science. For instance, the first conference that we did in 2018, it was an idea that we developed first, and we say, look, we want to organize a conference, no matter how we have money or not, and we decided to put money ourselves. So we did it, and then fortunately we get some sponsors from ICTP and ISP, and actually I think they give money for people who will travel. See, so we were able to buy a flight ticket for people coming from abroad. So Dr. Dambe is now showing the website that we have developed. So guys, I think for people who submitted abstract, you are somehow used to this website. It's not yet fully developed. We are still building it. Then yeah, I think that's all I can say from myself.
Yeah.
So if someone
And
wants to add
also,
something,
if I can add something very quickly before talking about the website, another point, and I think the PhD student has remarked that it's very important for us. The conference will always, and I hope always, be free for PhD students, because that was one point that we raised in the last conference, is that African institutions, research institutions, don't give too much money for PhD students to go and share their work with their fellows. So usually they have to finish the PhD before starting doing this kind of things. So Askin will try at his best to give them this opportunity to make their presentation every 2 years. At least for the moment, the conference is for every 2 years, and the network can decide to change it after that. That's it. And now I will talk quickly about the website. So as Dr. Dojit said, it's not finished because we are very busy on our research and lectures and all. So I just present some projects in the Askin network. Okay, so the Crepas is one of our projects, okay, which take us a lot of time at this moment. But there are also two main projects also. This first one is the lab facilities. So what the lab facilities? The lab facilities is a project that we developed to support the facts, to support the collaboration between African laboratories. So one of the point that one of the remarks was that usually why people are looking outside of Africa when they want to make research is because they don't have the equipment. And the problem actually is that even if we don't have equipment, we usually forget that in the country near us, the equipment can be there. Okay, so maybe you don't have all the equipment here, but maybe just in the country which is near you, they have that equipment. So we want to share that. So the idea here is that you can, if you are registered, and everybody here is registered now, you can come and add your equipment, okay? So you add your name, the email address, and also the lab name, the country, and here the instruments, the scientific instruments that you think that you can share, okay, with the community. a brief description of the instruments, okay, and the person that we should contact if you want to come in the lab and make some work, collaborate with you. And in the description, if the measurements should be paid or something like that, you can tell it, you can say it. All the conditions, you can put it in the description of here. And then all the person of the network will be aware that this equipment is available at your lab, okay? And if one day they have the need of this equipment that they don't have in their country, they can contact you and see how you can collaborate, if they have to pay or not, or if you just scientific collaboration and publication. Okay, so that is a very important project for us to support the collaboration between African countries. The second is the open journals, okay? So the point here is really to develop what we call today the like archive, you know. It's just for persons who want to share their contributions. For the moment, it's just an open journal, okay? There will be a reviewing, but it's a free reviewing inside. So for the moment, there is no indexing and all, but we hope that, who knows, in the future, if the network is going up, we can go up on that level and index it if we can. But for the moment, it's just communication. So the idea is to write some articles, and also we are thinking about writing some articles which will be for the non-scientific public. Okay, so people. So the idea is to be a little more on the communication point, also try to spread the science to people who are not scientific. And I think this is very important also. And the last thing is the project. So we are open to projects, propositions, okay? So, okay, yes, I forgot also in the main idea of the open journals, we have also some ideas of science divulging projects. So we have organized in collaboration with some other associations, the Math Camp. Okay, the Math Camp is a camp for spreading mathematics among students in college and primary school and all. So it was done with the collaboration with SAMI, which is the Association of Supporting African Math Initiatives. Okay, so that yes, last year was our first try. So we hope that we will do it once again, and we hope that all the network will support the project. So I was saying that, yes, you can also make your, propose your project, okay? We are open for that. Okay, there is this link. So you can also propose some projects, okay? And we can talk about that and all. And also, everybody now has received, okay? Everybody now has received some password. So you can connect yourself, okay, on the website, okay? So I'm showing, you can connect yourself, and when you be connected, you have here a link, an icon with your name, and then you can see if you have submitted some lab equipment, okay? If you have some Crepas submissions also, you have them here. If you have proposed some projects, they will be there. And also the good thing is, for example, for the lab facilities, if I go there now, because I'm connected, I can see the person who I have proposed. So it's very important to see the person who has proposed some equipment. You should be connected. So all the passwords that you have received that are very important. So I think to be quick, to be short, that's all I can say. For any other question, don't hesitate. Write to us at the contact@askin.org or info@askin.org. You all have these emails, or you can write to anybody in the network that you know. Okay. Next point. next point was, yes. So before we talk about the choice of the next host country, Dr. Latif, can we talk quickly about the publication of the article? Or maybe do someone have a question? I'm sorry, I was very concerned by being short. Someone has a question?
No question from here.
Okay, so Dr. Latif, can you make a little point about the publications and inform people on how it will work, and quickly we can go on with the next host country.
Thank you very much. I can see that we are not so many here, and it is important that everybody should be present at this moment, because the decisions are going to be made now and will be binding in the next 2 years when we are organizing the next edition of the Crepas conference. Anyway, in any case, whatever we decide, I want to believe we'll have to pass the information across. Like you said, we are happy that we had more countries participating this time compared to when we started in 2018. And I hope that in 2022, we are going to have many more countries present, probably half of Africa. Why not?
I hope, yeah.
And then also, like Dambe was emphasizing, he talked about the collaboration. This is an opportunity for us to come together. And I want to believe that during the presentations, we have seen people doing things related to what we are interested in, so we can always link up with them. Our email address and the contact of everybody can be accessed through the website. And if for whatever reasons we have not been able to get that right, we can send an email to asking admin, and then we can get the list of everybody with all the details. So those are things that we are very, very concerned about. Collaboration. We want to get to higher heights from here. At the next edition, we want many more publications from our collaborations. We want many more ideas, many proposals, talk together, prepared together. Like some of us are already trying these things, and we hope they are going to bear the fruits that we hope to get from them. Now, as for the publication of the proceedings, like I said earlier, this is something that we have been fighting to achieve. Dr. Olabi has done a lot of work on this, trying to make contact with possible publishers before we arrived at the idea of using IOP for the publication of the proceedings. Very good idea. We also got it with our colleagues from Covenant University through Dr. Adeze, I don't even know her new surname. What?
Adeze Enemwe.
Well, Enemwe, exactly, because I know the other name. Before she got married, she was my colleague here for many years and all that. So they have their conference published by IOP. So we were trying to do the same thing using their own channel. IOP is quite open to accept us, but they want us to have at least 100 publications, 100 papers published in our proceedings. This is going to make the price, even the production, cheaper. Otherwise, if they want to produce less than that, it might be higher, and then it might be difficult for us to bear the cost. So at this point, I wouldn't want to say we are not publishing, but probably we'll have to get back to them again and tell them we had only 54 presentations here. And then out of the 54 presentations, probably the ones they can publish are like 50, let's say. So if it is 50, it might be as high as, let's say, $200 or $150 per publication. That would be on the high side for most people. Because the plan we had was, because if we were able to make 100, I think they told us they will collect maybe, is it $65 or $70 or so per, which I think is quite easier, especially if you have more than 2 or 3 people on the publication, they can contribute to $20 each and all of that, and that would be easier. But still, we are going to see how far we can go on this, and then hopefully very soon, through asking, we are going to send email to all participants and inform them of the final decision. Thank you very much.
Okay, thank you, Dr. Latif. So I would propose that we can try to send email.
Yeah, thank you, Dr. Latif.
Yeah, you can go on, Dr. Olabi.
Yeah, regarding the publication.
Yeah.
You can go on.
Regarding the publication, I think if IOP can agree to publish 50, but at a high price, Hello?
Yeah, we are getting you.
Yeah, at a high price, we can consider that. We can maybe you can look for external funding that can help our people. Let's make a trial. If it is at higher price, it's better than not to publish at all. Because if our works are published in NIOP, it adds more flavors to our conference in subsequent years.
That is true. I agree with you.
Yeah, we should don't let us bother about the money. If the money is too high, we can look for sponsorship. Perhaps might see some organization that can help us out. All the authors. Yeah.
Okay. Okay. Thank you. I think this is a good also because we had received a message from Uppsala University, who was supporting us for the first edition. They were saying that if we were keeping the physical conference, if yes, they could help us once again, but unfortunately we couldn't keep the physical conference. So I think we can send them a message and say that finally we made the online conference, and if they can help us for the publication, so we can try it. It's an idea. But I think we should first be sure that everybody, at least on the 55 presentation, at least 50 are okay to write the final article.
Yeah,
So I think we should be okay for that first, and collect the articles, and then see what we can do with them. So we will.
Good.
Yeah. Okay. Thank you. Another word? Someone to add something? No.
Our seniors have not spoken. Professor Olabi, we have not heard you. Professor Olatunji, we haven't heard you, sir.
And I think Professor Sugoti left.
Yeah, Professor Sugoti is not around. We need to hear your feedback, please. Dr. Akinyemi, please feel free to comment.
Are you with us? No, I think I think Professor Falabi. Yeah, Professor Falabi, you can go on.
Hello, sir.
Okay.
Yeah,
Hello?
hello, Professor.
Yes, we have started a good conference in 2018 for developing Africa, such that we also become important in the organization of nations. Are you listening?
Yes, we are.
Yes, we are.
So now that the work has commenced, we have to start properly. And I also encourage each and every one of us to put our details on the website for more research collaborations.
Yes, thank you very much.
And that after that, we should look for more sponsors to sponsor several researches that we are doing, such that when they see our work and publication in reputable journals, we have more sponsors, and then we can do more research.
Yeah.
And I will say that you should not leave ICTP alone. They sponsored the first conference. They can still sponsor this one and the subsequent one. So I see that you have started. We have started good works, and then I'm even supposed to ask you that this registration we did. Some will be members, some will be associates, and some will be fellows. I think you should categorize that and see the several qualifications and to be in any of those categories, so that this will be a professional society too. So thank you.
Okay, thank you for these good advices. That is a good idea. We try to implement in the website, so really to the webmaster, this possibility to have the list of members.
A database.
You said?
A database of all participants.
Yeah, the database of our participants. Okay.
Email address, phone number, contact.
Yeah. I will send it to the webmaster so that this could be possible. Okay, thank you. And also, as he said, with
and we
trying
can
to
put our research publications, including this one, most of them on the website.
Yeah. Okay, we will try to see what we can do about that. Thank you.
Our pictures, our research areas, our focus, and recent publications can be on this website.
Yes.
So that anybody that just click there, we can just see us.
Yes.
Okay.
And what we have in our laboratories, things like that.
Okay.
Thank you.
Yeah.
Thank you, sir. Okay, so last part. So from the first edition, two countries who asked to host the next conference. It was Ivory Coast and Nigeria. But the problem is that at this conference, we didn't have a lot of persons from Ivory Coast. The point now is to ask the person who are present actually to talk about who will be the next one. So I will ask everybody, I don't know how you proceed, maybe just by making a little election, I don't know. What did you propose, fellows?
Actually, I will propose Nigeria.
Me also. So people will have the choice between Nigeria and Ivory Coast.
Yeah,
Hello?
I think you should consider the cumulative attendance, 2018 and 2020. I think Nigeria will take the uppermost now. You consider the cumulative attendance.
Yes, of course.
Prof,
Yeah.
Prof, we need to normalize it to the population.
Yeah.
That is interesting.
I think after the normalization, Nigeria still takes a edge, I think.
Okay.
No, I'm voting for Nigeria.
Okay, you're voting for Nigeria also. Okay.
That's interesting.
Yeah. Dr. Tobiwa?
Hello, sir.
Yeah. You are voting for?
For my country too. If I have my way, I would prefer Nigeria to host the next conference.
So Mr. Serge also is voting for Nigeria. Okay. Me also voting for Nigeria.
Nigeria is taking the lead.
I think.
We'd like to see your faces very, very soon in Nigeria.
Professor Sugoti, you are back. So we are voting for the next country. It was two countries who has proposed themselves. It was Ivory Coast and Nigeria. So Professor Sugoti, who are you voting for?
I will vote for Nigeria because I want to speak English.
That is good. So Professor Sugoti also is voting for Nigeria. Bertako.
Hello, guys.
Yeah.
I'm sorry, I'm driving right now, but since Nigeria is massively at the conference, I just can't vote anyone else. So yeah, just Nigeria on.
I think Nigeria is
And
winning.
I wanted to know, do we still keep this conference every 2 years, or we can kind of adopt another formula? Because I think it's kind of something. Maybe we can try to do some online 1 year for online and the next year for people gather together to do it. But this is just an idea, so just let in case because if we want to keep it every 2 years, I don't know whether it will like maybe every 1 year from maybe not from the next edition, but I don't know.
No, I think it's a very good idea. The point now is to see the motivation of people. So Dr. Latif want to say something, I think. Okay, so I think we can discuss about this point in the network. Okay, the Professor Falabi want to say something. Yeah.
I think since we are doing good work, we should increase the intensity of the good work. If we consider doing it yearly, it's okay for me. Okay. So I like it. Then it will make us work harder to develop Africa, to develop ourselves too.
Another thing is the preparation actually, because preparation, a year may not be enough to achieve adequate preparation.
Yeah, that's actually what I wanted to say. The organization it's actually a lot of work.
Yeah,
it's a lot of work, and considering we also have our own research going on.
Actually, about the organization, I think the most important thing is to renew the team. If the team is changing every year, it's possible.
Yeah, I think I agree with Dambe on that point. The main problem with organizing was the fact that the organization was the same people at the same time. So if, for instance, Nigeria next year try to gather a new team that work hard to make the conference available for that year, and then the next year another country, then the work will be done. But then do we have result to present? That one also is another issue.
Yeah, having result to present, but also if at least we have 2 or 3 persons who will continue with the new team each time. So that's all.
To guide them.
To guide them, with the resources they already have. So I think it's possible, but now it depends on us. If we choose to make it every year, so we should be very well organized, change the team. So each country who organizes it will build his team and will be supported by the person who has organized it the year before. So that's the point. So, okay, I think we can discuss about that in the mailing list after, because now we have the mail of everybody and try to discuss about that. Okay.
Before we leave, before we go to next point, please.
Sorry, I wanted to say something. Even if we say Nigeria, do we have to choose the university that should do it, or Nigerian people decide?
I think, for me, I think Nigerian people decide, but.
Yeah, we decide that among ourselves.
Yeah.
Okay.
Yeah, Professor Falabi want to talk here.
Before we proceed,
I think we should open a Telegram for all of us. A Telegram or WhatsApp. For the group.
Yeah. We have a WhatsApp, but we didn't add yet the new person who came this year. So
Telegram group.
Yeah. Okay. We'll do it surely in the next days or week.
Please, certificate of participants will be given to all the attendees, please.
Yes, of course. Certificates for participants, and for presenters, it will be specified that they have present something.
Okay, good.
Yeah. And also for organizers, it will be specified. Okay.
Good.
So it looks like Nigeria is winning. So I think we'll not continue because all the persons who don't vote yet are all from Nigeria. So I don't think they will vote for Ivory Coast. So Nigeria win. So the next Crepas will be maybe next year or in 2 years. So we'll decide this in the next weeks in the talk, in the discussions, and it will be in Nigeria. They will decide themselves about the university or the city who will host it. So we hope that everything will go very well, and all who organize this team, this conference will be with them. So I think I finished my job. It's up to you now, Professor Latif, Dr. Latif, and all, if you want to say something for me. So, okay.
Yeah, thank you very much. I don't really have much to say. All has been said as far as I can remember. And then the very good suggestions that Professor Afolabi has made, I think we have to take them into account. Having a database of everybody that participated in the conference, contact details, probably having a profile of all members of ASKIN on the website, why not? Maybe a passport photograph showing you for people to identify you, your profile, like a sort of CV, so to say, and then the publications, and then probably make the papers even available online there, so people visiting the website can also have access to the publication and read them and all of that. So another thing I also want us to emphasize is what Dambi suggested, that the sponsors, the money they gave us, I don't know how much it is $3,000 or something, I'm not sure. If
no, last edition it was specially specified to buy tickets, so it was a little high. It was 3,000, I think, but it was specified. So if we ask now for just publication, I don't think they will give us all this. So
okay, but I think Oxala has already given us money, right? Just that we
Dr.
cannot.
Latif.
Yeah.
Dr. Latif.
Yeah.
Sorry, in fact, the money, are you talking about ISP?
Yes.
Yes.
I think they already gave the money since March.
Yes, that's what I'm saying.
No,
what
they
I'm
didn't
saying
give
now
the
is
money.
this. We
They
will
didn't give
continue
the
to
money.
negotiate from tomorrow. I'm going to get in touch with the person, the liaison person, so we can again reach out to IOP to finalize.
Yeah.
Telling them we have about 50 publications, hopefully. So the only thing we'll have to do is to give ourselves time to finish up with the write-up of our articles to get them ready so we can begin the review process and everything, so we can also finally submit to them for the publication. Now, as we are saying that we are worried about being able to pay for the publication for individuals because of the cost, that would be high. If they agree to support the publication of our articles with the sponsorship they want to provide, then we'll be glad.
Okay.
Yeah, so we have to work towards that. Dambe, Beltaco,
Yes.
we have to make a move with the Jagli to see if we can use that money for the publication of the articles. And then also on my part, I'm going to get in touch with the other man from tomorrow. Tonight, I'll send him an SMS to see how we can push IOP to finalize the whole thing.
Okay. Okay, great. Just a precision, Dr. Betako. Get the money. It was a message to ask us if we are going to do it in physical conference, then they will send out the money. They just said that they are okay. But since we tell them that we are going online, we didn't get the money.
No, I don't remember, but I think since I had a discussion with Dr. Jagli, who told me the University of Lomé already have the money, and then he wanted to get it before the conference so that we think about it together. But I'll confirm that with Jagli.
Okay,
anyway,
confirm that.
yeah, I think we just need to confirm that with Dr.
Yeah, we need
I'll
to
confirm that
okay,
with
okay. I was not informed. Okay, anyway, all the network will be informed when when it will be confirmed. Okay, thank you. Thanks to everybody. Thanks for this.
Maybe before we go, the last thing I would like to suggest, or maybe I don't know if it's a suggestion, I will be very, very, very glad if the next edition is in my department here, please.
Oh my God, the fights have started.
This is a good fight. I like it.
He will pay for that. He will pay for that so that we can vote for him.
Okay, so I think it's this will be the closing words. Thank you. Thanks to everybody. Really, really big thanks. We didn't know that we could do it, and we do it.
Well, we were worried. I was very, very scared.
Me also.
I was thinking we are going to have a lot of challenges. And then when I arrived from my very long trip, because I spent almost 18 hours traveling, I spent about 6 hours in Istanbul waiting for another flight and all of that. When I got here, I was a bit tired. I was worried that I couldn't connect yesterday. And then today I can see the whole thing went well. I'm very, very, very happy. And we hope the next edition is going to be much better than this. Thank you all.
Yeah, I hope also. Thank you. And everything is good. And And we don't forget our friends from Eastern Africa. Thank you. That was very good. And we hope that you bring us a lot of researchers next session, next edition from East Africa. We are spreading very fast, and this is good thing. Thanks to everybody.
Okay, bye everybody. Thanks.
This is the
Thank
end.
you. Hello, bye. Thank you all.
Bye.
Yeah, let's stay in touch.
Yeah, if someone wants to talk for the last time, this is the time, or never talk again.
We'll continue talking on WhatsApp and everywhere.
Dr. Ada, is he online?
Okay. Is it bye-bye?
Yes.
Bye-bye.
Bye-bye,
Okay.
yeah.
Chantal, ouvre le capot, tu
Okay,
prends
bye-bye. Until
les deux
another time.
Okay.
Bye.
Bye-bye to everybody. Yeah.
Please remember
thank
to
you.
add me in the email list.
Yes, you said?
Remember to add me in the email list.
Yes. Yes, I think we don't have you and also Professor Olatondi. Please, Professor Olatondi, can you give us your email by SMS? And also, Hazu, please send your email by SMS. I don't have the email for both of you. By the chat, not SMS, the chat.
Send it in the chat, yeah.
Yeah, send it. So if Professor Olatondi can send his email also in the chat, so that I can register it. I don't know if he's here. Yes.
You want my email? Okay,
Yeah,
you want my email? Okay,
no, I think I have your email because you submit that.
Well, I'll be 100.
Yeah.
Okay.
Okay, I have from Rezu, and also I don't have from Olatondi, from Professor Olatondi. Maybe Taurid left already. Yes, he left. Okay, I will ask Taurid if it looks like Professor Olatondi is not near the laptop. Okay. And also, Rezu, please don't hesitate. Go on the website, asking.org, okay?
Okay.
Register yourself there. Yeah. Register yourself there so that you will be in touch for information.
Please, for our photograph will be there.
Unfortunately, the network was very bad. If not, I would say that we could take a photo, a virtual photo, if everybody put his video. But the network was very, very bad today. But
We put the pictures on the website.
Yeah, we put the pictures on the website. Okay, I will end the session. Thank you, everybody, and see you soon on the network, on the website, and WhatsApp and all. We'll make that. We'll send everything. Bye-bye.
Don't forget to. Thank you. You can stop the YouTube before you leave.
Yes, I forgot. Yeah.